And the nozzle, so as you're saying, there's a bunch of different design options, but it's a critical part of this.
Yeah.
How you do that conversion.
It's basically like how much can you convert is really like the ultimate game. How much pressure and heat can we convert into thrust? Like that's really, at the end of the day, that's what a rocket engine is.
The following is a conversation with Tim Dodd, host of the Everyday Astronaut YouTube channel, where he educates and inspires all of us with detailed but accessible explanations of rocket engines and all things space travel. This is a Lex Fridman podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Tim Dodd. Can you give a brief history of SpaceX rockets? So we got Falcon 1, Falcon 9. There's different versions of those, Falcon Heavy, Starship, and also the Dragon capsules and so on.
Well, Falcon 1 is where it all started. The original intent and the original idea of SpaceX was Elon wanted to try to get something to Mars. He saw that NASA didn't have a current Mars plan, and he wanted to go to Mars. So he decided, how do I best do this? He literally wanted to, at first, purchase a rocket from Russia. Then after a foiled attempt at doing that, he decided he was going to try to develop his own rocket. And the Falcon 1 is what came out of that process. And he developed a pretty incredible team. Like, I don't know how exactly he stumbled upon the team that he stumbled upon that quickly, but the people that he assembled were amazing. And they built the Falcon 1, which was a single Merlin engine, followed by an upper stage engine called the Kestrel engine. Pretty small compared to the things they're working on today, but that Merlin engine continued to evolve into being the power plant for the Falcon 9. They went from a small lift launch vehicle up into the medium class launch vehicle so they could provide services for NASA. That's one of the big things they first kind of hung their hat up was they got the opportunity to fly cargo to the International Space Station under, originally it was called the COTS program, the Commercial Orbital Transportation Services for NASA, which evolved into the commercial resupply contracts. And that's when SpaceX developed both their Dragon capsule, which is a uncrewed at first spacecraft that can dock to the ISS, and the Falcon 9 rocket that can take it to the International Space Station. And
the Dragon rides on, it's a thing up top that rides on the big booster thing that launches it into orbit.
Exactly. Yep. So the Falcon 9's the semi-truck, the Dragon capsule is the payload. It's the thing being dropped off basically at its destination. And in this case, the destination is the International Space Station. So they developed those relatively quickly and became a commercial success. Before you know it, they're now the number one launch provider in the world, launching more mass to orbit than anybody else, launching more frequently than countries, like the entire country of China, who's going crazy right now with launches. Granted, China beat them by 2 launches in 2022, but prior year, SpaceX beat the entire country of China. I mean, it's nuts.
And just like you said, SpaceX still beats China even this year in terms of the amount of payload that was done. So all
the mass to orbit.
The mass to orbit, right? That China had like 60 something, a couple more launches, but there was just like small CubeSat type of launches.
Exactly. Some of them were literally like 100 kilograms or something, like not large payloads.
And so SpaceX customers are different. So whoever wants to send payloads up into space.
Yes. But right now their biggest customer is actually themselves with Starlink. One of the biggest reasons they've launched so much mass to orbit is because Starlink is designed around the payload fairing and the payload capabilities of the Falcon 9 rocket. So, because they're vertically integrated, because they build their own satellites, because they're building their own rocket, they can literally design a system that's, another manufacturer might have made a more square satellite that was heavier or something. But SpaceX looked at it from a blank slate and said, here's our constraints, our payload mass constraints, our volume constraints. And they made a funky looking satellite. Things like the size of it's like a table folded up, which isn't anything I've, really ever seen before. So, but it's purpose built to fit as efficiently as possible inside their fairing and inside the capabilities of that rocket. So therefore, because they're launching those like an insane amount, dozens, 40, 50 times a year or whatever, they're just putting up insane amounts of mass. like we've never seen before.
What about the different versions of Falcon 9, so we can linger on them? What are some interesting memories to you of the different developments in Falcon 9?
The very first Falcon 9s had a square array of engines. It had like a 3x3x3 grid of their Merlin 1 engines, the 1Ds. And I think it only lasted, I don't remember if it was 2 or 4 flights before they went into this octaweb configuration where there's 8, like a ring of 8 engines with a center engine in the middle. Still in the same diameter. The rocket was, the fuselage was more or less the same, 3.7 meter wide diameter, but the actual thrust structure changed. And one of the big efficiency gains was you no longer have, a corner engine and then like a edge engine and then another corner engine. You can just make 8 of the same, kind of part of the octaweb, it's called, the same shape. And then your interchangeability and your manufacturability becomes a lot simpler. So that was kind of one of the bigger upgrades at first. And they kept stretching it. Every time they like touched this thing, it got longer and or taller and taller technically. And then the next big feature that you saw in 2014 would have been they added landing legs to a Falcon 9 rocket, which was, that was the first launch I ever went to, was actually to see, it was CRS-3, so Commercial Resupply Mission 3. And it was probably I don't remember what that was, like their 14th or 15th launch or something, like pretty early on. And people were literally laughing at the idea of them putting landing legs on it. They just thought it was stupid. They're like, why is this billionaire Elon Musk guy wasting his time trying to land a rocket? It's not going to work.
So you said the Mars planet was there in the beginning. What about the reusability of rockets? Was that there in the beginning?
I think reusability definitely, it's a necessary part of making any kind of interplanetary mission. In order to actually do that, just financially, you have to start reusing these things.
In terms of the development of the Falcon 1 and Falcon 9, how early on did the goal of reusing the rocket, having the rocket actually land, how early did that goal creep in?
I can't speak for Elon and SpaceX, but it was pretty, immediate that they wanted to try to recover. And as a matter of fact, I think the very first 2 Falcon 9 rockets and Falcon 1, I think they even wanted to try to recover using parachutes to recover the first stage. Now fast forward, almost 20 years later, and Rocket Lab's actually doing a concept like that, where they're pulling a parachute after the first stage is re-entering, and they actually are trying to recover it with a helicopter. It's going to try to snatch it out of the air. They've actually done it. They've actually done it successfully once.
How does the helicopter grab the rocket?
With this giant like drag line and a hook.
Oh,
and then it literally just like snags onto the parachute.
Wow.
And it's pretty amazing. But this is a small rocket. Their rocket's only about a metric ton. The booster is empty.
So the rocket releases parachutes.
Yep.
Like really high up. I'd love to see this.
Yeah.
It's an interesting idea. There's so many interesting ideas and possibilities. Like SpaceX basically just innovated a lot of different weird ideas just in the pursuit of making things more efficient, reusable, all of that. So basically thinking from first principles how to solve this problem. And so what you find is like you'll get all these kind of crazy kind of solutions.
And with SpaceX, they weren't even getting to the point of the booster surviving reentry long enough to be able to pull the parachutes.
Yeah.
Their mass fractions, and that varies. Every single rocket's different. All the, for instance, Rocket Lab uses carbon composite fuselage and tanks, or, same thing. And that's very, very lightweight, has really good mass fractions, and therefore their drag coefficients and things like that, they were able to survive reentry of the first stage, which is something that SpaceX wasn't able to do at the time. What the kind of the big, I think, breakthrough for SpaceX with reusing the booster is they realized we have to basically slow down before we hit the atmosphere. So they actually do what they used to call a reentry burn, which I still think is the correct term because it is re-entering the atmosphere, but now they call it the entry burn, and they light up 3 of the 9 Merlin engines. Not only to slow it down, but actually even while those engines are firing, it creates like a literal like force field as it's falling through the atmosphere.
Oh, interesting.
And but it also decreases the velocity by almost half, or around half, and then that therefore decreases the amount of the biggest thing with the atmosphere is that as it gets compressed against the front of anything flying through the atmosphere, the compressed atoms just get hot. And they can get so hot they turn into a plasma, and they get so hot they can just absolutely destroy anything. So they slow down enough that the air molecules don't end up, destroying the vehicle on reentry. And then they realized, I think at some point there's probably a similar crossover. They're like, well, if we're lighting the engines already to slow down in the atmosphere, we can just use that same engine to land.
Mhm.
And so like, well, what if we just stuck landing legs on it and just landed the thing vertically? And next thing you know is December 21st, 2015, they did exactly that for the first time. They landed.
So you were there before that then, right?
Yeah. Yep.
In 2014.
Yep. Early 2014. So that, and for me, like that was so fun watching, that was like the peak of me just becoming obsessed with this idea. I'm watching with like, and back in the day, it was like months between launches, so a launch was like a big idea. I'd wake up at 3 a.m. to watch this landing attempt or whatever, and every, there's CRS-4 almost landed, CRS-5 almost landed, CRS-6, CRS-7 blew up. I was watching that on, I think it was like a Saturday morning or maybe a Sunday morning. And I remember watching that and watched it blow up. And I was like, oh my God, now what? And it blew up on ascent. It was their first failure. So it was their 18th flight, I believe. CRS-7, the upper stage, had one of the there's bottles inside the tanks that are filled with helium, and one of those bottles broke off on ascent and actually just completely overpressured the upper stage, and the upper stage blew up, and the whole rocket went kaboom in an uncontrolled manner. And so then they came back with vengeance. And when they came back, the first mission back is the first time that they landed a rocket, which was awesome. So the return to flight after the anomaly was landing a rocket
and stuck the landing.
Yep.
Actually, the first time. So the first time you were there, what was that like? What do you remember from that day?
Just, I was surprised at how much bigger the rocket was than I imagined. I originally, when I was going down to Kennedy Space Center, I was disappointed that I wasn't seeing like I didn't know a ton about rockets. I knew enough to like know what a space shuttle was, what like the Saturn V was, but that was probably about the end of my knowledge. I just remember being disappointed that I wasn't seeing a big quote unquote NASA rocket flying. I was thinking in my head like, oh, I'm going to see this launch. It's probably going to be like, 3 stories tall or something, just some little skinny little stick and some little firecracker and yay, and I think I'd almost been pitched that too. I think the people that I was working for at the time, I think they kind of were downplaying it as like, well, it's not a big rocket, so it's not going to be that exciting, But we get out there to the pad and I'm like, this thing's huge. This is not a small rocket. Like it's 70 meters tall, 220 feet tall. It's huge. And I think people forget like the scale of that, It might look skinny and tall and all this stuff, but it's still a very, very large piece of machinery. It's physically about as large as you can ship. The booster is about as big as you can ship across the country, period, without like completely shutting down highways. It is made within those exact specifications of like having, lane privileges and bridges and everything. It's, 12 feet wide, 3.7 meters wide, and it's 45 meters long. So it's like exactly what you can fit with a pretty standard, like before you start getting into crazy amounts of problems shipping the rocket. And it's huge. It's huge. And people just don't understand that. And so when I saw it with my own eyes, I remember just being like, this is so much cooler than I thought.
Is it hard to believe that thing is going to have to lift off the ground and launch up into the air? Maybe that's the most humbling aspect of it. That something that size, humans have come up with a way to take something that size and launch it up into the air.
Yeah, there's certainly a very humbling aspect when you watch it actually leave. And
was there a sound to it? Was there like a feeling? What were the different experiences that you first remember?
Well, ironically, I didn't end up getting to see that one fly.
Oh,
I went home. My camera saw it. I left my camera out there, like a remote triggered camera. My first images as a launch photographer at the time was CRS-3, but I went home. It scrubbed too many times. Now, this is back in the day. They were scrubbing like often, and there'd be like a 3-day, 5-day, 7-day. You just never knew. So I go home and I watched the live stream of it. So I didn't even get to experience my first launch. And anyone that's ever tried to go to a launch can probably empathize because scrubs are very common in the spaceflight world. So that one I didn't get to see. But since then, obviously, I've been able to attend very many launches.
How much do you understand the control involved in the landing? How difficult is that problem?
I couldn't tell you a single thing about like the code and like the avionics behind it, but I can tell you all the hardware that makes it happen, if that helps.
Well, to me, it seems like whenever I talk to people, they say it's not that big of a deal in terms of the level of intelligence in the control. But to me, it's just like when you observe it, it seems incredible because of all the variables involved, all the uncertainties involved, all the because there's aerodynamics. I mean, like there's different temperatures. There's so much going on with the fuel, the burning, the combustion, just everything that's going on to be able to perform control at such high stakes effectively, like, that code is probably not written in JavaScript, I guess is what I'm saying. Anyway.
Actually, no, I don't. If I remember, again, this is well outside my domain. But they're coded in a common language. It's
probably going to be C.
Yeah, I'm pretty sure it is. And that was one of the things that was weird is that Elon, when he started SpaceX, was like, we're just going to code in the most common language so that we don't have to like have people learn this archaic, weird thing, and we can just literally pull people off the streets and be like, here, write it, and
it's probably C++. I mean, it'd be epic if it was like Python or something, but I think like reliable systems have to be written in C++ probably, which is a common language, which is something I imagine like NASA engineers would probably have to use some kind of proprietary language in the olden days for security, for privacy, all that kind of stuff.
Well, in the old days, like they were inventing code and language from scratch. Sure.
But it's still incredible that it's able to do that. Like, just the feat of engineering involved is just it's truly, it's like one of the marvels to observe about these rockets coming back to Earth, that they're able to land. Like, the drama of it is just incredible to see.
Yeah, well, the one of the fun things to remember too, specifically with the Falcon 9 and the Falcon 9 or Falcon Heavy boosters, I mean, it's the same thing basically. They shut down all but one of the 9 engines, and even with that one engine at its minimum throttle setting, it's still too much thrust to hover. So as this rocket's coming down, if they start a little bit too early, if they light that engine too early, it will actually stop above the ground and will not be able to lower itself. It will literally stop, like, say it stopped 200 feet above the ground. Their only option is to kill the engine, and then it's just going to fall those 200 feet. So it's what we call like a suicide burn or a hover slam, kind of interchangeable terms, because your thrust to weight ratio is never below 1. Yeah. So they have to actually literally be riding the throttle. So what you do is you kind of start, ideally, you kind of start like in the middle of your window of throttle range. So let's pretend your engine can throttle down to 40% of its maximum rated thrust. You might start at like 70% of thrust in the middle of that like window of where it could burn. So if all of a sudden it's kind of coming in too hot, you have room to throttle up. Mm-hmm. If you're coming into, you're actually, a little too early, you throttle it down. You have a little bit of wiggle room. And it's just amazing how smoothly and how perfectly they're able to still control that thing, even though they're down to one engine out of the 9, and they're still riding like the finest margin of what's possible. And they're continually playing with that to try to get it, because every bit of fuel they're using and propellant they're using to land is propellant they weren't using to put something into space.
Yeah.
So they want that to be as efficient as possible. So they're really like watching them hone that in and just continue to evolve and edit that and just get it to be the workhorse. We're coming up on 100 consecutive landings. Perfect landings, 100. I think they've done like 150 something landings altogether, 160 altogether. But we're talking like in a row without blowing up, which at the 5 years ago was completely experimental and insane. And now we're coming up to the point where we're 100 in a row. It's like this is becoming more reliable in the landing, which is not the primary mission. This is purely for SpaceX's like gain, is to recover the booster. It has nothing to do with the effect of getting the payload on orbit, most of the time. And the landing is really only for their benefit and their gain.
Long-term gain. Like, it's a long-term investment in being able to recover the boosters.
100%.
Can you believe all this was done in basically 10 years? So we've seen this development over a period of 10 years.
Oh, man.
So like where we started commercial space flight at scale to today, where it's almost starting to be mundane.
Yeah.
What Falcon 9 is able to do.
Yeah. I can't really believe it. I mean, obviously, even just in the, I think I'm a fairly fair weather fan, really didn't start paying attention until like 2014.
Yeah.
And just seeing what it was like back then to what it's like. I don't watch every launch at all anymore. Like, I'll catch the big ones.
Yeah.
I'll stream some of the really big ones. But like back in the day, like I said, would wake up in the middle of the night to catch these streams or, catch these launches and watch them because they were such a big deal. And there's maybe only 5 of them a year, And so it's a really big deal. Nowadays, it's like, oh yeah, and there's literally like 2 a week on average now. It's insane from SpaceX alone, let alone, United Launch Alliance, Rocket Lab, any of the Chinese missions, I mean, there's countless. It's insane. It's hard to really, really, really hard to keep up with.
I wonder at which point in the future the number of launches to orbit will exceed the number of launches of airplanes like on the surface of Earth.
Yeah, I have to admit, I kind of have a hard time extrapolating out that far. There's a lot of people that are like big futurists and really do think about like interplanetary stuff and think about colonizing Mars and stuff. I have a hard time predicting like when Starship's going to fly, the orbital launch, and that's like imminent-ish, like month or two scale time frame. And yet I'm still like, I can't tell you when I can't tell you anything about like when we're going to land on Mars or what that economy and what that, the scale of launch operations is going to look like in order to do that, because it's just so hard I wouldn't have predicted where we're at today 5 years ago. It's insane. It's so hard to predict. And yeah, but it's funny because there's so many like new companies starting up trying to predict that. And it's a really exciting, startup culture right now.
I think when you make certain engineering decisions and hiring decisions and like what you focus on in terms of both business and engineering, it's good to think on the scale of 10, 20, 50, 100 years. That's one of the things that Elon is exceptionally good at, which is asking the question, okay, this might seem impossible right now, but what's the obvious way to do this if we look out 20 years? Mm-hmm. And then you start to make decisions. You start to make decisions about robotics, about brain-computer interfaces, about space travel that make a lot of sense when you look at the scale of 10, 20, 50, 100 years, and don't make any sense if you look at the scale of just months. So, but of course, the actual work of day to day is focused on the next few months because there's deadlines, there's missions they have to accomplish. Anyway, we returning back to the brief history of SpaceX rockets. The Falcon Heavy. So what else is there? So we talked about Falcon 9 and the rapid development there. Yeah. What other flavors of Falcon is there, and how does that take us to Starship?
Yeah, realistically, the Falcon 9 evolved more or less, kind of like just got more powerful and a little bit longer and more capable. But nowadays they fly what's called the Block 5, even though it's like the 8th or 9th iteration of the Falcon 9, but they call it Block 5. It's the one that has the black landing legs, the black inner stage. They have a fleet of roughly 10 or so that are doing the majority of the legwork these days. And they're flying, up to 15 times, I think right now is the current booster leader. They're also recovering the fairings, so the nose cone of the rockets are frequently, if not every time, being recovered. Same with the booster for the most part. And the only thing being expended is the upper stage. And that's kind of where the Falcon 9 is ending. It really doesn't make sense to develop that infrastructure any longer. So they went with the next step, which is go even bigger physically. So they have more margin for upper stage reusability. And that's what we see with Starship and Super Heavy. So the Super Heavy booster, the whole system is confusing. The whole system's kind of considered Starship. But technically the Starship is just the upper stage, which is also like the spaceship, which is also the upper stage. Mm-hmm. And then the booster itself is considered the Super Heavy booster. And that's what they've been working on. Publicly, it came out in 2016 as at the time it was the ITS, the Interplanetary Transportation System. Later, and I think by the end of that year, 2017, it kind of became known as the BFR, the big Falcon rocket.
Yes.
Yeah. And then I think it was about end of 2018, they started calling it Starship. But that is where we're at today, and that's what they're working full steam ahead on.
And what about Dragon? We mentioned Dragon, Crew Dragon, Cargo Dragon.
Yeah. So they went from the cargo version of Dragon that flew about 20 times successfully to the International Space Station, except for that one CRS-7 where the rocket blew up in the capsule. Obviously didn't make it to the ISS. Then they went into the Dragon 2, which has two variants. It has a crew variant, so we just call it Crew Dragon, and then there's the cargo version of Dragon 2. And that's just an updated, sleeker, sexier version of Dragon, and it's ironically it's heavier altogether. So you'll never see those cool return to launch site landing, the boosters coming back to land for CRS missions anymore like we used to. But they landed on the drone ship anyway, and yeah, that's been flying successfully. And that's kind of there's Starlink, Dragon, Falcon 9, Falcon Heavy, and Starship system is kind of the whole SpaceX world, really.
In terms of the spaceships involved. So what to you are some of the major milestones in that history? We kind of mentioned a few.
Yeah.
Sticking the landing. Is there something that kind of stands out?
Yeah, I would say definitely the big ones, obviously, like any of the first, like the first flight of Falcon 1, first flight of Falcon 9, first time they went to the International Space Station, the first time they landed a booster, the first time they reused a booster, which is, I think, about 6 months after. No, it was a year after. It was SES-10. 2017. It was the first time they reused one of those boosters, and that was a big milestone. Like, can we even? Yeah, we recovered one. We caught one. It's like we got one. Now what? That was the first time they reflew one. Then flying humans was a huge one. DM2, Bob and Doug for NASA.
Bob and Doug, yeah.
Bob and Doug, baby. That was incredible. That was a huge step, I think, for SpaceX, was flying people.
So it's first major commercial launching of humans out into space.
Yeah, and not just into space, because there's been people that have done space flights with like suborbital hops, but going into orbit, and especially docking and rendezvousing with the International Space Station it's a big deal. It's a whole until you really understand the physics involved and the scale involved of like just crossing the Kármán line, going straight up versus going into orbit. Like, they're just completely different things almost.
What about Starship? Are we in a place where we can talk about milestones with Starship? Has there been, or has it just been an epic journey of failure and successes of testing and so on? Was there what would you classify at this point as a milestone that Starship or BFR or whatever the name is was able to achieve?
Well, so far the milestones we've seen, I'd say the first one would be the hop of, they call it Starhopper, and it's basically a very rudimentary rocket. But it was the first time they utilized their new Raptor engine to produce thrust to fly something. It first flew literally 3 meters off the ground or something, like tethered to the ground. Then it flew like 15, and then finally it flew 150 meters. And that was in 2019. And that was the first big milestone of Starship. And then after that, we saw SN5, SN6 kind of do the similar, like 150 meter hops with a little bit more elegant systems, proving out more of their tank building, proving out more of their, a lot of just subsystems. And then the big ones physically were in end of 2020 and early 2021 when they flew the SN8, 9, 10, 11, and 15.
What does the N stand for in SN?
I think just serial number or Starship number.
So number. SN, these are just names, numbers, numerical representations of the different testing efforts. They skipped some numbers, right?
Yeah.
If they scratch a test.
Yeah, and lots of times it'd be like literally they're building, because at Starbase and what SpaceX is working on, like the one foot is always in front of someone else's foot, and like the arm is not knowing what the leg is doing sometimes.
Yeah.
They will have someone working on, they'll just be like, hurry up and build 40 of these tank sections, and you build the bulkhead, and you build the downcomer, and you build the header tank, blah, blah, blah. And all of a sudden, like, oh, we actually evolved that. We don't use that header tank now. So it's going to go onto this one. So they'll have like parts of certain rockets built, and it's like, literally scrap it. Like, not scrap it like in the, joke term, but like literally just go scrap it. And they just evolve and iterate so quickly.
There were some epic explosions. I think Starship, something about it, probably just the amount of fuel, just leads to some epic failures.
Oh yeah.
Probably. Yeah. Would you say Starship is the source of the most epic failures in terms of size of explosion?
So you can literally measure it in like a yield of explosive power, like you could TNT. Like you can take a look at how much propellant is left over at the time of the explosion. And Starship, what's flown so far, even though it's physically one of the largest flying objects ever, just with the upper stage alone, they've not filled it more than like 10 or 20% full of propellant.
Yeah.
And so it actually hasn't been, the failures have been really epic looking, big visual fireballs. But in terms of spaceflight, they're still pretty small explosions, believe it or not.
They could still go bigger.
Oh, yeah. A lot.
And of course, the test payload of a Tesla Roadster was launched. I forget what year that was.
Yeah, that's 2018.
That was quite epic. Would you put that on a milestone?
Oh, yeah. Falcon Heavy demo was like definitely a big milestone. Yeah.
Is that funny to you that there's a Roadster floating out there?
Yeah.
Do we know the location of that Roadster at this point?
Oh, yeah. Where is roadster.com?
Yeah.
Oh, yeah.
Is it orbiting something?
Yeah, it's orbiting the sun. So it's orbiting the sun. And its orbit is basically between the Earth's orbit and beyond Mars. So I think of like 2.5 AU, if I remember right. So it's beyond Mars's orbit at its highest point, and it's back at Earth, kind of at its lowest point.
I wonder if there's a mission where you're going to somehow connect with it once again and like place extra things into it. I wonder how challenging that is technically.
Oh yeah, it could absolutely be done. The hard thing at this point, because it's on an eccentric orbit, would be rendezvousing with it, because you kind of have to be in alignment with its orbit to really line up well with it.
Yeah.
But yeah, I mean, someday I don't see any reason why we couldn't at least send for sure an uncrewed, if Elon wanted to just fly a robot out there to check up on it and photograph it or something, like that could be well within the realm of things.
Get an Optimus robot up there. So that was the story brilliantly told by you of the rockets for SpaceX. What about through the lens of engines? Can you give a brief history of the SpaceX rocket engines that were used that we haven't covered? So you mentioned all started with the Merlin engine and a Kestrel engine. What, through that lens,
Yeah.
what's there?
Engines are relatively small number, which is easy for us. There's the Merlin, and Merlin's evolved throughout time to be from like the Merlin to the Merlin 1C to the Merlin 1D to the Merlin 1D full thrust and all these other kind of tweaks of the same architecture. Kestrel ended with Falcon 1. They also have the Merlin vacuum engine, which is the upper stage engine for Falcon 9. Same relative system, but just optimized for vacuum, so it has a much larger bell nozzle. There's the Draco thrusters, which you kind of can consider engines. Well, they are rocket engines, but they're just small. They're not like the orbital engines. There's these Super Draco engines, which are the abort thrusters on Crew Dragon capsule. And then nowadays they have the Raptor engine and the Raptor vacuum variant. But they've already had two versions of Raptor. We've already seen kind of the Raptor development engine. We've kind of seen like a Raptor 1.5, whereas kind of taking hints of the future Raptor, but now we're well within what you'd consider a Raptor 2 variant. And that's really it.
Yeah, for the Raptor. Maybe I'll ask you that separately, but I like in general, and people, who doesn't know who Everyday Astronaut is? But if you don't somehow know, go check your YouTube channel out. You're an incredible educator about the super technical and the more sort of even the philosophical, the actual space travel. So you go down to the raw details of it, and there's just great videos on the Raptor engine. I think you have one on Merlin, and also actual tours with Elon where he discusses some of those things. On one of the tours, he says he's full of good lines. That guy. He says something about the number of fiddly bits, and he's the number of fiddly bits was decreased between Raptor 2 and Raptor 1.
Yeah,
and I think that's actually a really beautiful representation of the engineering efforts there, which is constantly trying to simplify.
Oh yeah.
Increase the efficiency of the engines, but also simplify the design so you can manufacture it. And in general, simplification leads to better performance and testing, and everything. So the number of fiddly bits, I'm sure there's a Wikipedia page on that now as an index, is actually a really good one.
Well, and when you think about it, I don't know of any other company prior that had kind of tried to measure their performance of their engine, not in like thrust to weight ratio or like how efficient it is, like in specific impulse, but literally in like dollar to thrust ratio. Like how much does this engine cost?
Yeah.
How much thrust can it produce? And like using that as a trade study instead of just like pure metrics of, because at the end of the day, like, okay, if it's cheaper and does, X amount of work, even if it's less efficient, it can actually be better long term.
And so I guess another way, it's not even just thrust. I don't know if that metric is used, but basically the cost of getting 1 kilogram of thing up into space.
Yeah.
That's basically what they're trying to minimize.
Especially,
right?
Yeah.
Like,
at the end of the day, that is definitely the ultimate metric, is how much does 1 kilogram cost to orbit eventually, but it's so funny because spaceflight is just the ultimate, it's the ultimate compromise. Every little thing, any variable can just change everything else. So you can tweak so many different things to get to different numbers and conclusions, but even things like on your first stage, when the rocket's pointing straight up and the engines are pointing straight down, you're dealing more with the thrust to weight ratio of the rocket. So how much thrust is it producing versus how much is gravity pulling down on it is actually a more important metric than how raw efficient the engine is. So it's funny. Then in space, it's kind of the opposite. Thrust to weight ratio doesn't really matter. What really matters is the specific impulse, it's called, or like the nozzle escape velocity or the ejection velocity of how fast is the gas moving is like the more important number on orbit. But it's just so crazy because there's all these, like, I would just love to see the trade studies, when you're like trying to figure out, like, is this more important than this or this or this? And it's like, you change this one little thing and all of a sudden, like everything changes. It's just, even the profile, like the launch profile, the trajectory of it, everything. everything.
I wonder what that trade-off discussions are like, because you can't really perfectly plan everything. So, and you always have to have some spare leeway on especially as you're testing new vehicles like Starship.
Yeah,
so
margins are important.
Yeah, having a margin given all the uncertainty that's there. Yeah, it's really interesting, like how they do those kinds of trade-offs, because they're also rapidly designing and redesigning and re-engineering, and the ultimately you want to give yourself the freedom to constantly innovate, but then through the process of testing, you solidify the thing that can be relied upon, especially if it's a crewed mission.
Yeah.
How to do that in a rapid cycle.
I remember at some point that NASA, as they're leading up to flying humans for the first time for NASA, there's some talk that like we're going to do a design freeze because SpaceX does evolve and iterate so quickly. Mm-hmm. They were saying that it was leading, because especially at the time, it was a mission called Amos 6, and they lost a rocket. They've only lost 2 rockets, like ever really, as far as trying to get something to space for the Falcon 9. Sorry. And the second one, Amos 6, I mean, that was back in 2016. So it's been a long time. And, but at the time, they're looking at flying humans in the near future. And it's like, if you guys keep tweaking this thing every time you take it out to the pad, well, there's going to be a problem, And so there is some pressure from NASA to kind of slow down on that iterative process. And, but that is also why they were able to evolve the Falcon 9 to be what it is today, is because they did just evolve it so quickly. Literally, like one after another was never really the same. And we're definitely seeing that with Starship now. Like it's evolved so quickly that you just can't even keep up with it,
So there's a fascinating culture clash there. Have you, just in observing and interacting with NASA folks, seen them sort of grow and change and evolve themselves, sort of inspired by this new developments in commercial spaceflight?
Oh, yeah. There's a lot of, especially like around DM2, there's a lot of talks and the press conferences and stuff where you'd hear people say, this is well outside of our comfort zone to work with SpaceX in this manner, because we take this approach to things. We're X, Y, and Z in this way, the way we normally certify things. And we're not used to SpaceX like, well, let's just try it, and do something, to a point. And so they said it ended up being fantastic. They loved working that way because it was just less paperwork almost and more just do. But at the same time, SpaceX, I think, even expressed, I don't remember if it was Hans Koenigsmann or someone in a press conference said, well, we really liked having someone just double check us so that we're not doing something super stupid right before we test something, Yeah. So there was a cool collaboration, because it is 2 very different philosophies of development and managing, space programs.
I wanted to talk to you a lot about engines, and maybe about Starship, and maybe about your own becoming an actual astronaut. But like, let's just go there before all that, and talk about the actual culture of SpaceX and your conversations with Elon. You've toured SpaceX facilities with him. You've interviewed him. You've interacted with him. What have you learned about rockets, about propulsion, about engineering, about design, about life from those interactions? He's pretty transparent, open human being, as an engineer, as a leader, as a person.
I would definitely say the biggest takeaway I've had from my times with Elon at SpaceX is really like the idea of questioning your constraints. He says that a lot, but he also does it a lot. Like there'll be times where like you'll see him change on a dime because he's like rethinking of something in a new or different way. And for me, I think we all put constraints on ourselves. We think about our own limits, on things that we can or cannot do. And I think it's made me kind of question, like, well, why did I say, no, I can't do that? Or, just off the top of my head, a good example. So in Iowa, I live in Iowa, or half the time or whatever. And there's a bike ride across the state of Iowa called RAGBRAI. And every year you just, like thousands of people get together and they ride across Iowa. And it was last summer. I met up with some friends and they're like, hey, do you want to go on RAGBRAI this year? I'm like, it's like a week away. They're like, yeah, you want to go? I'm like, yeah. And so I did, and it was one of those moments where I was proud of myself, because it's like, it's easy to just be like, no, I'm not ready, or this is my constraint is like, I'm not in shape. Mm-hmm. but like just question that, and so I think when it comes down to questioning your own constraints, it's even to that level of like, why do you question yourself on what you can and cannot do?
So that's for your personal life is really powerful, but a little bit more intuitive. I think what's really hard is to question constraints in a place like aeronautics or robotics or autonomous vehicles because there's experts everywhere that have done it for decades, and everyone admires those experts and respects those experts. And for you to step into a room knowing not much more than just what's in a Wikipedia article, and to just use your intuition and first principles thinking to disagree with the experts, that takes some guts, I think.
Well, you can't have everyone doing that either. Like there has to be some humility of knowing that something is a hardened concept and a hardened, like especially I'm not an engineer. I don't do this stuff, but I can imagine you sitting there having spent 6 years on a type of valve that perfectly manages cryogenic propellants or whatever, and someone walks in and says, "Why don't you just put a heater element in there?" Or something that's, something like because we've tried, we've done that 40 times or whatever. Like I'm sure there are things like that are very frustrating, but
see,
I don't know what that's like.
The thing is, with the experts, they're always going to be frustrated when the newbie comes in with their first principles thinking. But sometimes that frustration is justified, and sometimes it's not. Sometimes it's just stubbornness for failing to acknowledge a better way. And I've seen it both directions, so which is really interesting. So you need both, but that tension is always going to be there, and there has to be a almost like a dictatorial imperative that breaks through the expertise of the way things have been done in the past to push forward like a new way of doing it. And Elon's done that. I've seen a lot of great engineers do that. In the machine learning world, because there's been so much development, I've seen that happen. Usually when there's like rapid development, that starts to come into play. And I've seen that in autonomous vehicle space, brain-computer interfaces that Elon is involved with, all of it. It's kind of fascinating to watch. What about the actual design and engineering of the engine? Since you've learned about so many different kinds of engines over the past few years, just like what stands out to you about the way that engineering is done at SpaceX, or that Elon does engineering?
The hardest thing to kind of remember is like how much stuff was developed in the 50s and 60s. The concepts finally being utilized today were already literally done in the 60s. So a lot of the things that SpaceX is doing isn't a novel concept per se. They're like, for instance, the Raptor engine utilizes the full flow stage combustion cycle engine. And that was already developed by the Soviets in the 60s for an engine called the RD-270. And it makes sense. Like on paper, 100% it makes sense, because you're basically extracting the absolute maximum potential of the chemical energy in both propellants. And, at the end of the day, like you have to be dumb enough to say, we're going to try using this thing because it's actually really complicated to do what they're doing. But at the same time, like so are rockets. Like rocket engines are already stupid complicated. So adding, 10, 20% more, pain in the butt during the R&D, if it's, in the long 20, 30 year existence or whatever, like future of that engine, is that going to be worth it? Obviously, SpaceX said, yeah, I think we can actually develop this Raptor engine. So it's just interesting to see the things that have been looked at, or even reusability. Like the space shuttle was reusable. It was fully the upper stage. The shuttle itself, the orbiter was, that thing was, for all intents and purposes, a reusable rocket. Now, did it live up to its expectations? Not necessarily. So it left a lot of bad taste in people's mouth on the ideas of reusability. So for SpaceX to kind of come back into the room and on the table and say, we're going to use a reusable rocket. Specifically, we're going to do a fully reusable rocket. A lot of people are, even still today, a lot of people are going, yeah, you're not going to be able to do that.
Even today. So long term, you're not going to be able to reuse at scale.
Yeah. But definitely, I think the number of people that are saying that today is a small portion of those that were saying that type of thing 5 years ago. When Elon did that announcement in 2016 for the ITS, it was very, very aspirational, and people were just like, yeah, right. And there's a large number of people that had the factual reasons to think that and do that. At the time they'd only landed like 2 rockets or something, when they did that, or maybe 3. It was a very small number. When they announced that actually they had just lost a couple months prior, they just lost Amos 6. So they were still this young blossoming company, and to come in and be like, we figured out reusability and now we're going to go full scale and make the world's biggest, most heaviest, most powerful rocket ever. And we're going to fully reuse it. And it's going to go to Mars. It was just pretty out there. Like it really was. And it's all about perspective. But now, again, we're coming up on 100 consecutive landings of an orbital class rocket that's, 45 meters tall, 3.7 meters wide. Like this thing is huge, weighs 20 metric tons, even empty when it's landing. That thing's already huge. So seeing the success of that, I think people are now more like, well, okay, maybe there is actually the opportunity to be fully reusable. That's definitely probably the biggest constraint that I think has been questioned. That is
reusability.
Yep.
And then, of course, like the broader one of cost, of bringing down cost, that you're able to kind of bring down costs so much that something like colonizing Mars or many trips to Mars will be a possibility. People don't even, that seems so far out that they don't even have time or give effort to questioning it.
Yeah.
But it's the implied questioning. Can you really do that many launches?
Actually do it.
Can you actually do it? Yeah.
It's looking, I think it's one of those things where you look at the curve, you look at like 10 years ago, that was ridiculous.
Yeah.
Following this curve, if SpaceX goes from, 2 years ago launching, I don't remember what it was, 40 times to 60 times to 100 times this year is their amount. And if we just keep extrapolating that out, if they, maybe not that exponential, maybe it goes more linear or whatever, what's 20, 30 years, like the amount of stuff we can put on orbit and the potential we have to do things, like absolutely. Now, I don't want to put a time frame, I think, but you got to think we're increasing the number of launches. We're increasing the amount of things in space. We're increasing the amount of payload on orbit. That's probably not going to decrease anytime soon. And therefore, eventually, like the idea of going to Mars is absolutely reasonable.
Let me ask a difficult question that needs to be asked here. Can SpaceX continue its successes without Elon? This long-term mission to Mars. I think the discussion about Tesla and autopilot or robotics or Neuralink with brain-computer interfaces is a question wholly separate from the SpaceX question. Because there's a lot of other competitors doing some different but amazing engineering that Tesla is doing in both autonomous vehicles, semi-autonomy or full autonomy, and obviously in vehicle design and electric vehicles. There's a lot of people that are doing incredible brain-computer interfaces. But while there is a lot of competitors to SpaceX, and we'll talk about many of them, they're doing amazing work, it seems like he's really driving progress here over the past 10 years. What do you think about that?
Okay. The first thing I think to remind people is just how many brilliant people do work at each of these companies, obviously.
Yes.
Elon's had some of the best teams assembled ever. Just incredible people. He knows this. He will gladly tell people, and he says it often, like the amazing people, the amazing teams here. So it is important to remember that. That being said, like there is something to Elon's just super far forward, not taking no for an answer on things approach that, and almost to his dismay, I think he is afraid of the sunk cost fallacy so much that it almost gets to the border of like being, like throw out everything before it's even we've known it or not. But at the same time, like it moves the needle so fast, so far. So as far as the question of would SpaceX continue to like succeeding and be able to ultimately go to Mars without Elon, the Mars thing I think would probably be hard to uphold without it. I think a lot of that drive for Mars is from Elon. It is maybe too fantastical for the average person and the average employee and maybe the average CEO that might step in to have a company's mission be to go to Mars. Like it's just,
or even governments.
Yeah.
Clearly, because like you said, the Mars plan was non-existent for NASA.
Yeah. Still really, there isn't much, So I think if...
And how many people, and sorry to interrupt, how many people are talking about it's obvious that we need to become multiplanetary?
Right. There's not... There's the Mars Society. And
Like serious
Yeah.
leaders of engineering efforts
Yeah.
or nations and so on.
yeah,
Which it does seem, if you think about it, that it's obvious.
yeah, in the grand eventuality, it is obvious.
Of human civilization, this whole human experiment we have here, we should be expanding out into the cosmos.
100%. So I think the big mission, if we're measuring SpaceX's success on getting to Mars or not, I think they'd have a really hard time continuing to fulfill that drive without Elon at the helm. Now, I think there's a certain balance and beauty of Elon, specifically when it was Tesla and SpaceX, where Elon will go in, have mild tornadoes around the factory and the engineering, and like mix everything up and things get sometimes just totally thrown together, and totally just like get it done just to get it done and start moving in that direction. And then he'll leave and go do that same thing, at SpaceX or Tesla, vice versa. And then there's a little bit of a calm where people come back in and they fill in those gaps, and I think that's kind of always been a pretty healthy thing, honestly, is like, I think if he is too focused on any one thing, it almost is like he'll spin too much, like it's like
too many tornadoes.
Yeah, too many tornadoes. and I think it could almost be like, you need someone to come back in and like backfill almost. Because I've heard definitely stories of well, probably a good example would be last was that last year or 2 years ago? 2022, yeah. Was that, yeah. Or no, 2021, they did the first full stack of the Starship Super Heavy. And they called it the big surge. All of a sudden, like thousands of SpaceX employees, came down to Starbase and they just started building like you wouldn't freaking believe. I mean, it's just things going crazy. Beeping. It was actually in the middle of that first interview I did with him, was in the middle of that surge. There was like commotion like you wouldn't believe. You couldn't hardly talk because there's just so much going on. People just welding and blah, 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 Everything they did during that period was basically scrapped because it was just not done very well. But they got a fully stacked Starship rocket out on their launch pad, and I think at some point you kind of have to stabilize some things enough and just say like, this is what we're doing to catalyze some things and say, now do this. It's almost like do it for fake, now do it for real almost.
It's funny because through that time, because I had a lot of conversation with him, I think that process was hugely stressful. There was a sense, I don't know where that sense is today, but there's a sense that Starship is going to be very hard to pull off.
Yeah.
That's still borderline impossible to pull off. And that was really weighing heavy on him and the team and everybody.
Yeah.
So like to have this chaos of development is fascinating.
Yeah. Big time. And I think they really had to push, if they hadn't done that big push, we might only be now seeing a rocket stacked for the first time. It might be a lot more finished rocket, a lot more high fidelity, a lot more flight worthy rocket finished and stacked. But and they might not have to walk stuff backwards. But at the same time, like you do have to in this world, you do have to push really hard to make rapid iteration and rapid change and progress. So it's interesting. I don't know.
So lingering on that, another question I really should ask you because of you've been in awe of the amazing development of space travel technology over the past few years. What do you think about Elon buying Twitter? So in this perfect balance, optimized reallocation of tornadoes throughout the various efforts in human civilization, do you worry about his involvement with Twitter?
I mean, personally, I see that as a lot less important than, and personally for me, inspirational than Starship and, the work done at SpaceX and Tesla. To me, those were two very impactful and really, really just generally like, they uniting, like, something to rally around, get excited about, rally, and just like a future to look forward to.
Yep.
The idea of we're going to be building the world's most powerful, biggest rocket ever, and it's eventually going to be able to get humans on Mars for the first time. And we're going to transition the world into fully sustainable, awesome, just totally badass cars that do all these cool things. To me, those were like, that brought a sense of unity and a sense of like, we can do this. Personally, I just don't think that a social media, no matter what it is, I don't see that in a social media, and I don't see any sort of politicking as ever anything that's really ever uniting thing.
I understand that. I totally agree with you, especially with space, how inspiring it is. I have to push back. I do think the impact of social media, the basic level of meaningful connections of this collective intelligence that we call human civilization through the medium of digital communication, which is social media. I think that can have a huge impact. It could be the very vehicle that increases the inspiration that SpaceX does, and all different. The thing I've criticized them a bunch for is like, why bring politics into this? So the political divisions that we see on Twitter, feeding them is tricky. It's tricky to sort of understand what is the value of that, what is the contribution of that to this whole effort we got going on. So that's been a big challenge. But that said, like, again, this tornado, the number of tornadoes in social media, I think is really important, because social media has such a huge impact on us as a society, and to have a transparent, have a bit of turmoil. It's like Tom Waits says, I like my town with a little drop of poison. So like a little bit of that, shake things up, I think might be really healthy. I just worry about the long-term impact on the whole Mars project through that. And so, but you know what? This life, one of the reasons it's fun is through the chaos, like none of us know how it's going to turn out, and hopefully we try to help each other to make sure it turns out well.
And this really isn't like anything about my personal like politics or anything like that, but really just generally, any of my friends that are like, the first thing you hear about them in their day is something that happened in politics, or something that some world leader is doing or not doing, or saying and not saying. I just don't find that to be the most important thing, really. I know that obviously that can affect a lot of people. That has big real world consequences. Politics do. But like, I just, and this is just me, I'm such a like, oh, come together, cheerio kind of guy, that I just really think like you need something bigger than bickering about what people said and did and what they voted on and all this stuff to really push humanity forward. Like I know that politics and by extracting that, social media can affect things like space flight and even our like planetary defense, like being able to defend ourselves against asteroids. Like if politics has their way and everything goes to crap and we don't even get to, we're not going to be able to, continue space flight and things like that. But like, I don't know. I just think there's better ways to do it, and more uniting ways to do it than what feels like immature name calling sometimes,
Yeah, I think the political bickering that most people talk about, that's on top of most people's minds, is the thing that'll be completely forgotten by history. It has actually very little impact. Yes, politics matters, but like 1% of it. I think most of it is just political bickering, the push and pull of the red team and the blue team, and the news media that feeds off the division for the attention, and it's just like a fun athletic event almost with the blue team and the red team. So 100%. That you kind of have to have a historical perspective on it. Like most things will not really have a significant impact, and we should focus on development of science, technology, engineering, which is the thing that grows the pie.
100%.
This is what the economists know well.
Yeah,
which is the innovation, the engineering. That's what actually makes everybody richer.
Yeah,
this kind of political bickering is just eating the pie,
and not just richer, but it improves their lives. We can look at every modern technology that is bestowed upon us today: air conditioning, electricity, internet access, fresh, clean water, running water, blah, blah, blah. 100 years ago, so many of the things that I listed either didn't exist or were only accessible by the ultra wealthy. And it's through the innovation of technology and engineering and education that we are able to have it be that even someone below the poverty line in most of the developed world will have a good number of those things in their life. And that's just continuing to increase and continue to get better. So I think, that's, to me, that's in the grand scheme more important, but to each their own.
Speaking of amazing technological development, You have a few videos on this, but how does a rocket engine work? You're wearing some of the instruction manuals, but for one type of it, like what's the fuel? What are the kind of types of different rockets that you can kind of give an overview?
Yeah. Ultimately, a rocket engine converts high pressure and heat into kinetic energy. Like that's the only real job of a rocket engine is to take high pressure gas, high pressure gas, very energized. There's a lot of energy involved, and then literally turning that into molecules shooting in one direction, into kinetic energy. So, yeah, what you do basically, the simplest version of it is, of course, like famously a balloon. You take a balloon, you fill it up with air, you've got a pressure, you let go of it. Some of the air shoots out in a general direction-ish. You converted that pressure into kinetic energy. Now, if you start scaling that up, you can continue to do something like that. Like cold gas thruster would be kind of the most simple and easiest rocket engine to make, would be a cold gas thruster. And all that is you literally just take air, or specifically nitrogen, because it's a little bit more dense than all the others, or, and it's the majority of our atmosphere. It's more sparse. You can condense that down, sort in a really high pressure bottle, and then just literally shoot it through what's called a de-Lavelle nozzle, which is something that chokes the flow a little bit, gets it to be, takes it and gets it into supersonic speeds. Once it's at supersonic speed, you actually can't choke it down anymore. You'll just constrict the flow of mass flow. You'll constrict the airflow. So you actually go opposite. You start making it wider. And once it's already at supersonic speeds, if you expand it and make it wider, it actually gets faster and faster. So at first, when it's subsonic gas, you start shrinking, you constrict the flow, it's actually speeding up, just like, a highway. If you go from, or any of these examples, like a water hose, if you pinch it down and you want to flow the same amount of water from point A to point B through a smaller pipe, you can flow more water, or the same amount of water from point A to point B with a smaller pipe. It just has to go faster. Mm-hmm. So obviously you can constrict it, but at some point you actually get to a physical limitation, and that happens to be the speed of sound. Once it gets to the local speed of sound, you can then actually do the opposite. You actually expand it back out, and you're continuing to convert the pressure into velocity at that point, but it's now supersonic. And what's interesting is while you're doing that, you're actually cooling it down too. Each bit of that pipe that you're making wider and wider and wider, you're cooling down. So the more heat energy you have to work with, the more work you can actually do. So at some point, a hot, high pressure rocket engine is the best source of, that's the ultimate amount of work you can do.
And the nozzle, so as you're saying, there's a bunch of different design options, but it's a critical part of this.
Yeah.
How you do that conversion. Which
it's basically like how much can you convert is really like the ultimate game. How much pressure and heat can we convert into thrust? Like that's really, at the end of the day, that's what a rocket engine is. So you have to have a powerful enough rocket engine to actually lift the rocket, and a rocket is mostly just fuel. It's like 90 plus % just the weight of fuel. So you just have to lift the fuel that's going to take it into orbit.
And that's the thing specifically for rockets. You're just saying generally rocket engines, but for the task of going to orbit, you're fighting gravity, Earth gravity, which is fundamentally different than moon gravity or Mars gravity.
Yeah.
Or like you said, traveling out into space. Earth has a pretty intense gravity to overcome.
We're lucky because I think if it was 10% either way, like 10% harder, it'd be like, we could still do it. We'd still, with our current technology, we'd still be able to get stuff into orbit. Man, things like reusability and this, commercialization, the success that we've seen in the last 10 years, we'd just be on too thin of margins, I think. 10% easier, and we would have been like, it's just like totally different. It's so much easier. It's like this big, sliding scale, and 10% in either direction, we'd be either screwed or really happy, as far as getting into space. So it's just hard enough that things like fully reusable becomes very, very, very difficult. I think it's completely achievable. We have all the pieces to make it achievable. It does not disobey any laws of physics. It does not disobey there's no hard stops to it. It's just very, very, very hard. And so ultimately, like on Earth, for the first bit of launch, again, when the rocket's pointing straight up and the engines are pointing straight down, pointing end up, flaming end down, you're fighting gravity. And so that's kind of your biggest enemy outside of the Earth's atmosphere too.
So what kind of sources of fuel is there? So there's chemical rockets, liquid, solid gas, hybrid. There's electric. So what are the kinds of fuels we're talking about? What are oxidizers? What? Can you just explain your shirt? I guess.
Yeah.
The components of your shirt.
So really, I mean, fuels. There's kind of two terms. Well, you'll generally hear the word propellant being used. It's anything that is used to propel a spacecraft or used in a rocket engine. So you have to have, you can have a fuel. You have to have a fuel, you have to have an oxidizer, and you have to have a spark to actually get those things burning. And that's just a general law of like the universe. You have to have fuel, an oxidizer, and a spark. Now, some fuels will by themselves spark, like hypergolic fuels, but ultimately you're always left with some kind of fuel, oxidizer, and a spark. So the general ones used most often in rockets, liquid oxygen is kind of the king of, well, there's better oxidizers, but they're extremely, extremely hard to work with, like fluorine. But generally liquid oxygen, so you just chill oxygen down to its liquid state, minus 183 degrees Celsius. So it can be dense enough to store in tanks. It's 1,000 times more dense when it's in a liquid than it is as a gas. RP1, which is basically kerosene, is a very common fuel. Another common fuel nowadays is methane, liquid methane. Liquid hydrogen is another. It's the most efficient, potential for the most efficient, since it's one of the lightest molecules.
So I think, correct me if I'm wrong, but the Falcon 9 uses kerosene, and then Starship uses methane, liquid methane?
Yep, for fuel. And they both use liquid oxygen for their oxidizer.
For the oxidizer, okay.
Yep. But then, if you get into hypergolics, you'll normally have nitrogen tetroxide, which is your oxidizer, and some form of hydrazine for your fuel. There's solid rocket propellants, like solid rocket boosters, and those are actually pre-mixed. Your oxidizer is inherently like baked, literally like kind of baked into the sludge of fuel.
So like for SpaceX, it's all chemical liquid fuels.
Yep.
So how many solid based fuels are there? Are they still being used today? Is there most rockets?
Yeah, and the United States really is the only ones that, I guess early on, because it was really just the Soviet Union versus the United States. The United States started to use solids pretty early on. They're simple and easy, but these days, like, you'll still see them kind of as traditionally like boosters, like they're used to just help get something off the ground or help give it a little extra boost. So the space shuttle famously had those two huge white solid rocket boosters attached to the orange fuel tank. Those are solid rocket propellants. Things like the Atlas V can have up to 5 smaller solid rocket boosters. There's very few rockets that use a pure, at least these days, that use a pure solid rocket motor for its first stage. There still are, especially in China. There's a lot of startup rocket companies that kind of use just missile technology. They might use there might just be a variant of an ICBM that just use solid rocket fuel because it is relatively easy to develop. Model rockets use solid rocket motors and stuff like that. So they're still around, but they're just not as elegant and not as used these days, I'd say.
So what are rocket engine cycles? I think getting more towards your shirt question. You have a really good video called that. A lot of your videos that are technical are just exceptionally well done. So I think you deserve all the props you get. Thank you for doing this work. Really, 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 really well done. So it's called Rocket Engine Cycles. How do you power a rocket engine? And you go through all the different options. Is there something you could say about open cycle, closed cycle, full flow, all the different variants that you can use words to explain?
Yeah, without all the pretty pictures.
Yeah, without the pretty pictures.
So ultimately, like we said, your ultimate goal is you want to get heat and pressure into an engine. So obviously at some point you can either make really thick tanks of your rocket. You can get it so thick that you store the propellants in really, really high pressures. But obviously that doesn't scale very well. At some point your rocket's so heavy you can't even leave the ground, or it's just so much of your mass is just literally the walls of the rocket. So at some point people realize, hey, we could actually just pump the fuels and the oxidizer into the engine at a high pressure and increase the pressure through a pump. Now obviously a pump's going to require energy. You have to get that energy from somewhere. And again, at some point, people were like, well, there's already rocket fuel here. We'll just use some of the energy from the rocket fuel to spin these pumps. So that would be considered like open cycle, closed cycle, full flow stage combustion cycle are ways to tap into the propellant. Actually, and then there's tap off expanders. All of them kind of do the same thing, but you end up at some point spinning a turbine. A turbine can take some of the heat energy and the pressure of an engine, and then that can be connected to a shaft to pumps, and those pumps can increase the pressure of the propellants and force it into the combustion chamber. Now, the difference between open cycle, closed cycle, full flow, all those is what happens after the gas has flown through the turbine. So after you've used the turbine and spun up the energy, spun up the engine, what happens to that gas? So in an open cycle engine, you basically have like a separate small rocket engine in a sense. It's a gas generator, they call it. And that will be used to create take a little, we'll say 10% of the propellant flowing to the engine. Instead, you reroute it to like a smaller rocket engine called the gas generator. You point that at your turbine, and that will spin your turbine up to, ridiculous speeds, 30,000 plus RPM. And then after it spins, it's wasted most of its energy, and it's just dumped overboard. That would be open cycle. You're not worrying about it after that point, but you are left with a lot of unburnt, unused fuel. A good amount of that fuel is just completely, and especially because the turbine, you have to keep it from melting. So you can't run it at like optimal ratios. Not necessarily stoichiometric. In a rocket engine, you actually don't want it to be near stoichiometric where you're releasing all the energy. You actually want to release, you actually want to be throwing out the lighter molecule so it can be shot out faster generally in the engine. So, but in order to have a turbine survive, you have to actually cool. You have to have the gas going through it. It can't be stupid hot, or else you're just going to melt your turbine. So they normally, especially in the open cycle, you just run it really fuel rich. So there's a lot of extra fuel being pumped into it that will keep the temperatures at a reasonable, temperature. So you end up with this like dark, sooty smoke pouring out of that gas generator. That's just unburnt fuel. It's just wasted fuel. It never got a chance to be used.
Oh, interesting.
Like in the combustion chamber. It's not being used to propel the rocket. It's just being used to cool down the propellant that's being used to spin the turbine, that's being used to spin the pumps to push a lot of propellant into the engine. So, it doesn't take too long before, you're a greedy rocket scientist being like, look at all this wasted propellant, all this potential energy that's just literally being spewed out the side of the rocket. So that's where the closed cycle comes in. So now you have to get that propellant, take it from basically what was being wasted through the turbine, and you're going to try pumping it back into the engine. Now, you don't literally just pump that gas that's, that gas into the engine, because it's actually way too low of pressure compared to the main combustion chamber. By that point, by the time it's gone through the turbine, it's lost most of its pressure and heat to the turbine. So if you tried pumping it into the engine, just taking that pipe and sticking it right into the combustion chamber, the much higher pressure, hotter combustion chamber would just go backwards, and it'd stall out the engine and blow up the engine and whatever, what have you. So what they actually do is they normally will send, there might be some variations of this, but the general concept is you actually flow all of your fuel or all of your oxidizer through the turbine. So that would be closed cycle. So there's fuel-rich closed cycle, which would be you're flowing all of the fuel through the turbine, or there's oxidizer closed cycle, which is where you're flowing all of the oxidizer that's going into the engine through the turbine. Now, the trick here is you have to have that turbine after it's done its work. So after it's taken some of the potential energy, some of the heat energy from, we're now calling it a pre-burner, by the way, instead of it being a gas generator, you now call that device that's creating pressure to spin the turbine. You're now calling that a pre-burner because it's just going to pre-burn some of your fuel or some of your oxidizer. The trick is that has to be, by the time it's gone through the turbine, it has to be higher pressure than the combustion chamber, because otherwise it's going to go backwards still. So you really have to get that pre-burner up to ridiculously high pressures, like at least 20% higher than your main combustion chamber. And these combustion chambers, we're talking about engines that are at, 200, 100 to 200, even in SpaceX's Raptor engine, up to 300 bar in the main combustion chamber. So that's, 4,500 PSI, basically. Insane amounts of pressure inside these combustion chambers. So your turbine has to be even above that, or your gas generator or your pre-burner, has to be higher pressure than that even in order to have the flow going the right direction through the engine. So now you'll have those closed cycles. You'll have fuel rich, you have oxidizer rich. The tricks now, you're starting to get, it's crazy. There's just so many compromises. Every little decision you have of like, oh, I did this. Now now crap, it's going to do this. For instance, fuel rich, if you ran kerosene, fuel rich, how I mentioned soot coming out of the gas generator. Well, if you run soot through your engine like that and had it go through your injectors, like back into the engine, it'll clog the pores of the injectors and it'll end up blowing up the engine. The soot itself is so damaging that you can't really run a fuel-rich kerosene engine.
What exactly is soot? So it's like fuel somehow mixed up with the smoke. Like what? I wonder what is it chemically? It's just some weird.
It's mostly just carbon. It's
Carbon.
mostly just carbon,
That dark smoke.
solid chunks of carbon, and it can cake up and just literally like it's like ash almost. At some point, especially under those high pressures and high temperatures, it can physically build up and turn into like stalagmites and stalactites of carbon, really hard, forged in a rocket engine carbon.
I wonder how you figure all that out too. Is has to be experimentation. Some of that is chemistry, like theoretical, but like you're gonna have to build the thing at scale and actually test it.
Trial
and error.
There's
many decades of trial and error,
and many pieces of engines that you're trying to piece back together, going like, "What the hell happened here?"
Yeah, what happened?
Yeah.
Okay, so that's closed cycle. So how do we get to full flow?
So in either of those situations, you're still actually just having the opposite. So if you're fuel rich, all the fuel is going through the turbine, but only a tiny bit of oxygen is actually being put into that preburner to spin the pumps, and the rest of the oxygen is actually going through the pump, the primary pump, and straight into the combustion chamber. Mm-hmm. Now, full flow, the idea is you're going to actually preburn both your propellants. Both of your propellants are going to go through a preburner, and they're both going to end up spinning one of the pumps. Mm-hmm. So you'll have a fuel-rich preburner, and you're going to have an oxygen-rich preburner. Each one of those is going to get just, they're going to heat it up just enough and get it up to just enough pressure to spin up that turbine as fast as they need to do to get the pumps up to the right pressure, mm-hmm. and still have enough pressure through the turbine to overcome the pressure inside the main combustion chamber. And they're both going to arrive, both your fuel and your oxidizer are going to arrive in the main combustion chamber as hot gases already. So what was liquid oxygen is now gaseous oxygen. What was liquid methane is now gaseous methane. And they're meeting in this combustion chamber at still ridiculously high pressures. Again, for SpaceX's Raptor engine, they're meeting at 300 bar. Insane amounts of pressure. And then they combust from there on. And because they're already a gas-gas interaction, they're happy to burn. They're ready to burn. They're ready to mingle, as opposed to having a gas-liquid interaction, which is what's a lot more normal. You'll have two different states of matter, and they just might not. They might take a little more coaxing to, what's that word?
Coaxing?
Coaxing?
That doesn't sound like that doesn't sound correct, right?
Coaxing.
Coaxing. Yeah. All right.
I don't know. We'll cut that in post.
No, we'll have Morgan Freeman overdub us.
Yeah, each of us coaxing.
The fascinating thing is they're coaxed as gases in the combustion chamber.
That word. But they just take a little bit more. It takes more time in the combustion chamber to have a liquid and gas interaction like mixed together and unleash as much of their energy as you can before it exits the system.
Are some of the trade-offs here in terms of efficiency, which is most efficient, and then also complexity of the design and the engineering and the cost of the design and the engineering? Like, what are the different trade-offs between open cycle, closed cycle, and full flow?
Yeah, it's kind of like a what's the bears, the Goldilocks, it's like you kind of generally, the easiest is open cycle. Because you're just expelling the exhaust gas, the gas generator exhaust. You're not having to worry about it. You just spin up that thing as much as you need and deal with it, right? No big deal. Closed cycles offers 10 to 15% greater performance generally because you're not wasting that propellant. But it's complicated. It's a lot more complicated, especially if you're doing oxygen rich. Now you're having hot gaseous oxygen in your engine, which just generally wants to react with everything. It's just a recipe, like hot oxygen is just a recipe for things to catch on fire that shouldn't be on fire. So metals, under those conditions, lots of times will just spontaneously start burning. You'll actually turn your metal and it will now become fuel. You'll be engine rich before you know it because your hot oxygen
nice
is eating and using that engine as fuel, basically. So oxygen rich is generally very hard, but that is what the Soviet Union ended up doing with almost their entire line of engines was closed cycle oxygen rich. But, so those two are kind of generally hard, but offer great performance benefits over open cycle. But at the end of the day, full flow is by far it's the ultimate of all of them. It's the most difficult, but it also has the most potential to be the most efficient.
Starship, the Raptor 2, why is that engine using full flow?
Because it's the best. I mean, it's just physics wise, if you're trying to extract as much energy out of your propellants, there just isn't another cycle type that is better than it. But of course, it's very, very hard to develop. So far to date, the RD-270 in the 60s was built. There is a powerhead demonstrator built in the United States in the 90s and early 2000s, I think, maybe just the early 2000s. That was just the power, just the pumps and the turbines and the preburners, no chamber, no nothing. That was a big deal. Only the United States took, millions of dollars to just develop that. And then there's SpaceX's Raptor engine.
So you talked about the combustion chamber and how damn hot things get.
Mm-hmm.
High pressure, a lot of heat. How do you keep the thing cool? You have a great video on this too. How do you get it from what do you call it? Metal rich, engine rich.
How do you keep it
engine rich from like the metal from melting?
Well, one of the ways is to let it be engine rich. There's actually, you can use ablative cooling. You can literally make the walls thicker than you normally make it out of a material that will ablate away, that will kind of chip away and take some of the heat away with it. It's very, again, primitive. And it's actually what SpaceX first used on their first Merlin engines. They used ablative cooling. So it's basically a carbon nozzle, and you just let it get the inner layer of the engine was carbon, and you just let it get chewed away and eaten away. And that's just something you factor in. It's not very elegant, and it's definitely not reusable in that sense.
So there's probably really good models about like how it melts away, the rate at which it melts away to know what thickness.
Yeah.
But boy, that's dangerous.
I just
it's part of the design.
It seems so silly. So obviously you probably,
Wow.
it's not the most elegant. And the problem too, your geometry physically is changing too, because as you're eroding the walls, now things like your expansion ratio or the ratio between your throat and the nozzle exit is changing.
Yeah.
Because the thickness, like the throat's diameter is actually, like everything's changing. So it's not great.
It might not be melting away uniformly. There could be some like weird pockets for aerodynamics stuff. It's just a bunch of chaos. I
can't imagine having to like figure all that stuff out, honestly.
Yeah.
So the more elegant thing to do, there's a couple other things you can do, but the kind of the most common one, especially when we're dealing with liquid fueled rockets, is something called regeneratively cooling. And the idea is you basically just flow fuel or oxidizer through the walls of the nozzle and the chamber before they go through like into the injector or into the actual combustion chamber. Mm-hmm. By doing that, you're taking heat out of you're taking heat out of the metal of the walls and you're putting it into the propellant. So you're typically heating the propellant up, which is, remember when I said there's a gas interaction versus a liquid, like liquid gas. So lots of times, even if you pump them both at, as they, are both being pumped as liquids, by the time it goes through the walls of the chamber, lots of times one of them is phase changed into a gas. So now you do have that gas liquid interaction. That's because they're using the fuel or the oxidizer to cool the walls of the engine. So when you look at a rocket engine, although it looks like, a nice, beautifully uniform cylinder, smooth thing, there's oftentimes like the channels actually like milled into the walls that they run fuel through. And even though they're tiny, they can be like 2-3 millimeters thick, they'll actually still have a channel that goes down and U-turns and comes around and comes back.
Wow.
All the way down to the tip of the nozzle and everything. So it's just insane that,
Isn't that's pre-designed and that's like, so they design those channels.
Yeah.
There's probably some optimization there, like how the flow happens.
Well, especially because you're thinking about a conical thing or like a semi-conical thing where the area is getting smaller and smaller and smaller. You're flowing the same amount of propellant through it as you are down to the, you know what I mean? Like the propellant has to, so they have all these unique things like, sometimes different manifolds where they'll inject more or less fuel in certain areas. And
there must be like propellant simulation software because they surely can't like test this on actual physical.
Well, back in the day, they had to just build it.
Well, you mean back in the day, walked uphill in both ways. It was like, I mean, like anything back in the day before computers, where you like had like,
you just had to do it,
and like your simulation or modeling was like a sheet of paper where you're like calculating stuff.
Well, but
loosely
you can
estimating.
heat flux, like you can literally see how much energy and how much heat is inside the combustion chamber, how much, and that is a measurable thing even without a computer. Now, I'm not near smart enough to do any of this. Like, I've never tried measuring the heat flux of anything. I barely even know what that means. I'm just smart enough to regurgitate
lived, my
it.
friend. Then you haven't lived.
But that is something that people would calculate, and they find out, okay, copper, does a better job of transferring the heat between the walls of it and into the propellant, blah, 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 compared to XYZ.
Materials people. I've met just in all walks of life, especially just through MIT, through everywhere, where there's some people are just like 100x smarter than anyone you've ever met at a particular thing. Like you mentioned copper. They'll know the heat dissipation through different materials. They'll understand that more than it's like, holy shit, it's possible for a human being to deeply understand a thing.
Dude, aerospace is full of that. You'll have people that are so niche in some thing that the average person has never even remotely thought of. Yet this person has done it 40,000 different ways in an environment, being like, well, we found out that if we turn it 4 degrees that way and add 4% niobium, things you're like, what is your life? And how do you know this?
And the funny thing about them, they usually don't think it's a big deal.
Yeah.
They're usually like, they're so nonchalant about it that if you don't actually, you have to know enough. You actually have to know quite a lot to appreciate how much more they know.
Yeah.
Because otherwise you won't even notice it. Because our popular culture doesn't celebrate the intricacies of scientific or engineering mastery, which is interesting. There's all these people that lurk in the shadows.
Oh, I know.
They're just geniuses.
Yes.
Like you'll have like the LeBrons who are like good at basketball, so we understand that they're good at basketball. They do this thing with the ball and the hoop, and they do like it really well, better than a lot of other people under pressure. We celebrate.
It's this big public spectacle.
Yeah,
look at how great they are. Yeah,
but like the people, at these aerospace companies at NASA, at SpaceX, the kind of stuff they're doing, just there's geniuses there, and it's actually really inspiring. I mean, I've interacted with a lot of brilliant people in the software world. And maybe because I don't deeply understand a lot of hardware stuff, materials engineering, mechanical engineering, those people seem like so much smarter. I mean, it's always like the grass is greener or whatever the expression is, but there's a depth of understanding that engineers have that do like mechanical engineering that's just awe-inspiring to me.
Well, not to get too I don't know what the word would be, introverted or something or whatever, but that's actually kind of the whole point of Everyday Astronaut. Like that's almost the whole point of what I do each year. From the beginning, I did a thing called the Astro Awards, trying to be like an award show, hoping to lift up and celebrate and shine a spotlight on the people that are actually doing the hard work and try to treat them like the rock stars that they are, that we don't know about. And I think that's one of the things that for sure I think Elon definitely helped make spaceflight cool. Helped make that like a celebration thing where people are physically out cheering for rockets and science and space exploration. But I think that's just the beginning. I think like this should be a thing where the general public looks to these people as the coolest ones, as the coolest places to work, as the most important things. Sports are great and everything. I'm a big Formula One fan and things like that. But, at the same time, like we should be celebrating the people doing this crazy work, clocking in countless hours, just trying to figure out this one little thing that's going to help us further our understanding.
I mean, what's cooler than a giant thing with a really hot fire that goes boom and goes up into the air? I mean, like there's no, it's like, to me, like bridges are inspiring. It's like incredible architecture design, and like the humans are able to work against nature, build these gigantic metal things, but like rockets, with a tiny little humans on top of them, flying out into space. It's like it's the coolest possible thing. Everything comes together. All the different disciplines come together for the high stakes drama of riding that super powerful thing up away from the thing we call home, Earth. Exactly. It's like, it's so amazing.
Exactly.
So freaking amazing.
Well, I think that's kind of part of my like story arc, is I just used to be a huge car and motorcycle guy. Like I just loved, things that go fast and, are loud and go fast and make lots of power. And at the end of the day, like at some point you realize nothing goes faster and it's louder and makes more power than a
Yeah.
rocket. And I think that's kind of where I eventually just ended up. Wound up there just because there is nothing cooler than that.
Yeah, that's the ultimate level of reach as a car guy, is to become a rocket guy.
Yeah, 100%. And at some point, some car guys literally become rocket guys and strap rockets to cars and try and break land speed records. It's the same universe here, and yeah.
So Elon, with your conversation with him on the Raptor 2, was talking about, or you were talking about, like there's an excessive amount of cooling to be on the safe side as you're developing the engine. What kind of cooling was that?
So that would be film cooling. So remember how a little bit ago we were talking about like keeping the turbine from melting? You can just run it off nominal, basically off, typically fuel rich, just run more fuel through that so it's cool enough. You can actually do that locally kind of in your engine. So you can keep it so, imagine a combustion chamber and the top of it's just a flat, like imagine a shower head, and then you have the combustion chamber attached to it. The outer perimeter there, the part where the flame front would be touching the walls, you can actually have just more fuel injectors. So you're injecting locally a more fuel-rich zone along the entire nozzle, and that would be called film cooling. So it's less efficient though. Again, you're kind of wasting fuel. There's fuel that's running, and your mixture ratio is off, but only for a little portion of the big picture. So that's one of those compromises. Like you can do additional film cooling to make sure you're not melting your engine, but at the cost of performance usually. But you can also be smart and use film cooling. There's fun little clever tricks. For instance, you'll notice on the F1 engine that was on the Saturn V, the biggest rocket that had been built to date prior now to Starship. The F1 has this huge engines. There's 5 of them on the Saturn V, and you'll notice that the gas generator has a pipe that comes down, and then it actually splits off in a manifold and wraps around part of the nozzle. Mm-hmm. And that manifold takes the hot gas from the turbine, which is actually, it's not hot. It's actually cold gas compared to the combustion chamber. But it's, in human terms, you wouldn't want to put your hand in it. You'd not live. And it actually pipes that gas into the nozzle so that it creates a film cooling, an actual boundary layer of cooler gas against the hotter combustion chamber gas. So they're basically repurposing that gas that was normally wasted, and they pump it back into the engine and then into the nozzle, like kind of further down. So the trick there is it has to be far enough down that the pressure in the nozzle, because remember, as the nozzle gets bigger and bigger and bigger, the pressure is getting lower and lower, and the temperature is getting lower and lower. So you have to find this trade-off point where the pressure is lower than that gas from the turbine, mm-hmm. and then you pump it in, and it's cooler than the gas still is in the nozzle, and it can help not melt your nozzle. So you'll notice that the F1 is actually a good example of regen cooling. So the chamber walls, you can physically see the pipes actually on the F1 because it's so big, and they just literally used pipes and bent them, and you can see the coolant channels all the way up and down the engine until you get to that manifold. Then from there on, it just has what's called a nozzle extension, and it keeps going and going and going. And that section of nozzle is cooled by the film cooling of the gas generator.
The aerodynamics of cooler gas and the hot gas, because you have to have this kind of layer, right? The protective layer of cooler gas. Like understanding that obviously probably has to do, in modern times, there's probably really good simulation of aerodynamics, and to do it in terms of pressure too, to make sure it's in the right place.
Yeah.
That doesn't go back up.
Go backwards. Exactly. Yeah. If they have that manifold even 6 inches too high on that nozzle, it's just going to go upwards, And pressure always wants to flow from high to low.
The number of options you have here that result in it going boom is very large.
Near infinity, yeah.
Especially because, you can't do a small model of it. Maybe you can. No, you can't.
It doesn't really scale very well.
No, you have to do the full testing, and that's why you have all the kind of that's why you have with Starship all the tests that you think, why would you need to do so many static fires and so many tests, and why is it failing so many times? Can't you get it right? But it's very tough to get it right.
Well, and when you're pushing the boundaries, you want to know where and how it's going to fail.
That's right.
So you can engineer around them. So that's a luxury that SpaceX does have with the scale of Raptor. They're building Raptor cheaper than probably almost any other engine, maybe besides some of their own, at least at that scale. than before. They're testing, I think since last March or last April, they've tested 1,000 Raptor, 1,000 engine fires, I guess, not just Raptors, but that's just an insane amount of data and an insane amount of edge cases to learn. Oh my God, we found out that we were actually slightly overspinning our turbine at this degree, and this frequency is harmonic at this blah, blah, blah. And all of a sudden realize it's rattling and, it did this. And then you can engineer around that. It's like it ultimately, I think Elon said something like high production rate solves many ills or something along those lines. And it's just true. If you have an insane amount of engines and an insane amount of data, an insane amount of failures to learn from, you just know your system inside and out. You know those margins. You know where the failure points are. You know how to engineer around them. And
that's how I approach dating. No, I'm just kidding. Because we're talking about engines. So most rockets, I think all rockets have multiple stages today. Maybe they'll take us in a discussion of what ideas that could be for single stage to orbit rockets. But can you describe this whole thing that you've been mentioning here and there of multiple stages of a rocket?
Yeah, no, that's a good question. So ultimately, like I said, you're kind of pushing about 90%. The rocket's like basically just fuel with some skin on it. You know what I mean? Yeah. And so that skin weighs a lot of, skin and the engines do weigh a lot. Like I said, the Falcon 9 on its own is about 20 tons. Just the booster is about 20 metric tons. So it's not an insignificant amount of weight. So the idea is with staging is you ditch anything you don't need, more or less. So in the Falcon 9 is a perfect rocket to think about this because you have an upper stage and you have a booster, our first stage. And the first stage burns through all of its fuel. Once it's out of fuel, you let go of the second stage and ta-da, you actually just basically started and lit a brand new fresh rocket. And this brand new fresh rocket now doesn't have all that 20 tons attached to it. So it's a lot lighter. It doesn't need, as nearly as many engines to push it around. It needs just one instead of 9. Its engine can be optimized for the vacuum of space as opposed to having to operate at sea level with all of our actually pretty thick atmosphere, relatively. So staging is basically the idea that you get rid of things you don't need. On Earth, again, kind of that whole like 10% harder, 10% easier. If it was 10% easier, single stage to orbit would be no big deal. And it probably would have been like the way to get to orbit by choice, just because like it's not that hard. But with our Earth as it is, with physics as it is, it's doable. And we've had, we almost kind of actually the first orbit to take humans, or the first rocket to take humans into orbit from the United States, which was the Atlas rocket, was kind of a stage and a half. It actually only had like one big fuel tank. And what they did is they actually dropped off 2 of its 3 engines. Mm-hmm. So it just ditched some of the engines. But if it hadn't done that, so kind of people were like, well, that was single stage. It's like it still had a staging event. It still had to ditch mass in order to even make it into orbit. Had it not done that, it would have not been able to get into orbit. So you pretty quickly look at your trade and say, okay, well, if I want to stick to single stage to orbit, my payload mass becomes tiny. Like you might be able to put like, a Falcon 9 booster on its own. Like if you just flew one of the side core boosters of a Falcon Heavy with a nose cone on it and everything, just say, I'm just going to fly this on its own. You might be able to put like 10 kilograms into space or something, a very small amount. Well, throw a second stage on that thing and now you can put, 17,000 kilograms into space. So it's just an orders of magnitude more payload capacity because you did staging, because you ditched the vestigial weight. So the other thing that's hard about that too is that the engines, again, that operate at sea level are often not great in space and vice versa. Like you physically can't, most optimized for space engines, you can't even operate at sea level. They'll destroy themselves due to something called flow separation. Mm-hmm. So not only are you getting the benefit of ditching all the weight, but you're also able to use a much more efficient and typically, much less powerful engine in space.
So you mentioned on the multistage rockets that maybe the dream would be if we weren't living on Earth, but maybe we can on Earth, to have a single stage to orbit rocket where it's all one package, reusable.
Mm-hmm. Reusable gets even harder.
It gets even harder. So first of all, what is, just to linger on it, what is the single stage to orbit rocket? And why is it so hard to achieve? on Earth. You already kind of explained it a little bit, but just if we were to say, like, yeah, that's your assignment.
Yeah.
Tim, you're supposed to get together with Elon and other brilliant people, and like you have to do this.
Yeah.
Why is it so hard?
Why is it so hard? The payload fraction of a rocket is like 3 to 5 or 6 or 7% would be like, that's the amount of payload compared to the total mass of the rocket. Like you're lucky to get into beyond 5%. So if you're now having to deal with the weight of the rocket by the time you're in orbit, like your payload fraction, just you're talking about like margins. It's so small amount of leftover if you have to take all of it with you. So the sooner you can ditch weight, the better. The sooner you can ditch weight, the better. The sooner you can, and that's what you're doing. A rocket the whole time is actually ditching weight. Mm-hmm. All of that fuel, all of that big giant flame you see is literally mass being thrown out the back of the rocket. But what typically isn't expended, at least during nominal operations, you're not seeing the engines being, expelled out the thing until you get to staging, of course. And that's where, you're ditching all that dead weight. So single stage to orbit, your margins just become so small that it's not impossible, but it's just at the end of the day, like almost no matter who you are, you end up saying it's just simply not worth it. Like it'd be, if you have two rockets that are using the same amount of propellant, they're the same physical sizes, and one of them is cut in, in a third and has another little engine, it'll have 100 or 1,000 times more payload capacity than the one sitting right next to it. And now, so there's tricks you can do to like try to offset that. Things like Aerospike engines, which operate at as efficiently at sea level, at kind of optimized efficiency at sea level, and just by the way they're designed, the physics of them, they're also efficient in a vacuum too. You can do things like that, and at the end of the day, though, you just end up with a worse rocket than if you had just done stage, like no matter what. And people say like, well, what if you developed the new technology? It's like, okay, well, apply that technology to a multi-stage rocket and it's going to do better. Like no matter where you end up, it's just always better to ditch that weight.
Is there a cost to having multi-stage? Because you can still reuse the different stages.
That's the dream is, becomes easier to reuse multiple stages because now, like the booster doesn't have to survive orbital reentry temperatures and extreme environments. And you only have to, make survivable the upper stage. So you only have to put a big heat shield. I mean, Starship's the perfect thing of this. The upper stage has a big giant heat shield. The booster doesn't need it because the booster's not going to orbit. It's only going a fifth or a quarter of orbital velocity. So its heat that it experiences is survivable just by the stainless steel. You don't need an additional heat shield. So all of a sudden, if you're trying to reuse, pretend that you just welded the two stages of Starship together, remove those engines on Starship, that whole vehicle, if you're trying to reuse it, the whole vehicle now has to have a heat shield on one side of it.
Yeah.
The whole thing has to have these big, heavy wings. By the time you come down to it, there's probably just zero payload capacity. You basically put your fuel tank in space, good job.
So the dream of a single stage to orbit rocket, is that just even the wrong dream on Earth?
That's what most convention tells you. By the time if your goal is cheap, then you're going to have a physically larger rocket that has more engines, that has more propellant, blah blah blah, to put the same amount of mass into orbit compared to something else. We're talking like Rocket Lab's Electron, a really small rocket. It's like I think 1.3 meters wide and something like 18 meters tall or something. It's a small rocket. If you were to, and it can put something like 300 or so kilograms into orbit. You could either launch something that size or again, like a full, like big old Falcon 9 booster, the huge thing. And that would be lucky to put 300 kilograms into orbit, So it's like, which one's going to be cheaper to build, ship around all the stuff. And then you also you have fixed costs. Like the idea of flying but again, everything in rocket science is a compromise because now you have things like people on console time, all the people that are, on comms and working on the rocket, going down to the pad, filing paperwork, doing range control, making sure there's not planes and boats in the way, flight termination. You have all these fixed costs for any launch. I don't care how big the rocket is. There's a relatively fixed cost. So now you say like, okay, I'm going to be paying, well, let's just make up a number. I'm going to pay $5 million to fly a rocket between all the people going on site, all the propellant, all the licenses, blah, blah, blah. If your fixed cost is $5 million and you can put 300 kilograms in space versus you have a $5 million cost of operation and you can put 5,000 kilograms into space, like it's the business case is going to send you in one direction pretty quickly.
So you mentioned Aerospike engines. I think the internet informed me of your love affair with Aerospike engines. Find somebody that looks at you the way Tim Dodd looks at Aerospike engines. Can you explain what these are? How do they work? What's beautiful to them? How practical are they? Why don't we use them?
Oh my God.
Does it just boil down to the design of the nozzle? So maybe can you explain how is it possible to achieve this thing for an engine to be as efficient at in a vacuum at sea level and all different conditions?
You know what I love about this is that every question you've asked me is like a 1 hour video on my YouTube channel. I was like, now boil it down to 45 seconds.
Go.
So the Aerospike engine basically is an inside-out engine, more or less. So with a traditional engine, we've talked about the combustion chamber and the throat, and then it expands out into the nozzle. Those walls are containing the pressure, right? Aerospike is the opposite. It's basically the pressure of the engine is on the outside of it, and it's pushing inward against a spike. So it's almost like it's like the difference of if you were, let me think about this. If you were standing in like a tent or a teepee, right? And you put your arms at the top and you pushed your arms out like into an iron cross or something, you can physically lift the tent just by pushing outwards on the tent walls, right? Mm-hmm. Well, that would be like a traditional nozzle. Now, Aerospike would be almost like squeezing an ice cube. If you squeeze an ice cube, you can push in on it and kind of that wedge force will shoot that ice cube. So that's kind of what is happening. We have the high pressure gases on the outside of the spike squeezing in on that spike, and then it's pushing up against the, because it's equal on both sides against like kind of the ramp, is pushing up against the rocket. So that's where that force comes in, is against the nozzle, against the chambers. The hard part with an Aerospike. So I guess the cool thing about an Aerospike is that it can operate in space. You can have what's known as a really big expansion ratio. So that's your ratio between the throat, the area of the throat, versus the area of the nozzle exit. Mm-hmm. And remember how the bigger the nozzle is, it's continually just converting more and more, is converting that high energy, hot, high pressure gas into cooler, lower pressure, and faster gas. So each little millimeter along that nozzle is just getting it lower pressure and cooler, but faster. Now, if you take a big nozzle on Earth and at sea level and you fire it, you can actually get, even though we're going from say 300 bar, the Raptor engine, our atmosphere at sea level is about 1 bar. It's pretty much exactly 1 bar, depending on conditions. But you can actually get a nozzle to get way below 1 bar of pressure. So every little, you can go from 300 bar in just 2 meters down to 1 bar or below 1 bar. Wow. There's actually a limit. You can actually only expand it below, we'll say something like 70%. So you can get down to like 0.7 bar at nozzle exit before the pressure of the atmosphere is actually squeezing in on that exhaust and tearing it away from the walls of the engine, the walls of the nozzle exit. Mm-hmm. And what happens is it's kind of unpredictable. You get these pockets, these oscillations, and they'll be so extreme that they'll end up just destroying the nozzle. So you can't have a bigger expansion ratio than, again, relatively speaking, something like 0.7. Like you can't get that pressure exit too much below ambient air pressure before flow separation can destroy the engine.
So how come this engine can do so well in different pressure conditions?
So because it's inside out, the ambient pressure is pushing the exhaust gas into the wall, as opposed to a conventional engine, that exhaust gas or the ambient air is actually squeezing the exhaust gas away from the walls of the engine, and that squeezing away from is what can be destructive. So that since it's kind of inside out, the ambient air is pushing the exhaust gas into the engine walls, so you can't have flow separation. You won't have flow separation. Now, what happens is, so you can have this huge, amazingly efficient vacuum engine that has we'll say a 200-to-1 expansion ratio, which is really big. Like a lot of sea level engines are like 35, 40, 50-to-1 expansion ratios. And then in space, it's common to use like 150, 180, 200-to-1 expansion ratios. So an Aerospike can have something like 200-to-1. It's just that at sea level, it's kind of just getting pushed and it's kind of getting cut off early almost, but it doesn't matter. It's not like destructive. It's just not running at its maximum efficiency. As it climbs in altitude, as the ambient air gets thinner and thinner and thinner, it just inherently is pushing less and less and less against the walls of that Aerospike engine. So it actually continually gets more efficient at, as it climbs in altitude, as does the normal engine. But the difference is that you can use that huge expansion ratio at sea level, and you can't use a huge expansion ratio at sea level with a traditional nozzle.
Has anyone actually flown an Aerospike engine?
No Aerospike engine to date has ever been flown on an orbital rocket.
Why not? And would you like to see a future where they're used?
Purely because I think they're cool.
Yeah.
In the same way.
That's at the core of your love affair with Aerospike engines.
It's just, and I said this in my video. Actually, they're outside before I came in here. I saw an RX-7 in the streets that I just love, and that uses a rotary engine. On paper, the rotary engine is like more efficient, does all, smaller, more efficient, all these things. But in practice, it's like the thing is actually just like unreliable, hot, and it blah, 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 burns oil. It's kind of the same thing with the Aerospike engine. Like, yes, on paper, it's more efficient, but now you have a lot more surface area of your throat area, no matter what, is going to have the throat of the rocket engine is always where it's the hottest. It's the hardest thing to cool. And with an Aerospike, if it's inside out, now your throat is, no matter what, like way bigger. It's almost like the size of the nozzle exit normally, but now it's your hardest thing to cool, and you have a ton of it. And you also have two edges of it, no matter what. So even if you have like a circle inside a circle, you have like a just insane amount more surface area to cool with a limited amount of fuel. Don't forget, you're using your fuel as your coolant. So if you all of a sudden now take your throat area and you have X amount of space that you need to cool, you have a limited supply. It's like, sorry, this is the stuff that just
are there ideas for cooling for cooling Aerospike engines?
It's the same physics apply for an Aerospike as they would. So you just run into a limitation. Like at some point, I'm not flowing enough propellant. It scales kind of poorly. You know what I mean? Like you can increase the thrust of an Aerospike by making it bigger and increase the mass flow and the fuel going through the throats or the throat. But at the same time, like it's at the end of the day, it's physically possible. It's a lot more complex. You have a lot of issues with cooling, and you end up kind of right back where you started. So it's like, is it worth it to just keep going down this rabbit hole, trying to engineer this thing to work when like you could have probably spent a 10th the amount of time just slightly increasing the performance of your normal engine in the first place, Again, I'm going to anthropomorphize that lesson and apply it to my dating life. And once again, just kidding. Okay. Actually, just on a small tangent, since you are also a car guy, what's the greatest combustion engine car ever made to you? If you had to pick something, what's the coolest, the sexiest, the most powerful, the classiest, the most elegant, well designed? I don't know what. A lot of those things are different for me, but I'd say
are.
It's funny because now maybe it's just because it's fresh on mind, but I love that mid '90s RX-7, which especially in Japan, they had the 20B, a tri-rotor. That is like the coolest engine ever to me. Maybe. The FD RX-7. It's just too darn cool, honestly. It'd be, there you go.
Well, what about the mid 90s that makes it special?
Just that's the only time
everything was.
It's more that I love the engine and I like the car it's attached to. I'm not actually a big fan of like 90s styling, personally. But just that the 20B is just such a cool engine, and it's twin turbo sequential turbos. So they used a bigger turbo takes longer to spool up. It takes more. It's using that same like a turbine and a compressor, and if it's a large turbine, it takes more exhaust gas to get it spooled up. So if you have an engine that revs to 9,000 RPM and you want to get a lot of pressure out of that turbo, you have a big turbo. It's going to take forever. Like you're going to have your floor, and then like it's going to take a long time for that turbo to get spooled up. So they actually did a small turbo on it and a big turbo. So the small turbo would spool up first, get some boost going through the engine, get that engine operating, get it up to speed, get some power to the wheels. And then once that kind of reaches its limit, you'd flow it divert the exhaust gas into the bigger turbo. It's this sequential turbo. And then that now can supplement and actually increase the, overall performance of the vehicle by a lot. And I think that's just so cool. It's just like the ultimate, like brute force, out of the box thinking, and it actually made it into production. You know what I mean?
Can you what's the sound like? Can you tell an engine by its sound?
It sounds like a really, really, really angry lawnmower. It sounds horrible. It's actually a terrible sounding car. In my opinion, like it sounds just raspy and like the opposite of like a big muscle car.
Yeah.
You know, like a big muscle car is this deep guttural, like
deep.
Oh, it hits you. This is like it's just gonna annoy the hell out of you and all your neighbors. Like
But you love the engineering.
I love the engineering of it.
So to you, the car is the engine. It's not all the surface stuff, all the design stuff, all the the elegance, the curves, whatever it is.
Well, those come and go. You know, to me, styles change
forever.
Yeah,
I'm gonna apply that to my dating life once again. The metaphors just keep on coming.
Well, if you think about it, like my taste has changed throughout the years. When I first saw a Model 3 Tesla, I thought it was the most hideous car I've ever. Without the grill, I was like, "This is so stupid." It took me all but 2 months to think that it was one of the coolest looking cars. Same with Cybertruck. I mourned Cybertruck when I first saw that thing. I was at that thing with, and I went with. We used to do a podcast called Our Ludicrous Future, so we talked a lot about like cars and EVs and stuff. We went to that unveiling, and literally like we had like almost a non-alcohol induced hangover the next morning of like mourning the hideousness of Cybertruck. Come 6 months later, a year later, and I'm like, damn it, that thing's actually kind of cool.
Yeah, that also teaches you something about. Again, it's the thing you said earlier, sort of. Going against the current of the experts or the beliefs or whatever and making a decision from first principles. Some of that also applies to design and styling and fashion and culture and all
big
that.
Time.
Some of that, so in fashion especially, it's so interesting.
So subjective.
Being rebellious against the current fads actually is the way to pave the new fads.
Well, it didn't take long for others to follow. You look at like currently like what Hyundai's doing with their, I forget which one, like the Ioniq or something like that. It's square. It's like it's boxy. Mm-hmm. It's a throwback. It's 80s. It's got these beautiful retro taillights. It's got these square headlights. It's very inspired by Cybertruck, in my opinion. I mean, it might not be. It might be coincidental that we're all kind of getting this retro future vibe. But
I personally like the boxy. So I still haven't understood Porsches. I still can't quite understand the small size, the elegant, the curves. I don't quite get it.
See, like I said, I don't love the look of the RX-7. I don't love it, but I love it because of the engineering, I guess, that it represents. You know what I mean?
Yeah, it's not the surface stuff. It's the deep down stuff.
It's that 50-50 weight distribution that matters.
All right, let's talk about Starship a little bit. We've been sneaking up to it from a bunch of different directions. Can you just say what is Starship and what is the most impressive thing to you about it? I mean, you've talked about the sort of the engines involved. Maybe you haven't really. You're kind of like dancing around it, but because this is such a crucial thing in terms of the next few years, in terms of your own life personally, and also just human civilization reaching out to the stars. It seems like Starship is a really important vehicle to making that happen. So what is this thing that we're talking about?
Yeah, so Starship is currently in development, the world's largest, most powerful rocket ever built, fully reusable rocket, two-stage rocket. So the booster is landed, and all this is currently aspirational until it's working. So I'll say what it's aspirationally going to be, and obviously I have faith that will happen, but just factually. So the booster will be reused, landed and refueled and reused. The upper stage will be landed, refueled, and reused, and ideally rapidly. In the sense, not talking about months or weeks of refurbishment, but literally talking about like mild inspections, and ideally like under 24-hour reuse, where you literally land it and fly it like an airplane. So it utilizes liquid methane and liquid oxygen as its propellants. It utilizes the current iterations of it are 33 Raptor engines on the booster and 6 Raptors on the second stage. So there'll be 3 that are vacuum optimized and 3 that are sea level optimized on the upper stage that are they'll be used, I think, at stage separation anyway. in space, but their main reason that they use them is so they can use them for landing too. The 3 sea level engines to be able to propulsively land the upper stage as well.
So the 3 Raptor engines are the ones that generate the thrust that makes it the most powerful rocket ever built.
By almost double.
Compared to the Saturn V, really?
The N1 had 45 meganewtons of thrust. The Saturn V had, I think, 35 or 40 meganewtons of thrust. And this has 75 meganewtons. So we're talking almost double. It's a lot of power.
That could be the sexiest thing I've ever heard. Okay. So what are the different testing that's happening? So like what's a static fire with some of these Raptors look like, and where do we stand? You were just talking about offline, like the thing that happened yesterday.
Yeah.
That was impressive.
Everything in this is kind of iterations, and so the milestones that we're seeing, we actually have on everydayastronaut.com. We have a milestone checklist of like all the things we're hoping to see that we kind of need to see before the first orbital flight of this rocket. So a big milestone that got checked off yesterday was a wet dress rehearsal. So it's literally like fueling the rocket up, getting ready to do everything but lighting the engines, basically. So we're talking about loading it with propellant all the way. This is the first time. Yep, right there.
Where's the milestones?
Right there at the top. Click that big picture. Yep, just anywhere. That big picture. Yep.
So there's the wet dress rehearsal. So what's the wet dress rehearsal?
Yep. So that's where they, for the first time, they filled it completely to the brim with both liquid oxygen and liquid methane. Now they'd done component level testing where they fill it with liquid nitrogen, which is, it's an inert gas. So it's not like, say it leaks out, it's not going to explode. You could just have a big giant pool of liquid nitrogen like flooding the area, but it's not going to be an explosion. So they've done that for cryo testing to make sure all the components and stuff can handle, being at cryogenic temperatures. It's kind of a good analog before you start putting your fuel and your oxidizer in there. But now, as of yesterday, they fully fueled the rocket with propellant, both stages, the first stage and the second stage, while fully stacked on the pad. Like basically, it was the first sense we really got of like, this is what it's going to look like right before it takes off. Kind of breathing, coming to life for the first time.
What does the pad look like? So there's a few interesting aspects to this. What's up with the chopsticks and the all of that?
Yeah, so the launch pad is unique. I've never seen anything like it in the prior history of space flight. But it's a really simple launch stand. They basically have like this, it almost looks like a stool, like a milking a cow stool thing with a big giant.
Now
crane.
I know you're from Iowa, but yeah. Yes, we all know what that stool looks like.
we all been sitting on that stool milking cows.
Yeah. Been there, done that.
With a giant hole in the middle, and that hole in the middle of that stool is where the rocket sits, and it sits on these launch clamps. And then next to it is so that's the orbital launch mount, and then next to it, or the OLM, some people will say, next to it is the orbital launch tower, or the OLT. And that is not only integral to fueling up the upper stage. The upper stage has to have propellant lines run to it so that they can fill it with propellant and all that. But it also, they ended up making it so instead of having a big crane on site to stack the two on top of each other, they literally just use that tower as a crane. So the crane has these giant arms, lovingly called the chopsticks, or the whole system can be called Mechazilla. And that will grab onto the booster, pick it up off of its transporter that transports it from the production site, lifts it up, puts it down onto the launch mount, and then it will pick up the second stage or the upper stage Starship and plop it down on top of the booster. And they did that for the first time last year. Actually, I think it was like Valentine's last year was the first time they used the chopsticks to stack it. And now they're doing it quite frequently, But ultimately, those chopsticks have to serve a second purpose. They're actually going to utilize, if you say it's not so much they're going to catch the booster with these chopsticks. It's not like it's, a dad trying to catch a falling child, It's more that the booster and the Starship will someday land on those arms.
Yeah.
So they're more or less stationary. I'm sure there's some bit of, adjustment that the arms will do, but more or less the rocket's going to propulsively land and get picked up by like what's essentially like two like relatively small ball joints that hold the entire thing. And so it has to land very precisely on these mounts, then onto the launch mount. And that's what's going to just place it back onto the stand and allow it to be refueled and fly again.
What's the idea of using the arms versus having a launch pad to land on? What's the benefit?
You are basically removing the mass of what would be heavy landing legs, and you're putting kind of that landing infrastructure onto a ground system. So you're not having to carry those landing legs into orbit.
But it's also elevated off the ground. Is there some aspect to that where you don't have to balance the thrust and all the...
You can negate some of those, like there's like plume interactions. There's like, the exhaust hitting concrete, and especially with a rocket this big, it's going to, use like 3 Raptor engines firing. If you have them firing really close to the ground, you're just going to absolutely destroy and crater the ground, and you're going to have to refurbish the ground and the landing pad every time. And, or have huge landing legs that are super long and tall, to make it so it's elevated enough to not do that. So yeah, you're avoiding that whole mess by catching it high enough off the ground that you don't have to factor that in.
And that's how many engines are involved in the landing part? Is the 3 Raptor engines?
Well, we haven't actually, we haven't to date seen the exact landing sequence. So it might be something like at first they might light up, 7 or something, or 9 or something, some number to accelerate quickly or decelerate quickly. Same thing. And then shut it down to 3 or something for a little bit more granular control. Because unlike Falcon 9, Starship has enough engines and variability to actually, if it needed to hover, to maybe more precisely align itself with the pad, it would have that capability. And especially having multiple engines, if you only have a single engine running, you can't really roll. Your roll axis, you can do pitch and yaw because the engine is kind of like a rudder. It can move in 2 axes, so you can easily pitch and yaw the vehicle. But to actually induce roll along its vertical axis, you would either need like auxiliary engines to roll it, or you'd need a pair of engines so they can be opposed and induce roll. So by having 2 or 3 running, they have all 3 axes of control that they would need, kind of like a broomstick, and balancing a broomstick on your hand. They can just move it over, and if they need to align it to those landing nubs, on the landing arms and stuff like that, then they can do that.
Speaking of pitch and yaw, the thing, so Starship flips on its belly flops, does a interesting kind of maneuver on the way down to land. Can you describe that maneuver? What's involved with that?
Yeah, so this is definitely a first. I don't think anything's tried landing like this before, but the idea is when you're falling through the atmosphere could actually do a lot of work for you. You're moving quickly, something is falling from space. Mm-hmm. There's a lot of energy involved.
You have a really good video on this as well.
And thank you. As it's falling, you want to let the atmosphere do as much work as it can. And so if you have a unsymmetric, it's not a ball that's falling. This is some kind of object with shape. Some, at one face of it is going to have more surface area than the other face. So, in the shape of like a cylinder, if you're falling, like a soda can, if you're falling top or bottom first, it's a certain amount of surface area. If you flip that on its side, you actually have a lot more surface area. So with the same exact vehicle, you can actually have a lot more drag. You can actually slow it down a lot more using the exact same atmosphere, same vehicle. Just by turning it 90 degrees, you can slow it down substantially, like 3 or 4 times slower. So that's energy that you don't have to use anywhere else. You don't have to use an engine to slow you down. You don't have to do anything else. So SpaceX realized, okay, if we flip this thing on its side and let it fall like a skydiver almost, instead of like pencil diving into the pool, you're belly flopping. You're maximizing the amount of surface area that's in the wind stream that's being slowed down. But obviously, like, in order to land, especially if you're SpaceX and, Elon's obsessed with like not having different parts, he wants the best part is no part. Mm-hmm. So if you're going to land with the engines, you might as well use engines that you've already have, the engines that are, used for the other portions of flight. So you kick those on and you use those engines to actually turn it 90 degrees from belly flopping to feet first. And that way you can use those same engines to land, and you don't have to have like auxiliary landing engines. You don't have to have forces, even if you were to land like on its belly with a separate set of engines, not only would those engines weigh a lot, and be extra complexity, et cetera, but you also don't have to make the ship be able to handle landing, like on its belly, as opposed to having the forces be vertical through it.
But it's a giant thing. You have to rotate in the air.
Huge.
And as you also highlight, there's liquid fuel slushing around in the tank. So like you can't I guess, use that fuel directly. You have to have another kind of fuel. Like, there's just complexities there that are involved. Plus, the actual maneuver is difficult from the like. What are the thrusters that actually make all of that happen? You're adding a lot of complexity, not a lot, but your complexity to the maneuver and possibility where failure could happen, in order to sort of in order for the air to do some of the work. So what is some of that complexity? Just, you can linger on it.
If we think about what it's going to take to go from horizontal to vertical, this rocket in particular, the Starship, has these big flaps. So it has kind of 2 nose flaps and 2 rearward flaps. The rearward flaps are a lot bigger because the majority of the mass, the engines and stuff, are in the back of the vehicle. So in order to kind of be stable, and they just fold themselves inwards, like on their dihedral angle, at a dihedral angle, in order to increase or decrease the drag. So you can control all 3 axes of control while it's falling, on its belly. You can control it that way using these 4 different fins. So you have these giant moving surfaces that take thousands of horsepower, just insane amount of torque in order to move these quickly enough to be a valid control surface. So that's a huge complication, is moving these fins and developing that landing algorithm and the control for a huge vehicle with flaps going in and out, in and out, in and out to stay stable. Then right as you light the engines, now all of a sudden you want the top, you want to flip the rocket 90 degrees. So the rearward flaps, the bottom flaps, fold in. They tuck all the way in to minimize drag. That's going to make it want to, swing down. You extend the upper flaps. That makes it so the nose wants to pitch up. You kick on the engines. They're now lighting all 3 engines, at least as of the last successful attempts. They light all 3 of the sea level Raptor engines, and they're pitched all the way 10 or 15 degrees or whatever the maximum pitch is on them. And that induces, it does that kick maneuver to kick it over from horizontal to vertical. Now, the problem is you lit your engines while you're horizontal. So they put some horizontal velocity into the rocket. They push the rocket, at the time the nose is, at the time of lighting those engines, the nose is facing the horizon and the engines are facing the opposite horizon.
Yeah.
So you now shot it a decent amount in an off, the direction that you're not falling, So you have to factor that in to where you're landing, because you're going to land on this precise, in this case, you're going to land on the inside the loving arms of the chopsticks, the Creed arms wide open, try to land inside those.
Exactly the song that you're playing through my head as I watch this now. Thank you. Yeah. Thank you for forever joining those 2. I appreciate this.
And you have to very precisely control. So what you have to do is, now that it's done that kick, you also have to cancel out that horizontal velocity. So it's actually going to rotate beyond 90 degrees to cancel out that horizontal velocity, and then modulate the engines to make it so the thrust, is perfect, so that it can control itself into a controlled landing. And all this is done in 500 meters, 1,500 feet. You're doing all of those things stupidly close to the ground. It looks absurd. So far, they've done 5 of these tests. All the first 4 all blew up. They're all coming in from about 10 kilometers or 33,000 feet. Falling, flipping, again, this thing is huge. That just the booster, or just the upper stage of this, is 50 meters tall, so it's 150, well, it's 45 meters, about 50 meters tall, about 165 feet tall, 9 meters wide, so 30 feet wide. It weighs, something God, I don't remember if it's something 120 metric tons, so 120,000 kilograms, 250,000 pounds empty. And it's doing this flip maneuver, and it has to do all this perfectly. So the first four attempts of this were pretty spectacular failures.
So just to clarify, which stage is doing this maneuver?
It's the upper stage is doing this belly flop maneuver. Yep.
So this is the stage that would presumably have humans on board if we were to use.
And if things continue to plan. Now, here's something I would love to see.
Yeah.
Just saying this.
Yeah.
If you already have these big aero surfaces, the flaps, they also have to move. They're on heavy motors and hinges and flaps and all that stuff. I'm actually surprised that for Earth, they aren't just looking at landing it horizontally on a runway like the space shuttle.
Ooh.
I mean,
Interesting.
That worked. The Braun did it. The Soviet Union's Braun. I rolled my R real hard there. Sorry.
Thank you. Wow.
Really getting spicy.
I'm very impressed.
And the Braun did it. We have other space planes like the X-37B. We have the upcoming Sierra Nevada's Dream Chaser. You have some extra mass in the wings, but so does Starship. Starship has the extra mass of those flaps, and the motors and the hinges and all that stuff. I would like to see the trade on, like, is it actually lighter weight to do that versus doing what SpaceX is doing? So yeah, I mean, that's the funny thing. I think realistically, if Elon walks in the door tomorrow and says, guys, we did some simulations and actually it's like we can get another 5,000 kilograms into space if we just land it horizontal. If we kind of give up on our ego and land horizontally, at least on Earth, then, I think they could be doing that pretty quickly. Because that's the thing is, this ultimate thing has been to land on Mars and, other planets, and Mars doesn't have a runway, doesn't have a thick enough atmosphere to utilize aerodynamic flight like that. So you have to do propulsive landing for Mars. You're going to land on an unprepared surface, so it has to be able to do this at some point. Mm-hmm. The ultimate, it sounds ridiculous, and it is, but the ultimate goal of it is to land on Mars.
There's not much of an atmosphere to to help you with for the belly flop to be useful.
There's only 1% the atmosphere on Mars as there is on Earth, but you still want to utilize as much of that atmosphere as possible. So in the upper atmosphere, it's still going to be coming in more or less kind of perpendicular to the airstream. I guess it's probably more like 60 degrees, 70 degrees to the airstream, like where it's belly flopping. And it's going to especially do that on Mars. It's going to need to, use up let the little bit of atmosphere there is, you're coming in at insane velocities. And so even that 1% thin atmosphere is still going to do a lot of work. Now, on Mars, there's only 38% of Earth's gravity on Mars. So the belly flop maneuver is it could be a lot more conservative. You could do that at like 5,000 feet up, and it just wouldn't matter as much because there's not as much gravity loss or gravity drag. So you can kind of just more slowly, gently, you don't have to do this crazy, extravagant, like belly flop, flip maneuver. But it would still something at some point you would transition from more or less perpendicular to the airstream to, and horizontal to landing vertically.
I like how we're having this old, boring conversation about the differences of landing on Earth versus on Mars. This is surreal that this is actually a real conversation. Well, this is something that we're discussing.
Yeah.
Because it has to do both.
Yeah. But in my opinion,
yes, I
think we'll pretty quickly see an evolution of Starship that's like dedicated versions for certain tasks.
Sure.
And at the end of the day, again, if someone runs a simulation and says it's actually more efficient and it's better just to land horizontally on a runway, then that's what's going to happen. It doesn't matter, but they still will develop, if the ultimate goal is to land on Mars, then they'll have a dedicated Mars variant, which will likely look different than the Earth variant, and they'll still probably be launched on the same booster. You know what I mean? So there's...
Oh, you mean like that particular vehicle will not be returning back to Earth. It'll need to be modified. Because the ultimate is to have one Starship that goes to Mars, lands on Mars, and takes off of Mars, lands back on Earth, and is reused again.
Yeah.
Over and over and over.
And there's a chance that you have just a cycler, just if you at the end of the day, you're just really trying to see what is most feasible, what's the most efficient. You literally have a vehicle dedicated to Mars. Mars, it's easy to do a single stage orbit. Mm-hmm. It's a lot lower gravity, a lot thinner atmosphere. You can easily do a single stage orbit. You get into orbit, you park to a dedicated, transfer vehicle that goes between Earth and Mars. It only stays in space. You don't have heat shields. You don't have landing legs. You don't have all these things that you need. And ideally, it's nuclear powered, so it's super efficient. Mm-hmm. That gets you back to Earth. Once you're at Earth, you rendezvous again with another landing Starship. And that Starship might be a horizontal runway Starship, There's no, I don't see and I think ultimately it'll win out where we don't have a one size fits all. I think that's the flaw of the space shuttle, really, is that it was trying to do everything and ended up kind of doing nothing well. But that's, I think, what SpaceX has proven. I mean, SpaceX already has variants coming. There's already going to be a dedicated lunar lander for NASA for the Artemis program. There's already going to be a tanker variant. There's already going to be likely just a pure cargo version. There's likely going to be a human version. We'll likely see evolutions of this thing happen, relatively quickly.
And once it's all working, it's only a matter of weeks before people riding on it will be complaining about the speed of the Wi-Fi. As the old like Louis C.K. joke with like where you're flying on a chair through the air.
Yes.
It's
You didn't even-
incredible.
You didn't even know this existed, and now you're complaining about it.
It's great.
Exactly.
So you tweeted fun fact about Starship by doing the flip around 500 meters versus higher up, like 2,000 meters. The difference in delta V is 500 meters per second. That's a 20-ton fuel saving, which means basically 20 tons more you can put into orbit. That's more than Falcon 9 has ever launched just by flipping later. That's really interesting. So that was a decision too, to flip close to the ground.
Yeah. The closer to the ground, the better. The more the atmosphere is doing work. And, we get into that video really dives into like gravity losses and gravity drag. The more time you're spent, every second that your rocket engine is running, Earth is stealing 9.8 meters per second of acceleration against you. Mm-hmm. There's just inherently 9.8 meters per second squared of acceleration. So every second that engine is running, the first big majority of your thrust is actually being just stolen by Earth's gravity well. So the longer you're fighting that, the more inefficient it is. So the best thing would be you flip at 100 meters off the ground, you light all your engines to maximum thrust, and you pull 50 Gs, and you land on a dime basically. Obviously, there's no margin there. There's and there's diminishing returns on that gravity loss thing and in your high thrust weight ratios. So that's a pretty good compromise. Like, yes, it looks scary, but they could be a lot more aggressive with that yet and squeeze out even a little bit better performance. But there are diminishing returns. So that's kind of the magic number we've seen so far today, but we'll likely see that, be played with.
You've attended some of these. What does it feel like to see Starship in person? First of all, when it's just sitting there stacked. And second of all, when it's doing some of these tests, some of these maneuvers.
Well, first off, if you have the freedom of traveling and happen to live within a reasonable, either by plane or car, it's worth going down to South Texas. So Starbase is right on the border of Mexico and the United States and the very southern tip of Texas, right along the Rio Grande. And it's insane because it's right along a public highway. You can anyone can drive down this, assuming it's not closed for testing, because they do close the highways during the week a decent amount while they're doing tests. But sans any of those days, anyone can just drive down and see these things up close and personal with their own eyes. Like we're talking, from 100, 200 meters away, so 2 football fields away from the world's biggest, most powerful rocket. Imagine being able to do that during the, Soviet Union and, during the N1 and the Saturn V, imagine just being able to drive up right next to the launch pad. There's no way, and so to have this kind of access to this program is so incredible. The craziest thing is when you're driving out on Highway 4, it's bumpy. It's riddled with potholes now because of all the insane amount of trucks having to go out there and traffic, and you're going through this. It's just this weird. You're like, where am I? You occasionally are seeing, like, you can kind of see you can see Mexico out your right window as you're driving down this highway, and you're just sitting there like, where am I? And then all of a sudden you kind of turn this corner and the trees and the brush kind of clear out, and all of a sudden you get a sense of everything on the horizon. And at that point you're pretty much 5 miles on the nose or 8 kilometers away. And from there, you can just see through the heat haze, through the atmospheric distortion, and you just see this weird, like, it looks like a city almost on the horizon. There's tons of these tall buildings. There's a weird, ominous launch tower thing with arms wide open, and sometimes, and a giant metal rocket, and it just looks so weird. I mean, it's the word surreal, I think, by definition, I think if you are expecting it, it's not surreal. I think surreal kind of means like unexpected surprise or whatever, Even if you're expecting it, even if you've seen pictures, even if everything, it is surreal.
Yeah.
You stand there and you just go, what is this?
And also, I mean, there's a kind of magical aspect to this is the place where over the next few years we'll start as a human species reaching out there, traveling out there.
We'll for sure see the development of the rockets that I think will take us further than ever before. Be born right there.
What's it like to witness the actual testing of Starship?
So far, it's been high stakes, like It's been insane because those the first I kind of mentioned earlier, there's been SN8, 9, 10, 11, and 15 that have all done these suborbital hops. The highest one went 12.5 kilometers, and the rest of the four went 10 kilometers in altitude, and then turned off the engines and just fell. Mm-hmm. Now the cool thing about that is the general public could be about five miles away, so again like 8 kilometers away. And the weird thing is this rocket's slowly accelerating. Mm-hmm. They didn't want to exceed a certain speed, so they didn't have to worry about the aerodynamics of it. They just slowly climbed, and it probably also to appease the FAA. They're like, here, we'll just limit the thrust to weight ratio and just, make it so it's slow and controlled, no big deal. So it's basically more or less like slightly above a hover, just climbing for minutes, for like 4 or 5 minutes. You just hear and feel the roar of this thing. Normal rockets, like after the first 30 seconds or minute, they're so far away that it's just diminishing, it's just fading. You still get that rumble, that sense, but those first 5 flights, the suborbital hops were just, I'll cherish them forever because you're watching this thing that you've driven up next to, you've seen it with your own eyes, that's bigger than most buildings in a fairly dense urban area. It's this massive thing. You stood there, you look at it, you're like, wow, that's crazy. You've seen people working on it, they're little ants compared to it. Mm-hmm. Then you drive away and you see it on the horizon, and all of a sudden that thing leaves. It starts moving.
Hovering.
Essentially. And the first time, I mean, for me at least, I put my hands on my head when I can't help it. Not so, I don't know
it's
what
surreal,
it is.
like you said.
I don't know what in human nature decides this is what to do when you can't believe something, but that's what happens. And when that thing first took off, it was just like my brain couldn't process seeing, because I had spent so much time driving around and seeing it, and all of a sudden you're watching it just take off, and you're like, it's moving. And all these, the most complicated rocket engines ever made are all firing simultaneously, and it didn't blow up on the launch pad, and it's slowly increasing, and it's just crazy. And the sound, everything about it. And so by the time the first one is specifically, it was December 2020 was the first SN8. It went up, and we all lost it in the sky. We couldn't quite see it, but we had telescopes and high telephoto lenses tracking it. And what's funny is there's a pretty strong wind up there at altitude, and it was moving. There's a lot of gaseous oxygen being vented out of the rocket, and it's being blown by this air. So it looks like it's moving actually quite quickly, like away from us, like it was strafing to one side. So I'm watching the monitor. I'm going, oh my God, they're moving it like over Brownsville. And we're all of us, everyone on this hotel balcony is looking out, down, like way out over, and we can't find it. And we're like, where did they lose it? Like we're thinking like, oh my God, this is going to crash down in Brownsville. Yeah. And finally they shut the engines off, and we're watching it fall. And again, we're tracking it. We know it's falling, and it's falling. It's falling super controlled. And we're like, oh my God, this is perfect. And all of a sudden it clicked, and I see it with my, my eyes. I finally tracked it. And it's straight out, like straight in front of us. And it looks like it was a blimp, just barely moving. Mm-hmm. Because it is falling slowly thanks to all of its drag. And again, that's one of those moments I'm like, it's falling so slow, because it's so big, it's so massive, it's falling sideways. I've seen Falcon 9 boosters and Falcon Heavy boosters, and they scream. They come in so fast. And you can barely even see them. You can just barely track them. And all of a sudden they light their engines, and they decelerate so quickly. This was like the opposite. It was like, is that thing ever coming down? It was just falling so slowly and so right there. Just felt like it was so close. And so when it finally lit its engine and it flipped, I was losing my mind, because I'm like, it's working. This crazy plan, this huge, massive thing is doing this absurd feat. And the first 4, again, didn't work out as planned, but getting to that point already, getting to that flip maneuver was a huge milestone. And it was so exciting. Just going through those firsts were amazing. And I think, we're coming up now on them doing the full stacks of the booster and the upper stage. Mm-hmm. I think when we see that fly, when that leaves Earth for the first time, it'll be, like I said, almost twice the amount of thrust as anything else. It'll be the biggest, heaviest, largest thing to ever fly. It's going to shake everything. I can't wait.
Have all 33 Raptor engines been active at once? Have they tested that?
No, that's coming up. That's kind of the next milestone. I don't know, when this will come out, but we're That's like the next.
Just a few days, very quickly here.
But if people listening to this, if they're listening to it early on, they'll likely be able to catch. I think at this point it seems like next week.
So step one would be static fire.
Yep, holding onto the rocket and lighting up the engines. And so far they've lit at most. They went for like a more than 14 engine static fire. I don't recall if it was like 16 or something engines lit at once, and they ended up going down to 14 engines. That's the most engines they've ever lit. So the next step and the final kind of step before they fly this thing is they're actually going to light all 33 engines simultaneously. And although that sounds scary, let's not forget the Falcon Heavy that's now flown 5 times completely flawlessly has 27 engines running simultaneously. So they definitely have, SpaceX has experience with high number of engines running at the same time, but it is still like this is going to be a lot of moving parts and a lot of potential and a lot of everything.
What are the upcoming milestones, expected milestones? And I think there's one in particular I'd like to talk to you more about, but leading up to that, of course, is like, what are some of the tests here on the way? So is the static fire, the fully stacked with the 2 stages, will there be, and then all that leading to an orbital launch test? What are the things we should know about? And when do you think, like, what do you think the timeline will be with like the orbital test?
Timeline, the reason we have this website, the expected milestones, is because I always tell people to ignore any time you ever hear for any of this stuff and just pay attention to milestones, because when you're doing stuff for the first time, you just have no idea.
So just to understand the expected milestones here, the first column is the event, the second column is the date and status, TBD, complete. Green means what?
Green means it's been completed, and it shows the completion date there.
And the completion date.
Yep.
And then the others, maybe more, maybe not, for the full stack testing, the D-stack, and there's a 33 engine.
So realistically, we're expecting them to destack, and SpaceX, I think, just tweeted that actually, that they're going to be destacking the second stage from the first stage, kind of get the ship safe while they test, because they don't want to, 33 engines is pretty high risk. If they do blow up the rocket, when they test it for the first time, it's not going to be fully fueled, I don't think, at least. But there is a limit to how they do have to have it weighed down enough that the launch clamps can hold on to it. Because if you think about it, like, normally the launch clamps are holding onto an entire rocket weighing 5 million kilograms. 5 million, it's weighing an insane amount. So those clamps don't actually have to hold 75 meganewtons of thrust. They really only have to hold down 25 meganewtons of thrust. You know what I mean? They're not designed to hold down all 75. So they do have to have enough weight on the rocket. So even when they do the testing of the 33 engines, it'll have to have enough propellant in there that they don't exceed the clamping and the holding force of the stand. Otherwise, it'll break free from the launch stand and that booster will go flying off uncontrolled.
So it's a difficult thing to figure out in the test how many simultaneous things you test, right?
So they're kind of mitigating risks, which is why, like, they're destack. They don't want to have, although the ship could be on top of it to help weigh it down and simulate the launch environment better. At some point, that's a risk they're just going to take when they go for launch. And so for now, they're taking the ship off in case something goes wrong during the 33 engine test. And then once we see if the 33 engine test goes well, hopefully we see the second stage get stacked back on it. We'll see them get closer, like closing out all the items. And hope the big one too is the FAA launch license. That'll be publicly filed. We'll see that in the system having a launch license. And I have no sense of that type of thing. That's outside of, but that is a big milestone, and it might be something that could potentially hinder, hold up the launch date. We'll just be waiting for a launch license.
Yeah, I'm sure there's a lot of fascinating bureaucracy and politics and legal stuff and all that kind of beautiful, magical thing when you live in reality, because it is a big rocket.
Yeah. Well, and the biggest thing, it's not so much the FAA doesn't necessarily care about the success of the rocket. They really just care about the safety of public property, So it's a matter of being convinced and having the data to prove, okay, if this thing blows up, we have control of how and when it blows up. We have control of, X, Y, and Z. Here's the potential damage. Here's the blast radius. This again is over twice as powerful and twice as much potential. Actually, it's a lot more potential for an explosive energy if it, if it were to happen to. Well, let me walk back a little bit, because in order to have a real detonation, you have to have a perfect mixture ratio of your fuel and oxidizer. If when a rocket blows up, typically, it kind of unzips and some of the fuel will mix into some of the oxidizer, and you could have some explosive energy, but a lot of it's actually just a deflagration. It's just, flames and there would be explosive energy, but it's not like you're lighting all of it simultaneously. It's this giant bomb. It's just really not. So that's good. But at the same time, even in those circumstances, the amount of energy is still absurd enough to likely blow out windows, for miles and miles and miles, including my studio space.
Well, if the cameras hold up, it will be one heck of a show.
Exactly.
Hopefully, of course, would not happen. So how does that take us to an orbital launch? When do you think that would happen?
In my opinion, this is a very fluid, and this will change literally by the hour.
So you really think that it's very difficult to really say, like, even for something that could very well happen this year, even just a few months away, making a prediction. By the way, are you like superstitious on this kind of stuff a little bit? Like, you're worried about jinxing it and that kind of stuff?
At all. No.
Because I would imagine you would be like waiting for all of these launches that keep getting delayed, or you start thinking that there's certain things you do will control the weather.
My socks. Why am I wearing these socks that just scrubbed again? Yeah.
You're lucky. You have to wear the same lucky socks, otherwise there's going to be bad weather. Yeah.
So the reason that I say this and why it's so difficult is they did a first full stack test in July of 2021, and the expectation was we're a month or two away from a launch.
Yeah.
So realistically, for 18 months, I've been in a purgatory thinking that we're a month or two away of an orbital launch. Now, I did say, for the record, when that thing stacked and when a lot of speculation was saying, a month or two, I was saying, I don't expect it to fly in 2021. And I've been just saying, I just saw the amount of work that still needed to be done, like on the ground systems, the tanks, the launch mount, all the stuff. I'm sitting there like, there's still a lot of stuff. And they're going to have to validate it. They're going to have to test everything, every component. And, people were like, how dare you say that? Even Gwynne Shotwell, the president of SpaceX, is saying Q3 of 2021. I'm like, okay, but I'm not going to be surprised if it slips into 2022. And here we are at the beginning of 2023. And I think we're finally within 2 months. I'm expecting, I'm trying to keep my March and April as free as I can. We'll put it that way.
I love it. Actually, just in a small tangent on Gwynne Shotwell, what do you, from everything I know, she's an instrumental, a really crucial person to the success of SpaceX in running the show. She's the president, the COO. What do you know about her that sort of the genius of Gwynne Shotwell?
Man, my understanding is she's really the glue. She's the glue to the tornado. Tornado comes in, and then she comes around and just really executes on and helps. A famous story is that at some point Elon walked in, or she sprinted into a meeting because Elon was actively trying to cancel Falcon Heavy, saying it's too far, it's too much development. It's still too far away. And this is this might have been end of 2017 or something, and it flew for the first time in 2018. So we're talking it's close to the end of development. There's hardware being built, all this stuff, and Elon's literally in a meeting telling people they're going to cancel it and we're going to move on to BFR, or now Starship, and just go full steam ahead on that. And she runs into the meeting and reminds Elon, we have X amount of customers that have already purchased a ride on Falcon Heavy. We can't delay that. So it's that business sense of yes, it's great to innovate, but we also have to pay our dues and make the money to continue our operations. And I think she's just a lot better at, I think she has such a great perspective on everything. It really seems like everything she doesn't, I wish she did more interviews because I would love to hear more from her. But man, it just seems
hear that, Gwynne?
For both of us.
Yeah, she hasn't actually done that many interviews, right?
Not really, no. She's done a TED Talk, a couple little things here and there, but not really many interviews. And I would just love to hear what on a daily basis, what is she doing to keep her head on and keep everything so organized? My understanding is that she is absolutely integral and does just a insane amount of work at SpaceX.
Yeah, I mean so it's the project planning, but also the how the teams integrate together and the hiring and this is the management.
I think it's a lot of it is honestly even just the business, making sure the money's flowing in a positive trend, more or less. That yes, Elon's obviously a money guy, but he thinks I think Elon is so risky. He just loves to throw it all in that he leaves little margin for error. He's been really lucky with rolling his dice, especially like when he started SpaceX and Tesla. That was the ultimate roll of the dice. But I think she's a healthy balance to be like, well, here's our, operations and now we can continue to do this without risking everything, And Starship's close. Let me be clear. Starship is close to risking everything already. It's just such a big, fast-moving, high-risk developmental program that I personally think, SpaceX would probably be fine if they shut the doors on Starship and just flew Falcon 9 and Falcon Heavy for the next 10 years. They would still be commercially valid. They could not spend another dollar on research and development. They could fire, I don't want them to, fire everyone involved in anything research and development and just ran operations on Falcon 9 and Falcon Heavy, and they would still be dominant for 10 years. And they would still have a business case, and they'd still be fine. But they're all in. Like all chips are pretty much, as many chips as possible are in. For Starship.
I don't know what else I could say. Is there's not. I've talked to a lot of great leaders. There's just not many people like Elon that would push for Starship.
When they're already
a very successful company.
Yeah.
Sort of everyone doubted that it could be a successful company. It was so close to bankruptcy and failing. And then to take it into a financially viable, successful company. And just when you do, you take on a project that again risks everything.
Well, he already did this with Falcon 1 to Falcon 9. Like literally people were like, what are you doing? They basically signed over and were fully ramping up Falcon 9 by the time they finally had their first Falcon 1 success. They had one more flight. They only flew Falcon 1 successfully twice. They flew it 5 times altogether. The fourth one was successful and they flew one more time. And anyone else out there would have been like, let's keep flying the Falcon 1. We have a working rocket. We can start, making money and profiting. And already he was risking it all and saying, nope, we're going from Falcon 1 to Falcon 9 was a huge, huge leap. I think it's at least as big as a leap from Falcon 1 to 9 as it is from Falcon 9 to Starship, or around relatively a similar leap. So it's just that same thing again. People are going, why are you leaping into this insane program and system and risk when you have such a, you finally have this workhorse of a rocket that's so dominant in the industry, yet they're going 10x,
It so happens that you've been selected for the dearMoon mission that will fly Starship once around the moon with 9 people on board. You are one of those people. So just pause to take that in. Everything that we've been talking about, you will not just be reporting on, you will be a part of it. So tell me about the objective of this mission and how does it feel to be a part of it?
Well, man. Yeah, it's basically, it's the Willy Wonka of space. Like a generous, a generous individual purchased a ride from SpaceX as early, at least as far as I know, the earliest I knew about it was February 27th, 2017.
Who's the individual?
Yusaku Maezawa. But at the time, I'm telling you a story. At the time, we didn't know.
Okay, great. Great.
So February 27th, 2017, a press release comes out from SpaceX saying someone purchased a ride through us around the moon. We're going to fly someone around the moon. And at the time, it was on a Crew Dragon capsule and a Falcon Heavy. It's like, wow. And that was enough. That little moment right there, that press release. It's the first time I'm like, I'm going to make a YouTube video about this. I stood up, turned on my camera, put on my, at the time, spacesuit. Mm-hmm. And I basically yelled at the camera for 3 minutes about someone's going around the moon, Fast forward to 2018, end of 2018 or near the end, they introduced, there was a SpaceX press conference. I'm there as a member of the press. I'm reporting on, we're going to meet this person that's going around the moon, and come to find out, boom, they're going to be riding on Starship now. They changed from Falcon Heavy and Dragon. SpaceX is no longer going to do that. They're going to upgrade them basically to Starship. So instead of being in like a small tin can. They're in this giant, luxurious, mega rocket around the moon. And it comes out that this individual named Yusaku Maezawa, who is a Japanese billionaire, purchased this ride. And instead of inviting, his friends and, colleagues and whatever, whoever, his family members or whatever, he decided the most impactful thing he could do with this opportunity is invite more or less artists. In the original thing, it was like artists, journalists, a painter, an athlete, photographer, videographer, all walks of life, basically.
When they said athlete, they thought of you.
They're like, I know a guy. This guy rode Ragbri once. And at the time, I was like, this is crazy. I can't believe this is going to happen. And, he had this vision of, we're going to find people from all around the world. I'm going to invite people from all around the world, from different walks of life, different, trades. And I'm going to share this experience so that they can share it with the world and really have an impact much greater than, any one country or any one individual or any, set of military trained, astronauts could do. Offer up a new perspective. Beautiful. At the press conference, I cried. Like, I had a couple tears in my eyes. I was like, this is so cool.
We could just pause on that. So he goes by MZ?
MZ, yep.
How incredible is that?
I
think it's you often don't realize the importance of individuals in human history. Like they define, because this could be, we talked about the importance of Elon in particular. Most of the work is done by large groups of people that are collective intelligence that we band together. But like, these individuals can be the spark of the catalyst of that progress. And I mean, just this idea of getting not just civilians, which is already incredible, but civilians with a sort of an artistic flame that burns inside them. They're able to communicate. Whatever they do, are able to communicate something about that experience. And it's just a genius idea to spend quite probably a very large amount of money for that. I mean, and that will be part of history.
Yeah. And it's easy these days for people to be cynical, especially about like space flight and wealthy individuals. But really, in my opinion, and maybe, just at the time, I was just couldn't believe this idea. I'm someone that has studied a lot about, the Apollo program, the people that have been to the moon, and they're incredible individuals, but they're so saturated with tasks, and they're military trained and often, that they didn't really have the luxury of just being able to soak in the experience of going around or to the moon and seeing the moon up close with your own eyes. Like, that just psychologically has to be insane. And so to have this opportunity to be able to observe our closest celestial neighbor with your own eyes, and your sole purpose is to soak it in and share it and communicate and create with the rest of our planet, like, that to me is just beautiful.
So that is the objective of the mission.
That right there is the objective of the mission.
And how does it feel to be selected as one of the 9 to do it?
It's a gradient. It's doing a few things. Since I've known, it's become, I think the closer it gets, the more excited and the more nervous I get. The
more real it becomes.
The more real it becomes. The announcement was a big, it just got announced at the end of 2022 publicly, who's involved. And so, prior to that, like, I had, each step of the selection process, there's a pretty comprehensive selection process with interviews and stuff. Each step I'd try not to get my hopes up. And frankly, like, this, let me be clear, this was not something that, like, I've always wanted to do. It's not like I'm out there. I didn't start doing YouTube videos because I wanted to even go to space. Like, none of that. And I've said, hilariously, I've probably said dozens or hundreds of times on air, like, yeah, I don't ever want to go to space, because it's not like it's not a driving force. It's not really a thing I even really truly pictured or let myself fantasize about, frankly. So each step of the selection process, I didn't really let myself dream about it too much, or, but it would kind of chip away, like, oh my God, this is actually becoming more real. This is actually more and more of an opportunity. And I get equally more nervous too. Like, frankly, I've seen spaceflight stuff go wrong. I think about this stuff a lot. So, like, yeah, I get more nervous, but I also get more excited about that opportunity. Like it's an opportunity that how can you pass? And I still have to actually stop, pause, think, and actually realize the reality that that I am going to the moon. I'm going to see the moon up close, flying around the moon. I'm sorry, some people get mad when I say going to the moon since I'm not landing on it. But flying around the moon, seeing the far side of the moon with my own eyes,
And seeing Earth.
and seeing the Earth rise behind it. Yeah, it's going to. I can't tell you what it's going to be like and feel like.
So epic.
But it's insane to me that like we're having this conversation and that is my reality, you know, like, and that someone was generous enough to consider the option of sharing this with frankly strangers.
Yeah.
And the process that they had for selecting, like how much thought and time went into the selection process is incredible. You know, they did a public call at the beginning of 2021. And so the team's involved in whittling it down from 1 million applicants. There's 1 million applicants that whittled it, and they got it down to 8 crew members and 2 backups.
Yeah.
Amazing people. I would have, you know, I don't know how they wound up where they did, but it's incredible. I feel a very deep connection to everyone that's already involved. And
What can you say about the crew? You've gotten a chance to meet them and talk to them, and Steve Aoki's on the crew. Like, who else is there? So you are obviously the star athlete on the team. Who else in terms of the artists that are there?
so, oh man, we might just want to pull up just so I don't totally butcher and forget anybody. But because so far I haven't actually had the chance to meet everyone in person. You know, so far a lot of this was done during the pandemic, but we've met through a couple different things. We've had a couple different times to get together. But so far I have not met Steve Aoki yet or Top. We've been on calls and stuff. I also have not yet met Dev Joshi, who is an actor from India. So yeah, we can Steve Aoki, American DJ and producer and musician. Top from South Korea is also a musician and a producer.
So this is all across the world. So like truly global, all different kinds of walks of life.
Yes.
All artists of different forms.
And Steve is Japanese. His parents are Japanese, but he, you know, born and raised in the United States. Yemi is a dancer and choreographer from the Czech Republic. Rhiannon is a fine art photographer from, well, England and Ireland. I guess she lives in both and kind of a bit of she's all over the place. Technically, she's Irish, I guess. Tim Dodd, yep, that's me from the United States. Mm-hmm. Then you have Kareem, who is from England and also is a photographer and documentarian. Does a lot of work with oceanography and volcanoes. So he does really incredible work. Brendan Hall is a documentarian and filmmaker. Dev Joshi, Brendan is also from the United States. Dev Joshi is an Indian actor. I believe he's also already been producing and things. He's very young. I think he's only like 19 or 20, and he's been acting since he was like 5 years old or something. He's a Bollywood star. Like he is a star in India, which is really cool.
Right.
Caitlin Farrington from the United States is an Olympic gold medalist snowboarder. So she, believe it or not, is the athlete and not me.
Sorry.
And then and she's one of the backup crew members, as so is Miyu from Japan, who's a dancer.
Oh, it's amazing. I mean, it's such an interesting group. I mean, is there something else you could say about MZ? How about Yusaka Maezawa?
Yeah, Yusaka Maezawa. So he's also a musician. So he was actually in like some kind of punk hardcore Japanese bands in the 90s and stuff, and early 2000s. He started a record company and distribution and sales. Ended up in fashion and owns one of the biggest fashion companies in Japan, and has become a fine art collector and just kind of a philanthropist. And
he's been out to space already.
He's already not only been to space, like, you know, he's been to the International Space Station. He's been on orbit and on the ISS. And so what's cool is, like, you know, there's talks of, frankly, to be honest, like I still don't know all of the details about this. You know, we're not yet into training. I kind of always assumed prior that there'd be some professional astronaut. You know, when they talked about it in 2018, there's talks of we'll have a professional astronaut on board. But realistically now, like, MZ is a trained astronaut, you know. Mm-hmm. He has trained for a long, like 6 months, you know, plus to be able to fly on Soyuz. So as far as like, it's good to know for me that I have someone on the crew that has experience with spaceflight, has trained and has some knowledge on spaceflight as well. That is an important aspect for sure.
So you made an excellent video about flying in a fighter jet that I think you mentioned may be relevant to the training. Is there some high-level aspects to training that you anticipate that you might be able to speak to?
Yeah. So, so far, I think we can really lean on what has happened with the other, commercial crew missions and in private missions like the Inspiration 4 mission or Axiom, where SpaceX flew individuals. They trained for about 6 months, a lot of like reading manuals and learning the spacecraft.
Are you going to do like a Rocky 4 montage or something?
I hope I just get shredded. I hope it's physical, a lot of physical training.
And they're like, we didn't tell him to do that. He just seems to want to film himself shirtless in the snow. It doesn't make any sense. How is this relevant?
Why is he always doing this? I can't get him to stop punching meat. So yeah, hopefully, realistically,
that's a manual reading. I like it. But there's a physical component to all of this, and that's really, I mean, that's fascinating. And it's also inspiring that sort of civilians can do this. That's really interesting.
Yeah, I mean, this is, and to me, this represents this and the other commercial space, private spaceflight missions like this represent really a turning point, like truly an inflection. And again, it's easy for people to be cynical that, why are people wasting all this money doing spaceflight stuff? It's like, well, I'm sure some people were saying that same thing about, airplanes and early aviation, going like, I can't believe those people are wasting the government's, funding these stupid planes and stuff. How's this ever going to benefit me? And nowadays, like, imagine if all the planes just stopped working. Like, we'd freak out. Like, our economy would collapse.
Yep.
It would suck, and it might be a long time before we get to that reality with spaceflight. Well, no, if spaceflight halted today, space assets, all of our, on orbit assets, our life would be crippled. And I don't think people realize that.
Yeah.
So we're already reliant on it.
Yep.
But now we're getting to the point where we're really turning that corner where it's the average person alive today. If you're born, now or from now on, I think there's a real decent chance that by the time you pass, there's an opportunity to have flown in space.
Yeah, I mean, if I'm being honest, I still haven't lost the feeling of magic of flying in an airplane. I often catch myself thinking, like, how is this real? And like the contrast of this incredible thing that's incredibly safe, flying through the air, taking off and landing, while everyone else just looks bored watching, like, I don't know, some romantic comedy on their phone with Wi-Fi.
Yeah.
So it's just, it's like the contrast of that is like, wow, we're incredible. We're incredible as a society. And it's like we develop some amazing technology that improves almost immeasurably our quality of life. And then we take it for granted and now still reach for the next thing and the next thing. And life becomes more beautiful and complex and interesting. And it's just the same stuff will be happening. With space travel.
It'll become mundane and boring at some point.
The tough thing about space travel, of course, I don't even know if it's such a giant leap over airplanes because airplanes are already incredible. But the tough thing with space travel is the destination, right? Is the landing on whole other worlds, whether it's docking with different transport vehicles or the space station, or it's landing elsewhere. I mean, it really is incredible. I think you mentioned, since there's artists, there's filmmakers, and so on, and you're all of those, on top of being a great athlete. I don't know. I'll just stop the running joke at this point. But have you thought about just in general, like we've offline talked about microphones and like all the different ways to film space launch, rocket launches. Have you thought about the different options of like how to capture this? Have the team have been like brainstorming and thinking about this? Do you anticipate it being super challenging? Because there's so many opportunities to sort of think of how to do this.
So one of the fun things to remember is that Starship is huge. Like its internal volume is, the pressurized volume on Starship is bigger than a 747's pressurized volume. And it can take 100 metric tons to anywhere with enough refueling. 100. So we have, in theory, very little mass and volume constraints.
Mhm.
Unlike prior all other spaceflight missions ever, you have to, you're counting,
Mhm.
grams down to, and just really can't risk, you have very defined parameters on what you can and cannot do. We're going to likely have the luxury of being able to film and capture this in a way that's just never been done before. We won't be inhibited by mass and volume constraints like prior.
Yeah.
So all that said and done, I'm hoping that we'll be able to just arm ourselves to the teeth with the absolute best cameras and equipment possible, backups on backups, and and pre-wire, like pre-rig things. Starship is going to be a transportation system, and it has, it's being built from the ground up. There's no reason why they can't put infrastructure in for cameras that are just housed in the vehicle. These are talks that I'm excited to have, because I really, ideally, one of the things I'd love to do, I'm going to be pushing really hard to actually try live streaming from inside during the launch.
During the launch, live stream from the inside, that would be incredible. If
Wouldn't
that's
that
possible
be?
if that's possible to pull off, that's really, really incredible.
Now
There is the magic to the live stream, because like that's real. That's right there. That would, the world would tune in. That would be truly inspiring. Yes.
To me, that's one of those things. A lot of people ask why they aren't doing it. Of course, NASA and other individuals have their reasons of why not. There's obviously some technical hurdles, but now with Starlink and other capabilities, there's less hurdles. There's obviously some transparency reasons why, and safety reasons why it might not be a great idea to live stream a risky rocket launch. The Challenger, I think, put a pretty bad taste in our mouth as far as publicizing an event and having every student in the United States tune in to, a tragedy. But that's something I'm pushing for really hard, just because I think it could be magical. I think it could really connect with people in a way that hasn't been done before.
Speaking of Challenger, have you thought about the fact that you're riding a thing, as we've been talking about, that's a giant, explosive, powerful rocket? Have you thought about the risk of that, the danger of that? Have you contemplated your own mortality?
How could I not? I've seen and felt 4 of these prototype vehicles blow up, with my own eyes. I don't know if there's anyone else, early days, some of the, Mercury and Gemini astronauts watched failures of rockets and then got on them. I don't know of too many people that are dumb enough to do that, though, this day and age. It's obviously, I will have to see a lot of successful launches and have to have a lot of confidence and in the engineering, the data, that they've developed a safe system. Because currently, the current iteration of Starship has no abort system, has no escape tower. So, Dragon capsule, which is currently flying people, has a launch abort system. It has Super Draco engines that, either by the push of a button or by the automatic triggering of the flight computer, can shoot the capsule off of the rocket in milliseconds and pull it safely away, get it far enough away that it can pull the parachutes and safely splash down. Starship, by all iterations I've ever seen, does not have that. The space shuttle also did not have that. So it's not absurd to not have an abort system. Like, there is, certain engineering principles that prove that could be a completely valid thing. The space shuttle flew 133 times fully successfully. It did have 2 failures, resulting in the loss of 14 lives. 98.5% success rate. Pretty,
Yeah.
There's other, I've probably done things that are a lot riskier. I have raced motorcycles, drag race motorcycles, and, ridden like an absolute jerk on the streets on a motorcycle. I'm sure I've had a higher than a 98.5% survival rate, or lower than that, at some point. So it's yes, it's risky, it's scary. And I think about it a lot. It definitely is one of those things that I will have to see. And I'm in no hurry for this to happen either. Personally, I'm in no hurry, because it's like, I would rather see this thing be developed and iterated and see 10, or I was going to say 10 dozen, but I'd be happy with a dozen fully successful, like, oh, we've got this thing totally nailed down, before I get on it. But and that likely is the reality. There will likely be a dozen or 2 or 3 launches, because just even to get to the moon on Starship, they have to refuel it in orbit. So it will get to Earth orbit basically empty and out of fuel. So I'll have to dock with a fuel depot, fill up, and then go to the moon. So just to even get that full, we're already talking about a handful of launches. So there will be a lot of launches before we fly.
Would they do a test flight without humans on board that goes to the moon, or no?
I'm not sure. I'm not sure if they'll do that exact flight profile, but by then they will have already flown. Most likely the Artemis 3 program will have flown a Starship variant to the moon that lands on the moon. So at that point, you're pretty much, I would like them to test the heat shield at that entry velocity, though, because it is, it takes it's about 30% faster to get, like, to go 30% faster than low Earth orbit to get out to a translunar injection. And although that only sounds like, oh, 30% faster, it's, the reentry heating experienced by a vehicle goes up by velocity cubed, not squared. So, and not linear. So it's not like if you go twice as fast, you see twice as much heat, 30% faster, 30% more heat. It's not squared. It's not go twice as fast, get 4 times as much heat. It's go twice as fast, get 8 times as much heat on reentry. So 30% faster on reentry is actually a really, really big deal. So I would love to see that be tested. There's certain things that I would love to see, milestones that I would love to see tested out and proven before I get on board. But at the end of the day, I really do believe that just like Falcon 9 and the success of that they're going to push it and get all the kinks out well before anyone's on top of it. Nowadays, Falcon 9 and Dragon is, arguably one of the safest, most reliable, and best rides you could take to space.
Are you afraid of dying?
Yeah.
Is this one of the first times you're young?
Yeah.
Have you gotten a chance to think about death as one of the first times you've really contemplated it?
I mean, yeah. I mean, like I said, I've had dumb moments on motorcycles where I kind of saw, like, I'm going to smash into this thing at 120 mile an hour, and I'm going
So you've had moments when you realize it could end just like this.
Yes. Where you literally, I have for most of my adult life had dreams of falling and hitting the ground, and it just you get a ringing in your ears, it all goes black, and in my head I go, oh shit, that was it.
Have you seen a therapist about this? Or
I
wonder what it means.
So I'm
sure there's a Freudian interpretation somewhere in there that I'm going to also apply to my dating life. No, the joke is the running joke continues. Okay, so I mean it's fascinating in general, as I hope we'll talk about in the early days of spaceflight, that there is the task of reaching out to the stars is a fundamentally risky one. You have to take risks, and of course, there's really rigorous safety precautions and so on. But it's still a risk.
Well, and I think, like most people, for me, the idea of dying isn't so much about myself; it's about those affected by it. My loved ones, my family, my girlfriend, my friends. Obviously, I don't want to have this be a traumatic experience for anybody. It's already going to be hard. Like, it's already. I know my mom gets my parents and family and friends are very supportive. And, my parents are, all about it, of course, but my mom is also very emotional too. So, speaking of athletes, my brother-in-law has actually been on American Ninja Warrior 2 seasons, phenomenal athlete. And even just when he competes, my mom gets so emotional, like she can't even hold it together seeing that. So what's it going to be like when she sees her son get on top of a skyscraper and ascend on a column of flames into the heavens? Like, that's going to be very difficult, and I've taken them out. They've seen Starbase and they've seen Starship. They've seen a couple launches.
I don't know if that's going to make him feel better.
Hey, exposure therapy, I guess.
Exposure therapy. Okay. Have you had that conversation with them about this, like before agreeing to join? I mean, was that what that was, or is it one of those things like, you don't have that conversation? I suppose it's understood that there's a love, there's a passion here.
And realistically, I'm not I'm going to be convinced and statistically convinced that this is relatively safe. You know, like again in the 99% safe.
Yeah.
Again, there's things that people do every day that are less safe than this. You know,
Like you riding a motorcycle.
again, yeah, riding a motorcycle, doing wheelies at over 100 mile an hour. Not
You
the
did
smartest.
wheelies over 100. What? How, what? All right.
I'm not a smart guy always. Okay.
Well, you know.
Formation flying in the fighter jets was likely a more dangerous thing
Yes.
than what I'll be doing in spaceflight.
So, as surreal as it is, we're talking about you flying around the moon. Let's rewind and talk about the origin story. What's the origin story of Everyday Astronaut?
I used to be a professional photographer. So from 2008 until the end of 2016, that was my income, was photography full time.
Like you were an Instagram model and took butt pictures of yourself? Or
Instagram fitness model.
Fitness
obviously.
model, obviously.
No, I did a lot of weddings. I shot 150 weddings,
Wow.
all around the world.
So subjects, all kinds of material, like did you portrait also?
A lot of portrait work, and then just random like commercial things like food and beverages for businesses, or like wheelchair ramp company. I shot their product line. It's random whatever a professional photographer does in Cedar Falls, Iowa.
When did you fall in love with photography, with a visual medium? Do you remember?
Yeah, I do actually remember. I grew up drawing constantly. I was the weird kid that I would bring a sketch pad to the restaurants. Like every restaurant when I was growing up, until I was like 18, 19, I literally would just sit there and draw while we're waiting for food. And my parents like fostered that. They would, and I'd be the weird kid, but I'd be engaging and talking, but I'd be sitting there drawing. And I was always obsessed with realism and like recreating and, visualizing things. And so when I got my hands on a camera, it was actually my dad's old Pentax that I first shot on a film camera, and developing the film. I didn't personally develop it, like, getting the film back in those days. I just was like so excited about the idea that I had this visual thing that I saw with my own eyes, and now I can stop time and capture it and show it to other people. Just kind of like, to me, that was like the ultimate form of realism, was like literally showing you the photons basically that affected this film. And so I was 19 when I got my first digital SLR, a Canon 20D, and started shooting. And yeah, I fell in love with it. It became like I got a job at a camera store, and basically all my extra money went into buying everything that I could at the time. And I only worked there for about exactly a year before I went into pursuing photography full time. And I basically was shooting weddings so that I could travel and pay, like, afford to be able to do some big trips every year and develop some kind of, portfolio of traveling, and not necessarily like, not for, I guess Instagram wasn't much of a thing at the time. It's really just, I liked making big prints and having them displayed and that kind of stuff. And
Are you still a Canon guy? Are you still a Canon elitist?
No. I moved around. I did Sony for a bit. I still kind of shoot mostly Canon glass, but adapted to either Sony,
mean? What's
like
Canon glass?
lenses. Sorry, like Canon
Glass.
lenses.
Look at you. What do you think about these things that I'm using? Sony A7 IV.
Great.
It's great. See, yeah, it's
Yeah.
I've been, I Googled around just trying to find a camera that can do video and photography pretty well. And obviously going with just like generic lenses, prime lens. I resisted everything. My whole journey with these camera things, I'm trying to figure stuff out. Is like prime lenses seem so stupid. Like, so for prime lenses, it's like a fixed zoom thing.
Yep.
It's like, why? Because I remember I was going to like Ukraine and thinking it's similar, like, very similar to spaceflight. But you're very constrained because you're going into an unknown environment.
Mm-hmm.
You go into a war zone. You go into a front. You don't know you don't know anything.
Right.
And there's like a little suitcase. You have to like figure out like, how do you film this? What's robust? What gives you like a good image versus the flexibility versus the weight. Because weight is important there. You have to think about like, can you really bring like a bunch of zoom lenses and all that kind of stuff.
Yep.
So I had to learn really quickly. But yeah, it's a whole journey that you've already been on. But it's nice to have a beginner like me, like to
For sure.
explore that. I think there is there's a nice thing, just like as we've been talking about with the beginner's mind, to not let equipment get in the way of like what your vision is of what a thing should look like.
Yeah.
Sometimes, like, especially if you're a professional videographer, photographer, cinematographer, whatever you call it, you can like fetishize equipment too much. You could get so much equipment. And I've interacted that because I've been trying to learn from other people that have so much more experience than me. I think their advice is often like very pushing a lot of equipment versus like the final thing. Like, how do you create the art of it? And like, because to me, even photography is just like storytelling. And so, like, a lot of the discussion to me that I enjoy, especially talking to creative people, is like the final story. Like how, and I've learned, you know, like light is a weird thing. Like, it's so interesting. It's so interesting how you can create emotion with light.
Mm-hmm.
Like with a little, you can take a phone and like you light your face in different ways, and like it changes the emotion.
Oh yeah,
it's so weird. I'm like, holy shit. Like, because like that's the conversation I want to have. Like, if people give me advice how to light a scene, all that kind of stuff is great, but the reality is that a little bit of light in a different direction, that you have to understand how that changes
the contour on your face and everything,
and the expression that your face can, like the expression that could be effectively communicated under different lighting conditions. And then like the mystery of like having some of your face in darkness and some not, when you can only see the eyes and not the face, when the background is visible or not. I mean, there's it's all just like this interesting art form that can be so powerful when you're telling a story.
Well, and what's fun with me with photography and rockets, they're both like the ultimate story of compromise. Because when you start learning about photography, you learn about, you know, how the aperture affects both your exposure, but also your depth of field, how your shutter speed affects both your exposure, your depth of field, how the, you know, a medium format camera versus a crop camera affects, you know, everything is a compromise, and price versus performance. You know, like there's always a compromise. You're always literally doing like a trade study of what can I afford? What's my outcome? Like blah, 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 blah. How fast is the autofocus or whatever? Same with rockets. Like there's a million choices and every single one of them affects every single thing. So there's always all these trades, and it's so cool that you can see the same, totally different outcomes based on the same like requirements. You know, like do X, and here's how we're going to do it. And, you know, two teams of people will come up with wildly different things.
When did you fall in love with rockets?
So yeah, so the story kind of keeps going for me. So I was doing.
Sorry to interrupt. Really.
Can't talk photography, man. We'll go on a deep rabbit hole there. So so it ended. You know, I'm through all this doing a lot of weddings. I was already getting saturated and feeling like I'm not being as creative. You know, you can only shoot them so many weddings before you're like, well, now we do this pose, this pose, this pose. You know, even if like they're amazing places, like, you know, in front of a castle in Germany or something, I'm still like, well, at the end of the day, I'm not being very creative, you know? So I remember craving like some projects. And so I was sitting at my friend's coffee shop in my hometown in Cedar Falls, Sidecar Coffee. And I'm sitting on this red couch and I see this article from, I think, Gizmodo, and it said, you could own the flight stick of an Apollo command module. And I knew enough to know what that meant, but that's really about the end of my space knowledge. And so I clicked on it. The clickbait got me. Like, I'm like, oh yeah, I'm going to see if, you know, and I see that the minimum bid was like $250,000. I'm like, okay, no, I can't own the Apollo joystick, you know, but it got me on this website called RR Auction. And so I started scrolling through that, looking for things that hadn't been bid on. And they had like, you know, at the time they're doing a huge space auction. And so I'm looking for things just out of curiosity, fun. These are cool. Like, it's starting to really, you know, like I said, I like space, but I wasn't like in love with it or anything. But I'm very just seeing all this stuff. I'm like, this is so cool. Look at all this old history stuff. And I ended up seeing there's an article for a VMSTK 44 flight suit, high altitude flight suit that came from the Soviet Union, and looks, you know, it's like a MiG fighter pilot suit, very similar to like the SR-71, like kind of pumpkin suit, semi-pressure suit with a, you know, full helmet. I mean, it looks like a spacesuit, you know, for all intents and purposes, it's kind of like a spacesuit. And I just bid on it. You know, I bid like, I think $325. And next thing you know, like it arrives at my door.
Yeah.
And from that point on, like literally I got it out. I immediately try to put it on. And the first thing that I do is almost die in it because I closed the helmet down on myself and locked it and didn't know how to unlock it. So I'm literally, and so as soon as I seal it up, I'm realizing I can't breathe. I'm going to run out of air. So luckily, like there's a hose, you know, kind of that long hose thing that would normally plug into an air supply, had a little plug on the end of it. So I just unplugged it and was able to temporarily breathe through the hose until I figured out the locking mechanism. So there was that was my mortality rate thing right there. So that was probably above a 98 or below a 98.
So you're there panicking inside for a few seconds.
Already reading like my premature obituary, like idiot dies alone in spacesuit in his living room. You know, like just imagine.
Yeah.
That would be like Darwin Award for sure. For sure.
Oh.
So so I get the spacesuit and it kind of
literally take my breath away.
Right. You should feel bad for that one.
You introduced Creed to me, so you should feel bad about that one. Stars wide open. But yeah.
Okay, so I ended up like the spacesuit kind of like more or less haunted me because it kind of just it sat in like my living room for a long time and I didn't know what to do with it. And I actually had a friend who is also a photographer, wanted to do like a photo. He was just kind of taking pictures randomly. He's like, "Hey, bring your spacesuit over. We'll do a picture." It's like, all right, you know, I walk across the street. He literally lived across the street, Taylor, and I put the spacesuit on. He took this funny picture of me, like, "This is awesome." And I got a lot of like fun out of like creating a character, you know, of everyday astronaut. Or at the time, I guess I didn't know an astronaut. Mm-hmm. And then that kind of just continued. I was like thinking of more and more funny situations where I could have this astronaut on Earth doing mundane, everyday things. And came up with the name Everyday Astronaut. And originally it was just literally a photo project, like this whole art series of an astronaut doing these things, these funny, whimsical, you know, silly, mundane things. But I was researching a lot about like, you know, I was trying to hide Easter eggs. Like I was going to hide in like the, you know, the echocardiogram of Alan Shepard, you know, like his first flight into space and photoshopping that into pictures and like, you know, doing all these little like facts about spaceflight, but they're just hidden little elements in these photos. And man, doing that, I just fell in love with it. I just was going over every little detail that I could learning. I was just couldn't stop learning. And I was getting excited because I was like, I could be teaching people about all this exciting stuff and all the cool things people figured out, you know, 40 years ago, 50 years ago, and was trying to portray that through images on Instagram. And, you know, it took me a little while, but eventually I realized, you know, on Instagram, your retention rate, you're lucky if you get like 2 seconds of someone looking at an image, you know, or maybe nowadays 60 seconds of a quick little Instagram short or something. But yeah,
it doesn't give you a chance to really teach, to explore a little topic that you felt the curiosity about the thing. There's so much to learn here. This is so beautiful.
There's so many opportunities to have a light bulb go off for someone and be like, this is awesome. And so, yeah, I think I started, so by the end of 2016, like throughout 2016, I realized I want to be done doing photography as a profession and I want to pursue Everyday Astronaut. But I didn't know what it meant yet. I just knew like I had this thing, you know, and at that time I'd been doing it for roughly 2 years and had, you know, seen, I don't know, like 50,000 Instagram followers or something. I thought like I could just be a full-time influencer now, you know, like just go around taking pictures of myself in a spacesuit and doing public appearances and write a children's book or something. I don't know. I don't know what this thing is. I'll figure it out, you know?
Yeah.
And so, it basically, I gave myself like a runway of 1 year of 2017 of like, I'm going to throw stuff at the wall and see what sticks. So I was doing like Twitch streams. I was playing Kerbal Space Program, which is like a video game, like a physics-based rocket building simulation game, but it's also like, it's fun and silly because you're not playing with like humans. You're playing with these little Kerbal, like little alien guys, and it's fun and silly. You know, streaming that on Twitch and doing things and posting some of those things onto YouTube. But finally, like I said, it actually happened to be February 27th, 2017, when SpaceX had that announcement that they're flying someone around the moon, that I got to tell people about this, and stood there and made my first like produced YouTube video. And I didn't want it to be over 3 minutes. I was afraid that'd be way too long for YouTube. And I got it down to like, I don't know, 2 minutes and 40 seconds or something. And that video,
you, wearing
I was wearing the spacesuit.
The spacesuit.
Yep. and very
There.
like horrible audio. It looks like it was color graded by a 7-year-old with a tan marker or something. Like it just looks terrible. Sounds horrible. I'm yelling. No one's happy. but but the video, did relatively well. Like I had no followers on YouTube. Like I had, maybe 102 or something.
Is the video still up?
Yeah.
That's great. I'm gonna have to watch it after
It's
this. This
so
is
cringy.
wonderful.
And as it should be, your
Yeah.
first video should be terrible. If it's not terrible, then you spent too long trying to make it.
Yeah.
So, the thing that clicked for me is I had very little audience, and all of a sudden that video kind of took off. Relatively, I think it got like 10,000 or 12,000 views, and I was like, "Holy crap, that's way more engagement than
I'm
I'd have." on
famous.
Instagram. I'm famous now. 10,000 people. That's almost my whole town.
First of all, that is kind of crazy. Like 10,000 people is crazy. It's
Yeah.
crazy. Like if you had 500 people attend a thing that you do, that
Yeah.
would be like you're like a rock star. It's crazy. I mean,
We lose perspective. I think.
yeah, we really lose perspective very quickly.
Very
Yes.
quickly. So I made another video. This one I spent more time on, and I had before photography. Actually, I used to do like wedding videography too. So I had done my woes with videography and weddings and stuff. I hated video. Like I thought video was the worst. Took so long to edit. And I love photography. It's like boom, you snap it, boom, post, you're done in an hour.
Yeah.
And video, it's like this whole cumbersome thing. So I thought I'll never do video. And here I was making this long, what at the time seemed like a long 7-minute long YouTube video about how the Falcon 9 lands. And again, like that one I posted, and it did really bad. And I was really upset. I'm like, I spent 2 weeks on this stupid video, worked really hard scripting and blah, blah, blah. And then it, had like 1,000 views or something. It did much worse than the first video. And I was so upset. And I kind of like was ready to keep throwing more spaghetti at the wall to see what's going to stick for Everyday Astronaut. And I think it was like a month or two later, I happened to like, check the analytics on YouTube, and all of a sudden, that video like kind of took off, and it got like 40 or 50 or 60,000 views or something. I was like, no way. And it just kept, that just honed it in more. That like, okay, YouTube will bring bring an audience to me, as opposed to like Instagram. I had to find and, try to get the audience to come to me. And this was like, they were going to do the legwork. So if I make decent videos, and I realized like really the fun thing for me was explaining a topic that was scary and intimidating, and try to make it, fun and engaging.
What were some of the struggles of building up a YouTube channel? So for people who don't know, once again, you have a YouTube channel called Everyday Astronaut, and there's some incredible videos on it. So what was some of the challenges and the struggles in the early days?
Definitely, like at first, you're not going to find your own voice, and I know, like even Jimmy talked to you about that, like how your first video is going to suck. You're not going to be yourself. You're going to be nervous. You're not going to know the tone, the pace, the things that are interesting. And actually, originally, I had constraints. I was really worried about making a short video because I thought there's no way anyone's going to watch a 3-minute video and then a 7-minute video. And pretty quickly, I realized like YouTube as a whole was kind of changing, but also there's always that historic backbone of like 22 minutes of programming for a 30-minute spot on TV. Like no one goes over 22 or 44 minutes, if you have the full hour special or whatever. Like that is the absolute limit of what a human being can watch, basically was what I thought.
Yeah.
And slowly I just kept playing and getting longer and actually more and more in depth into the topics. And instead of getting like pushback, and being like, this is so boring, I realized as long as as I was walking people through the whole step, giving them all the context they need, they're happy to get as deep into the weeds as I can get them. And so that just kind of fed the snowball, just kept rolling. And I'm like, all right. And, before you know it, I'm making hour-long videos. Like an hour long is more or less a normal length on my channel for a produced video. And they're really, really in depth. But I love like that process of trying to preemptively kind of guess what the questions might be. And part of that is like we do like script read-throughs with like our supporters, and do like cuts of videos, and a decent amount of people see it before it goes public. And we get those questions out of the way. We get those people asking the questions. And then I love nothing more than trying to, get all those questions answered by the end of the video.
A question about being a creator on YouTube, there could be a challenging psychological aspect to it, which is like you might invest a huge amount of your effort into a thing, and it doesn't receive much attention at all. And there's something about YouTube and in general social media that makes you feel really crappy about that if you let it. If you really look at the numbers, It's very, very difficult not to pay attention to that. I mean, that's the reason why I turn off numbers on my interface for stuff that I've created, because I just see it having a negative effect on your mind. But even then, it still has an effect. I mean, your epic video on the history of Soviet rockets comes to mind, and we'll talk about that in a second. But it's called, people should check it out, the entire Soviet rocket engine family tree. So that's something you've researched for 2 years.
Yeah.
Right, you put your heart and soul into it. There's a lot of passion. There's a long journey. It's I think about like an hour and a half video. Is there challenges? Is there like, how difficult is that to put so much of yourself into a video and it maybe not do so well?
Yeah, that's the struggle for sure, honestly, especially as we grow. I try to make better and better videos, which means hiring more and more people to do, higher end animations and spend more time editing and shooting and scripting, and but at the end of the day, like, it still can't be just losing money.
Mm-hmm.
And I have videos that definitely lose a lot of money because I, hire 3D artists and stuff. And I was so certain the Soviet rocket engine video I thought was just purely going to be a passion project. I honestly was like, if it ever crosses 1 million, it's a home run. Because
and does it cross like a couple million now?
I think it's a little over 2.
Wow.
Which is insane to me. Like, I just really thought this was more something just to put on the shelf as a resource, almost for myself, like, just to kind of have that knowledge bank, and something I've always wanted to straighten out in my own head and kind of know the history a little bit better. But come to find out, like, it took a while. It was a slow churn.
Well, I remember when you first released it, and that's when I watched it. I remember, like, this has so few views.
Yeah.
I remember being just sad. Like, I was like sad about the state of the world, because I know how much love you put into it, how much, I don't know. I to me, for some reason, that somehow would directly connect to huge views. But see, what made me sad is, like, if you use a different thumbnail or a different title, that could affect the popularity.
Yeah, I know.
And then I just could imagine the torment you're going through. What if I used a different thumbnail? It's that Jimmy, the Mr. Beast torment, like, just a slightly different title, or a slightly different, it could change everything.
I have videos, is ironically, the last, like, I don't know, 5 videos I've produced are horribly flopping. Like, some of my worst videos I've ever made, statistically.
The interesting one is, like, you summarize incredible video. You summarizing that people should go watch about all the awards video for 2022, like all the cool stuff that happened in 2022. I remember that not being that popular. There's a few ones recently that are not that popular,
like riding in a fighter jet. I thought that was going to be easy, like 1 or 2 million. Yeah. I don't know if I've paid the flights off to go there. You know what I mean? Like, in that video,
it makes no sense.
Frankly, here's at the end of the day.
Yeah.
I realized, like, I have lately, especially the last, like, year or two, kind of disconnected from that aspect of it. I'm super fortunate. I have very generous, like, Patreon support and people that can help me sustain to produce.
People go support Tim on Patreon.
Well, it's that, but as as a creator, like, that is what keeps the lights on it and makes it so it, I can go this deep. Like, if I didn't have that, if I had to rely solely on, like, YouTube ad revenue, I mean, they'd be super different videos. I wouldn't spend as much time researching, because they'd just be more glossed over. It's like a hurry to churn them out so I can keep the machine going. And I have this incredible freedom to really dive into a topic. Like, a video that I've been working on now for almost 3 months is how to start a rocket engine. And let me tell you, it's not as easy as one might think, or I guess as it is as difficult as you might think. I mean, it's an insane topic. And
what do you mean by start? You mean like the ignition?
Like how do you physically get them running? Like, there's all these, the valves and the turbine, that we were talking about earlier, like, that has to run on the pumps, but it itself is powering the pumps. So how do you get that, like chicken and egg? How do you get that thing started? There's tons of, it's so cool. There's so many ways. And so for me, that required reading a lot and talking to people that know a lot more than me. And just really trying to make sure I understand enough of it to explain it and try to weave a narrative, And so that video is 3 months in the making. We're still probably another 2 or 3 weeks out. And I don't expect, I mean, I think this one will do relatively well, but in the grand scheme of YouTube, like still child's play. But I'm okay. And I'm okay with that. I'm at that point actually where I am okay with that. It still stings. And I'm more worried about just like, can I continue to do it at this quality and at this level if it's losing money? You know what I mean? So there is a trade-off, and I am kind of having to navigate that.
But you have sort of the depth of the impact you have is a thing that YouTube can't give you numbers on, but it's a really important thing to sort of remember that it's really not just about the YouTube numbers, or it's off for people like you that are basically educating and revealing the brilliance in a technology that will make humans a multiplanetary species and give hope to millions of young minds that will build that future. I mean, that's immeasurable. That's not just the views. But it's that's really important to sort of remember as you're creating it. That's something
100%.
I try to think about as well. So like views,
and that becomes more.
Don't matter.
I realize that more and more, like every day. The more the channel matures, the more I realize the importance of it as an overall mission, as opposed to like, in the first year or two, it's a rat race of growth and of popularity and all that kind of stuff, and you feel that. You feel that it's a driving force. These days, not so much, just because that will wear you out very quickly.
So back to the Soviet rocket video, the epic video, probably the most epically researched video you've done. I mean, it's truly an epic video. So what, again, called the entire Soviet rocket engine family tree, took you 2 years to research. What are some fascinating things you've learned about the history of rocket engines in the Soviet Union and in general through the process of making that video?
The coolest thing to me is how it's this weird blend for the Soviet Union went through an insane iteration process and made so many engines. Like I didn't even touch, any like maneuvering thrusters or missile engines. Like I only really dealt with main propulsion engines on orbital rockets, and there's still way too many to talk about. I mean, it's still dozens and dozens of engines. And I could have gone deeper into this, which is hilarious. They iterated so much, made a new engine for just at the drop of a hat. Yet they still also like did super primitive things. They physically are still today lighting the main combustion chambers of the Soyuz engines of the RD-107 and RD-108 with essentially matchsticks. Like they literally stick a T-shaped thing up into the chamber and have a pyrotechnic in it that ignites the actual propellants in the combustion chamber. It's not the most elegant solution in the world.
Yeah.
They're still using that. So they went from like the whole spectrum of like, it's the mixture of like, make it better, faster, harder, stronger, gooder, all the way around, to also, if it ain't broke, don't fix it. It's like, it employs all of the above.
So it's like, it's a lot of innovation, but also they use duct tape. So like,
Yes.
it's like all of it together.
Yes. That's exactly that's exactly the way to put it. And they did things that are insane. They developed a full flow stage combustion cycle engine. This engine, had it been used, I mean, it would have put it was same relative size as the F1 engine on the Saturn V, like in that same category, way up there of like, 6.7 like meganewtons of thrust or something around, and then the F1 is like 7 or something. It's huge, yet way more complicated, way more efficient, way just better engine in that sense, as far as performance goes. Yet it never flew. It never left the stand. They never built the rocket around it. The N1, which was the most powerful rocket to have flown so far to date, like it never made it through its first stage burn. All 4 attempts failed spectacularly, and yet it had so much technology on it that was still unrivaled today almost. Like finally now we're beating it, the NK-33s that they developed for that rocket. Like finally today we're to the point of like having better engines than they built in the 60s.
Yeah. What stands out to you from the N1 family of rocket engines?
Well, it's interesting because the N1 was the Kuznetsov Design Bureau, and he was actually an aircraft manufacturer. So he was one of the first people outside of kind of the missile and rocket program. He had all these other bigwigs kind of in the other OKBs that were developing missiles and rockets. And then all of a sudden, here comes Nikolai Kuznetsov, who had never developed a rocket engine. And so his first attempt at rocket engines was the NK series, the NK-15, NK-33, and they were amazing. They were brilliant. They were these wonderful closed cycle oxygen-rich engines that were awesome. They were awesome engines, and that were, because I love that because his direct boss, since he wasn't necessarily in the aerospace, or in the, I guess, the rocket missile defense world, he didn't have to. At the fall of the Soviet Union, he didn't have to give away all of his things to the same people as the other people. Mm-hmm. So he hid, like 80 of his engines in a hangar. And then we still literally used them in the United States. We used altogether, I think it was like 8 or 10 of them, repurposed them as they're called AJ-26s in the United States. But like we still were flying Soviet rocket engines in the 2000s because they were better than engines we are building today. Like to me, that's my favorite fact about the N1 rocket engines, that they're still that good, that they were the best choice for, at the time, orbital sciences.
Some of the culture that engineering has led to these things that still work. It's incredible.
Yeah.
You said that the RD-171 is one of the coolest engines ever made. Why is that?
Yeah. So one of the fun things about the Soviet engines is it'll look like a lot of their engines look like multiple engines, because you see multiple nozzles, you see multiple combustion chambers, and you would think, well, obviously, the nozzle is the engine, right? Mm-hmm. But what they actually would do, the real heart and the real power of the rocket engine actually comes from the turbopumps, comes from the pumps themselves. And, as we talked about earlier, that includes the turbine and the actual pumps that flow the propellant into the chambers. And so the Soviet Union was incredible at developing these closed cycle, high powered turbopumps. But if you try to scale the combustion chamber too big, you end up with what's called combustion instability. You have such a large surface area of crazy flames, and combustion happening, they can get these weird pockets and oscillations and frequencies, and they just couldn't make big combustion chambers. They never figured it out. They never quite, well, they did actually kind of figure it out, but they didn't like it. So they ended up just shrinking down and having small combustion chambers and just splitting the pipes, basically. Instead of one fuel pump one pipe going into one combustion chamber and one oxidizer pipe going into one combustion chamber, they'd split it off into two or four combustion chambers, and kind of spread that work around so that they didn't experience this combustion instability. So the RD-171 is like still to date the most powerful rocket engine ever built. The turbopump is insane. I don't even remember how many, like 200,000 horsepower or something comes out of that turbopump in order to flow the amount of propellant necessary at those rates and at those pressures into the combustion chamber. So it has 4 chambers, and it's just an absolute marvel of engineering. And yeah, and then the cool thing too is, specifically with the RD-171, its engine, all 4 of those nozzles can actually pivot and rotate. Mm-hmm. And I just now, as I'm explaining this, realized that has to mean that they have joints, like flexible joints in the high pressure pump lines, mm-hmm. in order to, like, this is the realization I'm having right now, because normally you put the gimbal above the turbopump, like the mount where the engine swivels, so that you have low pressure coming from the tanks into the pumps. And then you just have a straight, fixed pipe flowing into the engine. So you don't have to bend that pipe and have it be dynamic. If they had the 4 chambers moving independently from each other, that means those 4 chambers all had to have a flexible high pressure pipe going, which I don't know if that's, why am I just now realizing this?
Yeah, so there's engineering challenges with that.
Insane.
So
I never even thought that was a thing you could do, honestly. I gotta look into why and how and what.
Yeah, I wonder why that design decision was made.
So the easier thing to do normally is you would keep those nozzles fixed, and then affix, like, say the Soyuz engine, the RD-107 and 108, they have a fixed main combustion chambers, and they use these little Vernier, or some people got mad at me for saying Vernier and Werner engines, that swivel themselves, and those provide your control authority. So the main chambers stay fixed, and then you get your roll and your pitch and your yaw out of auxiliary thrusters.
By the way, did you get anything wrong in that video? that people told you about?
Yeah, a few things. Yep. First off, we had a graphic error where we actually we copied and pasted a lot of our like After Effects projects.
Mm-hmm.
So our nuclear engines, one of them on screen says that it runs on RP1. It does not. It has basically all the wrong stats. We just didn't catch it in the edit. That we literally copy and pasted, and I say it right on screen, but in the voiceover, but on screen it's wrong. The other thing, and I'm excited to ask you about this. I watched, and I spoke with a lot of Russian-speaking individuals. We had a lot of research assistants that were reading and blah, blah, blah. I tried really hard to learn how to pronounce Sergei Korolyov's name. And I'm still going to say it wrong no matter what. My understanding,
yes,
and from listening to native speakers, is closer to Korolyov than it is Korolev.
Yeah, definitely. Sergei Pavlovich Korolyov.
See, I will never say it that perfectly, but I know it's not just Korolev. I mean, again, the English translation of it likely, I should have just said Korolev and said I'm saying it the dumb America way, but
but you rolled your R, comrade. Okay, it's excellent. So, let me just ask you the difference in the culture, because you've researched so many rockets from so many different eras, the Saturn V, and just everything you're seeing now. Are there some interesting differences, especially when you look at the space race, between the Soviet rocket engineers and efforts versus the American?
There's definitely huge cultural changes, and the fun thing is that they kind of spawned from the same. They have the same starting place. Both, the Soviet rocket engines and Americans all came from the Nazi V2 rocket and the A4 engine. Mm-hmm. Literally, physically spawned from that, because at the end of World War II, we took a handful of German scientists, and the Soviets took a handful of German scientists. And they both got their own some blueprints here and there, and the others got some blueprints. So we literally have the same. It's a weird thing where we're starting from the same thing and letting two divergent paths go crazy on their own development. So it's really fun to see the cultural differences. One of the things the United States did is they really would kind of take an engine and just perfect it more or less, and not really evolve that much. I don't know, and I don't know why. I actually need to do a history lesson on all of the U.S. engines, but it's literally as far as orbital class engines before now, it's like a dozen or two. It's a tenth the amount of the Soviets, and the Soviets just literally made up a new engine every time they had a new they wouldn't. And it was like a completely different engine.
Yeah.
So
I wonder if there's some aspect to the culture, and I don't want to overstate it, but there is more of a safety culture, I think, in the United States. And I think if you care about safety, or rather, you have, you're more risk averse.
Yeah.
So you care about safety more, about the value of human life and the risk taken there, that you will iterate less. So yeah. I think the Soviets, especially in the early aspect of the program, I don't want to overstate this, is some of it is just through stories, you just hear anecdotes. They're more willing to take risks.
Yeah.
Risks with human life, risks with spacecraft.
For example, the first orbital space flights from the Soviet Union, the cosmonaut had to eject out of the capsule and parachute to a landing.
Yes.
That's not very well known. And it wasn't, they hid that even from history as best they could at first, because they were slightly ashamed that they couldn't have a full recovery system with their spacecraft. They could physically recover it, but they wouldn't have been able to recover the cosmonaut in one piece. So instead, they had them just eject out of the thing and parachute to safety. That's insane. And so there definitely was some extra risks, but also a freedom to just push things to the limits and try everything. They threw all the spaghetti on the wall.
It's funny that most people probably don't even know the first person into space in America, and obviously everybody knows that. It's kind of interesting how the space race, and even World War II, even the history books, you ask most Americans, they think that America won World War II. Without America, the real heroes of World War II is America. You ask British people, they say, and everybody has a pretty good justification. Without Britain, without Churchill, Hitler would have taken over the world. And I think probably the strongest case is the Soviet Union case, that they're the ones that won the war. The reason it's the strongest case is where most of the fighting happened.
Right.
Most of the death happened.
Yeah.
Most of the destruction. But everyone has their perspective. And certainly on the space race, the great accomplishment is the first man on the moon from the U.S. perspective.
Yeah, I was going to say. Yeah.
And then Yuri Gagarin, from the Russian perspective, is like first man in space. And that, I think, still persists. And some of that in healthy forms is probably constructive to a little bit of competition. Just pushes all the great scientists on each side. But what do you think about this Yuri Gagarin mission of the first human in space? And the Vostok mission in 1961. Just in general, when you look back at that time, leading to the first man on the moon.
Yeah, April 12th, 1961.
Mm-hmm.
Yuri's night, baby. That's it's insane. What's insane to me is the first person in space didn't just go to space; he went into orbit.
Mm-hmm.
Yuri Gagarin flew around the Earth in orbit and re-entered. That's a monumental task compared to suborbital. So the United States did 2 suborbital flights in that same year. I believe in that same year, at least. I'm pretty sure in 1961. They flew for the first time orbitally in 1962. So they weren't terribly far behind to get a human into orbit. Like in the grand scheme of things, 10 months difference. But at the same time, like the fact that the Soviet Union just went straight to flying someone into orbit is monumental.
And I'm sure they did not do excessive, rigorous testing here. Because there is a space race, and you have the first is important. Just imagine being Yuri. What do you say when they're like launching him, like "Let's go" or something? Like, you're taking. We're talking about you being on Starship. Like, you're taking a pretty big risk being launched out into orbit.
Oh, hopefully a lot less risk than what Yuri went through. So Yuri, the crazy thing, remember those matchsticks we talked about?
Yeah.
There's 20 main combustion chambers on Soyuz, and there's 12 more Vernier engines that all need to be lit. So you're sitting on top of this booster, and they light all of those 32 combustion chambers on the ground, and then it has this insane separation process between what the Soviet Union would call the first stage and the second stages, but we would call it like the core stage and the boosters. They all, 4 of these boosters have to peel away perfectly from the core stage simultaneously. If one of them sticks on, mission failed. If one of them doesn't eject properly or drags into the other tank, it's a goner. So the staging process of the Soyuz is insane to me that ended up working out. It's just the technology in Soyuz. And I mean, more or less, that same rocket is what's still flying humans that are cosmonauts from Roscosmos and going to the International Space Station are flying on a variant of that Soyuz rocket still today. It's still like that big of a workhorse.
What do you think about Roscosmos as it stands today, its history and its future, in comparison to NASA and other national efforts, and in comparison to commercial spaceflight?
Yeah. I mean, utmost respect for the engineers involved and everything that's happened. I think Energomash is like still one of the greatest engine manufacturers when they have the funding to do so. But man, it seems like they're falling from grace as far as space prowess. The Roscosmos went from having, I think they got very comfortable at the top of, from 2011 until 2022 or until 2020, they were the only ride to the International Space Station. Since then, it started, I feel like in 2018, honestly, I think that's kind of when that's the first time I specifically remember a pretty nasty thing happened in 2018. I think it was a Soyuz mission to the International Space Station, had one of the boosters not detach and had to have an abort. But, that happened. Then all of a sudden, next thing you know, there's a Progress being docked to the ISS a couple years ago that spun the ISS, cartwheeled the ISS out of control. Followed a few months later, the Pirs module docks to the International Space Station, spirals the International Space Station out of control again with a thruster getting fixed on. There's a hole in a Russian segment. I think the most recent one right now, there's a Soyuz docked to the ISS that has a puncture in it and it's leaking coolant and will not be returning humans on it. So they're actually having to fly up an uncrewed Soyuz. And that one likely wasn't a manufacturing error. It probably was like a micrometeorite puncture, rendering the spacecraft unusable. We don't know for sure yet. But it's just really been like this fall from grace where they have all the potential. They have some of the best engines, some of the best rockets, and especially like right before the collapse of the Soviet Union, the Buran shuttle and the Energia rocket were incredible. Had they been able to evolve that into Buran 2 and the reusable Energia, they had a fully reusable Energia on the drawing board, and like I honestly fully think they could have done it.
Is it possible to return to a place where there is friendly competition between nations that ultimately unites and inspires the peoples of these different worlds, these very different worlds that have, especially recently, come to conflict over the war in Ukraine? The tension builds. The war, the conflict, the suffering is actually creating more and more division, creating more and more hate. I think, as we've talked about, I think science and engineering, and especially the most epic version of engineering, which is rocketry and space travel, unites people. Unites people even in a time of tension, conflict, and war. So do you have a hope that we can return to that place?
I think historically, spaceflight has been one of the most bonding things. We have countless examples of, Cold War enemies coming together and working together, lending a hand. Apollo 13, for example, of course, there is the potential that who knew where it was going to re-enter, since it was not in the planned trajectory at all for re-entry. And the Soviet Union said, hey, wherever they landed, like, we'll help you guys out, basically. And that was a pretty big thing at the time, obviously. We also, in 1975, saw the Apollo-Soyuz mission, which was an Apollo spacecraft docking with the Soyuz spacecraft. First time there's international collaboration. And again, 1975, still very amidst the Cold War. Yet we have this collaboration that I don't know what else could have done that. And think about what it actually takes to do that. You have to come up with a docking module that is, that takes the two different air environments and the two different docking systems, and talk to the engineers and mission planners and figure out, train together. The cosmonauts and the astronauts trained together and got to know each other. They were crossing boundaries and borders and coming together for this mission. And even if it was totally a fluff piece, like even if it was totally this like, cynical, just trying to make a pretty face for everybody for the cameras or something, obviously it still had an impact.
Yeah, the symbolic impact, but there's also the practical impact. I mean, a lot of people have to work together.
Yes,
and that has a ripple effect on the culture, on the different engineers.
100%. And even just the astronauts and the cosmonauts involved, like, think about what probably went through their heads during this process of like going from, oh my God, I'm going to have to work with them, to getting to know them and then sharing meals in space. Like, that's a crazy transformation of timelines. And I would love to, I do think that spaceflight has the ability to bond us and unite us, because it is ultimately, this tiny little planet we're floating around on. It is the boundary that we all share. It only takes you getting off this planet to realize, oh my God, we're all neighbors. We're all living in the same house together. And I do think ultimately, as we continue to expand our horizons and expand our exploration, that it has the potential to unite us more than it has the potential to divide us.
So one of the potential conflicts of the 21st century that I think everyone wants to avoid, both in the cyberspace and in the hot war space, Cold War, hot war, all kinds of war, all kinds of economic conflict, is between the United States and China. So China is going full steam ahead in developing a space program, doing a lot of incredible work. Like you mentioned, 64 launches in 2022 with 2 failures. But, moving straight ahead.
And by the way, those failures, we had a lot of startups. Like, a lot of the launches were from brand new companies. So to have 2 failures out of 64, I mean, that's still impressive. If you look at operational launches, it was flawless.
Do you see a pathway where there's, again, in that same way, collaboration or friendly competition between all the different companies and nations in the United States and China in the next, as we push towards the moon, Mars and beyond.
I held a dumb hope that China would actually be allowed to sign on to the Artemis Accord to be able to take part in this next step towards the moon. I mean, just imagine if they provided a propulsion module or a lander or something, and we actually came together to land on the moon instead of having another space race. It's like it would have been so cool. And yeah, I still am hopeful that similar to back in the Cold War that we might have something like that someday where we actually are collaborating. And it feels like sometimes we're really close to that, and then other times it feels like we're really far from that. And it just sucks because I know, and I try really hard on my channel to always separate and celebrate the work being done. Because at the end of the day, there's someone that's just going home to their family, clocking in hours, working really hard on pushing their program and doing engineering work. And it's we don't get to choose where we're born and what we're born into. So I really like to avoid, the political aspects of things and the geopolitical aspects, and just appreciate the science and the science we're seeing, and the progress that China's doing in the last 10 years is very akin to the, early spaceflight programs, and with the runway of just keep on going. I see no reason for them to be slowing down. So it's definitely something to watch and be interested in. And who knows? I mean, there really genuinely might be a race to the moon again, and there really genuinely might be a race to Mars.
The part of me is excited about that because a race is pretty cool.
Yeah.
But the hopefully it's friendly competition and some collaboration. It is true that maybe I'm being a bit cynical, but nations sometimes, governments and leaders of those governments sometimes ruin things. You don't often have, statistically speaking, it's harder to have a leader of a nation that looks beyond the particular political bickering of that nation. And you have a JFK type character that really steps up and inspires. I think statistically speaking, it's better to have somebody like Elon, who's a leader of a company, a commercial effort that is able to look beyond the borders of nations, and certainly inspiring educators like yourself to look beyond the borders of those nations and the geopolitical conflicts and so on to inspire people. I think that's just made so much easier. You can have more reach. Tim Dodd can have more reach than NASA, right? In terms of inspiring the world, and that's fascinating. That gives power to the individuals that see past the silly short-term geopolitical conflicts.
Yeah,
that's the hope, at least.
Yeah, yeah.
Do you worry that there might be a war in space?
Yeah.
Let's look out into the future. So forget. so the interesting thing about these rockets, right? Let's not forget, rockets do what rockets do. That they can carry payloads that can be weapons. Do you worry about this?
I worry most about space wars as leading to the Kessler syndrome of having a cascading effect of a spacecraft blowing up and then affecting another spacecraft, and that blows up, and then all of a sudden you're trapped and have this debris cloud that we can't go into space anymore. That's my biggest, because frankly at this point we could annihilate ourselves with terrestrial stuff anyway. You know what I mean? We don't need space to end society as we know it. You know what I mean?
Yeah.
But we could really, and the good thing is I think mostly everyone seems to understand this for the most part, that we really can't be risking blowing up stuff in space in low Earth orbit, because it could easily, we could strand ourselves from space assets for 50 years.
Interesting. Can you elaborate on that? So what is the danger of the debris there that could jeopardize access to space?
So for instance, it was only a couple of years ago, Russia did an anti-satellite test on an orbital. There's we've done this too. The U.S. has done this. I'm not pinning it on them, but we kind of know nowadays, don't do anti-satellite tests on orbital things, because those things stay in orbit. When you blow something up in space, it's not people think, when in space, you throw something that's just going to keep going forever and ever and ever.
Yeah.
I mean, that's in the sense that it's not going to be slowed down due to air resistance. It's going to continue to do that, but it's staying in orbit around the Earth. Like you just slightly change the orbit of it around Earth when you throw a ball or something, you know? So the scary thing is when you blow up a satellite, all those pieces of that satellite are now millions of bullets in a halo around the Earth, in a very specific halo, you know? So some things get blown up faster, you know, according to its orbit, faster. So they'll go a little bit higher elliptically. Some things will get slowed down in that explosion and actually re-enter. Some things will go sideways and change its inclination of that orbit. So you have this debris field, but it more or less becomes a band of like, no, you know, like a big, scary, sharp, scary bullets that can destroy another spacecraft. And so then all of a sudden, especially now Starlink, you know, we're talking about thousands and thousands and thousands of satellites in space. If all of a sudden one, you know, a couple of them crash and you know, blow up, and all of a sudden you have all the shrapnel going everywhere, and then that hits another satellite, that creates shrapnel. You can literally blanket our entire low Earth orbit in 17,500 mile an hour bullets. You know, we're talking that the kinetic energy in this is so hard for people to fathom, because that, you know, that's over 10 times faster than most like rifle bullets. And even like a big 50 cal is not going to be, you know, we're still talking about 10% that. So when you think about the kinetic energy, it's insane. So a fleck of paint can go through panes of glass at that velocity. You know, a little piece of metal can puncture, you know, blow straight through.
So like, so our actions that seem small, so small scale military actions can have dire detrimental effects to the whole space program, like global space program.
Oh yeah, it can affect everything and everyone,
including satellites.
Oh yeah, especially satellites. Like that's the good and the bad thing is, the good thing is a lot of satellites don't operate in low Earth orbit. Like a lot of the ones that we use day to day, a lot of them are in medium Earth orbit, like if they're GPS or they're geostationary, which are way, way, way out there. And because of that, they won't really ever deorbit, or like it'll take, you know, millennia to deorbit, because just because something's in space doesn't mean it's there forever, especially like in low Earth orbit. The atmosphere doesn't just suddenly stop. It's not like you hit the Kármán line 100 kilometers and all of a sudden there's zero atmosphere. The atmosphere just slowly tapers. You know, you can experience that yourself as you climb a mountain. You slowly realize there's less and less air. You just keep going. And just because you're in space 200, 300 kilometers up, there's still trace molecules. You know, there's the occasional oxygen molecule. There's the occasional nitrogen molecule. And so that is actually drag. So as a spacecraft in low Earth orbit, depending on its altitude, will take anywhere from 5 years to 5 months to deorbit, you know, or 2 months or 1 month, like depending on its orbit or its altitude, we'll have some parasitic drag still, and slowly throughout time slow down, which lowers its orbit, which drags it down more, lowers its orbit, and et cetera, until it re-enters. So if we end up with some kind of catastrophic event where the entire low Earth orbit is, you know, has been inundated and blown up, it'll take months for the first band, you know, to clear up. It'll take years for something like beyond. There's charts, you know, people have all this stuff available. You shouldn't look it up.
This is terrifying, by the way.
But
this is really
But again, the caveat is, for the most part, the low Earth orbit stuff would clear up within years. So we could get back to doing some low Earth. Like Starlink stuff would probably be able to be and you know, we could kind of redo it and build up from the ground up again. GPS wouldn't be wiped out, and our geostationary satellites wouldn't be wiped out. But the scary thing is we wouldn't be able to relaunch and replace new things because we're stuck. We're not going to fly through that debris field, you know?
And we avoid that by avoiding military actions in space.
And these days, like there's more and more requirements and legislation, and especially trying to get international collaboration on having end-of-life plans for satellites. So that satellites, especially those in low Earth orbit, have like drag devices to increase them. Once they're done, they literally pull like even just a ribbon, like a silly little, like, you know, 40-foot long ribbon will sit there, and it'll slowly, or it can speed up its reentry process by months or years or whatever. So we're starting to see that this is now an importance. There's a really cool company called Stoke Aerospace out in Washington, is one of these launch providers that's really looking not into just trying to be the next, you know, SpaceX launch company. They're really seeing satellite bringing stuff down from space as actually being, especially right now, we have all of these hundreds and thousands of satellites being launched every year, someone at some point is probably going to have to do some cleanup. And so they're looking at being one of those companies to do that.
What do you think about Starlink and the efforts of Starlink to put a very large number of satellites out there and provide internet access to Earth?
Anyone.
To anyone.
Generally, I think Starlink is phenomenal. And I would be saying this if it was any company. I want to make that clear that people think I'm just some, SpaceX fanboy or something, and everything they do is perfect.
I think as your fan, I could say you're basically a fanboy or just a fan of everybody that's doing space stuff. And I don't there's no, even in this whole conversation, there's no way we cover like 10% of what I wanted to talk to you about. So we're jumping around. I mean, we could talk probably for an hour about Artemis. We could talk about anything with ULA, obviously all the other commercial efforts. We could talk about the NASA efforts and Saturn V. Like, are we gonna really go this conversation not talking about Saturn V? And we might. Okay, so anyway, Starlink. You're a fan of everything. Starlink is in general exciting to you, and
not for the space assets, but just the potential for humanity. Like, I really think, even as a consumer of the internet, personally, our studio space down in Texas, we're stuck with Mediacom, which has like the least reliable internet service, period. That's the only option. Either that or they're trying to charge me like $20,000 to run a fiber optic cable like 1,000 meters or something. Like, it's insane. I'm not going to do that. I bought Starlink. It helps, but it's still not, amazing. But you can see where this is going in a year, 2, 3, 5 years. They're like, oh, I can totally screw this other internet provider, and this is now by far the best option, and it's available literally anywhere. You don't have to be limited to your local internet service provider. And on the global scale, of course, you have people being able to learn and learn about rockets, learn about water management and architecture and city planning and fitness and health. All of the modern conveniences that we Google every single day. There's people that don't have access to that right now. I'm a self-taught rocket nerd. I would not be who I am if it wasn't for the internet in the last 7 years, 6, 7 years.
So unlocking the intellectual potential of places like Africa, of rural areas that don't currently have internet access.
That's a huge thing. That's like humanitarian 101 is give people access to information. And I think we have this potential to try to step in and fix other people's problems. But the reality is, like, people are smart. Yeah. No matter where you are, you give them the resources to learn, they're going to solve problems. They're going to problem solve. They're going to engineer. But if you don't give them access to that information, they're going to be stuck in their cycles, And so I think the potential for Starlink is incredible. I think it's already impactful. It's already affecting people in rural and indigenous areas, and it's already affecting businesses and all that stuff. I think it's great. I think it is, there's some downsides with astronomy, with ground-based astronomy, that it can hinder observations from the ground. There's already a lot of communications between SpaceX and astronomical societies and things like that, because it is a real concern. It can ruin observations, it can ruin data. But like one of the big ones, for instance, recently, I think a new thing they're going to be working into is that currently, if a Starlink is flying over a ground-based asset, a lot of ground telescopes actually have a laser that goes up and it measures the atmospheric distortion, and the telescopes literally sit there and, like, by the millisecond changes the focus and fixes those atmospheric distortions. Mm-hmm. And that laser can interfere with satellites. So previously, I'm pretty sure that SpaceX actually had to, request that as they're flying over these satellites, these telescopes, they turn off the laser. Mm-hmm. And when you have tens of thousands of these things flying, you're going to be turning off the laser more than it's on, and just being this insanely inconvenient thing, because you're going to have these junctions happen often. And I think one of the things that SpaceX is like, okay, no, you guys keep the laser on, we'll deal with your laser. Good step, things like that, mitigating the brightness of them so they're not visible under most conditions. Of course, like, there's still always going to be visible in some. But then ultimately for me, it's like this, you have this weird, like almost like a puberty of space flight and and astronomy, where currently it's not cheap enough to really do a ton of incredible science or space-based telescopes. We have Webb, we have Hubble, we have all these other awesome space-based telescopes, Chandra, et cetera, whatever. And but it's still so expensive to launch them that we're still so reliant on our ground telescopes. But in the future, you can see a world where, oh, this is so cheap, we'll just launch, we can launch 50 James Webb Space Telescope size telescopes this year for half the price of doing it on Earth, and get way better data. Mm-hmm. So in the future, I think in 20, 30 years, we'll look at it and be like, oh man, that was an awkward time where space assets were interfering with astronomy. But I think in the future, it's can you imagine doing space, astronomy from the ground? That's insane.
There could be complexities to just having that many, just another topic. So complexities associated with having so many satellites, especially with competing companies and competing nations. Do you see that as an issue, having tens of thousands, hundreds of thousands of satellites?
Yeah.
It becomes a very interesting robotics collision avoidance problem.
The one thing to keep in mind is perspective. I know 10,000 satellites and 20,000 and 100,000 satellites sounds insane, and it sounds really scary. But, just even look at how many planes are in the air at any given time. Mm-hmm. And the planes are bigger. They're flying slower, which actually means there's a greater chance of collision. If you think about, two objects occupying space, if one's moving really fast, imagine trying to, throw two basketballs at each other, relatively easy. Now try shooting two bullets at each other and have at 90 degrees from each other. You have to have your timing down, really perfect to do that. Now take that times 10, and these objects are taking up a physical space, very small amount of time. They're relatively small. Most satellites are not very big, and they have limitless altitudes to deal with. So even though you can have what look like convergences, they can be 10, 20, 50, 100 kilometers difference often. And they're dealing with this. All space assets know, hey, I'm at this orbital plane and this blah, 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 blah. And they know their altitudes and know their safe distances and have these margins built in. And it's space. So there's an insane amount of room, So there's
a lot of margin.
There's a lot of margin. But of course, you can't excuse that all the way. You have to still have plans and be considering that and considering collisions and considering all of the above.
When do you think the first human being will step foot on Mars? You don't like timelines, but is this something, and you're very much focused on kind of the short term of incredible progress that's happening, and that makes total sense. But there is the Mars plan that was at the origin of the commercial spaceflight efforts. Do you still see and dream about that day?
Let me be clear that I don't want to go to Mars, but I do think if you're making me guess a timeline for when humans will walk on Mars, even a year ago I still would have said by the end of 2020, the 2020s decade, so by December 31st, 2029, I thought humans would have walked on Mars. I'm starting to think that's still too optimistic, but I definitely think by 2040. I for sure think that. And I really think it's just hard to predict that curve, that project out that curve. We're going to go from feeling like it's impossible to it's feeling like it's inevitable.
It could be another, by the end of this decade, JFK type moment, especially if China steps up with the space race.
Yeah.
It could be all right, NASA kind of says, all right, this Elon fella, really make this a gigantic effort.
Well, and if Starship works out as planned, and as NASA has invested in human landing system, they're relying on SpaceX to land on the moon. If SpaceX can land on the moon, they can land on Mars. Now, whether or not the life support and the human considerations of long-term spaceflight missions and high radiation and blah, 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 refueling on Mars is a huge, huge, huge deal. They definitely could send a Starship to Mars and land, ideally land in one piece on Mars. As soon as they can land on the moon, they can land on Mars, basically. Those two things are very... In some ways, Mars is almost easier. If you can use, because you can use the atmosphere to slow down. It actually doesn't take that much more delta V to actually land on Mars than it does. Because on the moon, you don't have any... You have to first get out to the moon, then orbit the moon. You have to slow down. Every one of those is a maneuver change. Then you have to lower your orbit until it coincides, hits the moon. And then you have to slow down enough to not explode when you hit the moon. So there's a lot of delta V there, a lot of change in velocity. Mars is actually, by the time you kind of crunch the numbers, it's relatively similar. It's just a lot more difficult, like timeline wise, and accuracy, and all of these other communication. There's a lot of other things obviously involved. I'm glossing over it, making it sound easy. It's not, but I think I think there's a real decent chance we could see a Starship vehicle land on Mars, uncrewed by the end of the decade, though.
End of the decade. I mean, there's also a sociological element, maybe a political one, where I think you're allowed to take more risks with Mars than you are with the moon. Because we've done the moon, 1969.
Yeah.
It's been a while. So PR-wise, you have to be much safer.
Yeah.
With Mars, like everyone's like, it's super dangerous, so you could take a little more risk.
100%.
Especially with manned missions. But actually just going back to the moon landing, Apollo 11 mission. We haven't talked about this, Adam. It's the amazing engine there, but again, the romantic question. And you look back at that moon landing, one small step for man, one giant step for mankind. What do you think about that moment in human history? Do you go back to that often, or are you focused just like with the cars on the engines?
No. I still, when I need inspiration, I rewatch this documentary called "When We Left Earth." I think it was Discovery Channel did it. 6-part episode. It was narrated by Gary Sinise. Phenomenal overview of the space race, and that will get my juices flowing every time. Every time, just it's so well done, and it really just summarizes that program so well. And when and beyond, it goes all the way to the space shuttle, but. Yeah, when I watch footage of humans walking on the moon, it's just I can't believe we're dumb enough to do it with the technology we had and the risks they took to do it, and the insane engineering that it took to do that is just absolutely astonishing. The amount of the sheer like logistics of what it took to do it with the technology we had back then is like, how did we have so much money and effort and energy and time and resources, human resources to do this? Like, it's just
the weakness
insane.
of the computers they had back then. Yeah. You had to do so much. I mean, it's so much with so little.
It's insane. But at the same time, like, I don't know if we want to talk about conspiracy theories or anything, but like, it is all of, we have the proof in the pudding of like the 400,000 people on payroll, like, all of the paperwork, all of the...
Oh, you mean the question, the conspiracy, if we land on the moon?
Yeah. Like,
well, I mean, I think
the receipts are there, like literally.
We did. But it's like a lot of things like that. I mean, we actually generally live in a pretty cynical time where people distrust institutions. Part of the thing with the space program is one of the things that can help reinvigorate the trust in institutions. By institutions... Even that word is a bad word now. But institutions means a bunch of humans get together and do a big thing together.
Yeah.
Yeah, but like if I was conspiratorially minded, it's like, how the hell did humans do that?
Yeah.
So I think that's a very cynical take, unfortunately, but it's still an incredible one. And also, there's until you look at the receipts, there's a kind of like a rationale to that kind of conspiracy theory because so much pressure was put on the space race, the PR of it, to be the winner. So it makes sense that you might want to try to take shortcuts and fake things and propaganda, different kinds of messaging, and I'm sure stuff like that was happening. Some kind of like little adjustment here and there to present things better and so on. But ultimately, the actual engineering project of landing on the moon, the fact that humans did that, I mean, it is sad that we didn't have better like ways to record it. And as I watch like SpaceX efforts and Blue Origin and these efforts, it's still not trivial to record the how just amazing, awe-inspiring space is. Because it like... it's like Elon jokes about like space does look fake.
Yeah.
Like I think there is some element of it where you have to be there to experience it really. Mm-hmm. And I don't like, I think it's it's currently is still an unsolved problem of how do you capture the awe of that. I mean, you're one of the early people that are part of the crew that is exploring that very question. I'm sure you won't find all the answers, but you'll start to say, like, how do we convert this into a visual format, into some kind of format that captures the magic of it?
100%. And that's a perspective thing that I think about all the time. You know, when I'll do a lot of thinking about, like, what is the thing that's reacting to people? Is it the sound? Is it the perspective? Is it like seeing a little tiny human next to a landing leg that makes people go, oh my God, this thing is huge? You know, just reading, you know, and digesting that and trying to help to convey that as best as possible, because the stuff that we are and have worked on is so cool. It's so exciting, and it's so important, and like, actually, you know, so much bigger than any one of us, physically and metaphorically. I wish everyone had that experience and had that light bulb go off.
And that's the cool thing, that you're like smack in the middle of solving that really difficult and fascinating problem of how do you capture the magic? How do you inspire? Like, that's not just an engineer problem. That's a communication problem, education problem.
I find, specifically for myself, that I get most excited about something when I learn a lot about it. Like when I learn the ins and the outs, and I learn all the little problem solving and the cool, like, oh my God, they had to do what to make it work? Wow, that's amazing. And I try to just always go back to that root thing of, like, what can I teach myself? Like, if I'm every video, I expect that I learn something making it, no matter what. Like, no matter how much I think I know about something, at the end of the day, if I'm not learning something, it's not a good video, you know? And I always think that people get excited when they learn and when they have some questions answered for them.
Let me ask you a couple of quick out there futuristic questions. I have to.
Sure.
I'd hate myself if I don't ask you. So first, let's talk about nuclear propulsion. So out there, interesting propulsion ideas. So what do you think, beyond the chemical engines that we talked about, what do you think about using nuclear fission and maybe even nuclear fusion for propulsion?
We already have thermal nuclear reactors. There are nuclear engines that have been tested both by the United States and Soviet Union that were 100% valid, like totally ready to go, efficient, super awesome. Yes. Hardcore yes. And what they're using is, basically a fusion reactor. You're flowing hydrogen through it and heating up that hydrogen, taking it from liquid to a gas, you know, and by heating it up, you're adding energy to the propellant. And then you're literally just using that now steam hot hydrogen and flowing it through a de Laval nozzle. And you also have to use that energy to spin the pumps to still pump the thing. So you're still kind of using like a lot of the tricks that you're using, but instead of a chemical reaction, you're literally just using nuclear fission to heat up propellant and do the same thing. And at the end of the day, you end up with like 800 to 900 seconds of specific impulse, which is double that of chemical propulsion. Most of that comes just because hydrogen's so light. You're only ejecting hydrogen out of the nozzle. So the lighter a molecule is, the faster it, you know, just like if you had a golf ball versus like a bowling ball, you can only physically throw one so fast, and the other one, as a human, you're not going to do very well with. So you have the more potential for a higher exit velocity. So nuclear thermal, amazing. You can just shoot these little hydrogen molecules out crazy fast, crazy efficiently. We already have it. Like, we can do it. Yes. And actually, we're already investing in that again, as the United States is looking into basically ramping back up our nuclear propulsion.
Why haven't we done it yet? And what do you think the challenges are there? And do you think that's an obvious future? Like, would you see in 50 years we're not using, like, we're not for major projects like a Starship type of project, we're not using chemical propulsion anymore?
For getting off Earth, you'll always want to use chemical propulsion because the gas will become irradiated. Like, you don't want to, and actually the thrust to weight ratio of these engines are relatively poor. They're very heavy. They have a nuclear reactor. Like, they're really, the reason we kind of give up on them is they're really most useful for like interplanetary. If you're trying to get if you're trying to send a huge payload off to Mars, nuclear thermal is amazing. It's still could be beneficial even going to the moon, you know, like in an Earth moon system, you could use nuclear thermal very effectively, and it could be a great choice. But it also that starts to get into that trade of like, we can just kind of use a little bit bigger rocket and fly
Sure.
a normal.
Yeah.
You know, it's that whole trade thing. But another reason why we kind of stopped using them, the one that the United States developed, Nerva, was so heavy, only a Saturn V could actually lift the stage of it,
Yeah.
like the upper stage. So it replaced the S4B with a nuclear thermal with the Nerva engine. The Soviet Union developed one about 1/10 the size and thrust that was small enough to fly on a proton rocket. But neither of them ever flew. Both of them have been tested and like thumbs up, ready to go, which is just a huge shame to me because they could unlock a lot of interplanetary potential and just all around awesome.
Which potentially interstellar as well.
I don't think nuclear thermal, we're not quite getting there, but then you get into like nuclear pulse drives and things where you're literally like basically ejecting a bomb out the back of your rocket and exploding it and having like a shock absorber and pogo sticking your way out of the solar system. That's, I mean, by all physics, sure. You know, there's nothing wrong with that. It's not breaking any laws of physics. And, you know, but I just don't see us getting to that need anytime soon. I don't think we're going to
Interstellar travel.
Yeah, I think we're going to want a better understanding of physics and
physics itself. Yeah. Do you have a hope that maybe theoretical physics will open the door to some exciting propulsion systems?
Yeah, I do. I think we're still at the very infancy of our understanding of everything and how things work. And, you know, 100 years ago, it would be stupid to try to predict the things we know today. And who knows, like even, you know, I think about things like James Webb looking deeper into our solar system than ever before and physically being able to see objects that we just have not even been able to physically see before.
Oh, and being able to study black holes, for example, better, the stuff that's happening outside of black holes, at the edges of black holes, how the information is stored, the
100%.
holographic principles. Just there's so much weirdness about black holes.
Yes.
So around where gravity starts bending light, it's like, all right, we get to look at that now and start to wonder, like, what is going on? And how can we like use that somehow for propulsion? I mean, it seems like awfully crazy and futuristic at this moment, but I think that's because we know almost nothing about, those kinds of objects where the general relativity and quantum mechanics start to have to be both considered to describe those kinds of objects. And as we study those objects, we might figure out some kind of unification thing that will allow us to understand maybe how to use black holes for propulsion. Like, I could say a lot of crazy things, but like basically.
But the point is, it'd be stupid for us to even guess about things we don't even know about yet. You know what I mean? Like, and so therefore, I'm not going to say that the best option for interstellar travel is nuclear drives. Like that could be like someone saying, you know, in 1600, the only way to fly is by strapping 1,000 birds to your head, you know, like.
But that said, I mean, everything you're saying is right, but human history is such, like at the beginning of the 20th century, physicists, Rutherford, everybody, there's brilliant people that said we've basically solved all of it.
Right.
If you talk to most physicists, I think they're going to say like, we've pretty much solved, like the standard model describes physics extremely accurately.
Right.
General relativity explains the cosmos as we observe them extremely accurately. Yeah, there's a whole dark matter, dark energy thing, whatever.
Yeah.
But outside of that, we basically solved like where are you going to find gaps in knowledge that are going to somehow create warp drives or something like this, or wormholes. But it seems like throughout history, we prove ourselves wrong time and time again. And
yes. No, this is well outside of any of my knowledge base. So I want to make sure that if I say anything stupid, it's because I'm just a peasant here in physics land. But
yes, we're all peasants in physics land.
But I really just think like it's very humbling that we're still using chemical propulsion and variants of like injecting mass to propel ourselves. And no matter how you get at it. And I think someday I would expect that our species has figured out a way to get beyond that.
Gotta ask you another wild question. What do you think of Bob Lazar? who claimed that he worked at and saw in Area 51 a propulsion system fueled by, I'm quoting here, maybe from Wikipedia, I don't know where I got this from, fueled by an antimatter reactor, which used as fuel the chemical element with atomic number 115. At the time, it wasn't synthesized. It was later in 2003 synthesized, named muscovium. He said that the propulsion system relied on a stable isotope of element 115, which allegedly generates a gravity wave that allowed the vehicle to fly and to evade visual detection by bending light around it. No stable isotopes of muscovium have yet been synthesized. All have proven extremely radioactive, decaying in a few hundred milliseconds. One, do you believe him? Which I find him fascinating because it's I find the human mind even more fascinating than 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 something like an antimatter drive, because I think it's such a giant mystery that we haven't even begun to explore deeply. Anyway, in that sense, whether he's lying or not are both interesting things to explore from a psychology perspective. But to I mean, it's basically saying that I guess it's an alien, uh, extraterrestrial engine thing. What do you think?
I mean, I'm happy to change my opinion based on new evidence at any point. I have, like, the biggest part of me wants to just be like, this is obviously just stupid and a hoax and just total, quack. And then another part of me still is like, this is exciting and fun to think that this is all real. And then another part of me goes, why? How good is this guy at lying and making stuff up? Because it's all really good, like good storytelling, good. Like, I don't know what to think, honestly. I don't know. I'm really very skeptical about anyone explaining anything like this. Like, I mean, my radar is like screaming at me, like, this is all full crap,
Yeah.
But I'd say, like, there's still a part of me that's just like, man, that is kind of cool. How did he know that? And like, you know what I mean? It's,
Well, I think
I'm conflicted.
I think you're actually in the best kind of place, because it's. I'm afraid of being the kind of person that hears something like that and says it's definitely he's definitely full of crap, and basically close my mind off to all that stuff. I'm afraid of being somebody who closes my mind off to a thing that's actually a early thread to a brilliant, to a future, to a fascinating solution to a mystery. So, but in this case, I mean, I have so many red flags from a psychological perspective that but again, outside of this particular individual, I do wonder if aliens have visited us. I think aliens are everywhere. I think the universe is teeming with alien life. I mean, it's very difficult for me to statistically understand, given how life finds a way here on Earth, just everywhere. The entire history of life on Earth, from the very origin of life, it seems to be damn good at doing its thing and evolving to get better and better and better at doing its thing. Now, there could be some special aspects to the origin of life itself, which is completely not understood. So maybe the true magic is in the origin of life. Or it could be that there is some magical leaps to eukaryotic cells, for example, that the universe, our galaxy, is teeming with alien life, but it's all bacteria. They're all boring bacteria or exciting bacteria. No offense to bacteria. But the no intelligent spacefaring civilizations. I don't know. But if I were to guess, if I had to bet all my money, there is spacefaring civilizations everywhere in the universe. And the fact that they have not been directly, definitively observed confuses me. And I think it's a mystery. And if I were to suggest what the solution to that mystery is they might look extremely different from us. And we might be too dumb to detect them.
Yeah.
And so there, I think you have to be extremely open-minded at what would we be looking for.
Right.
That's a very practical thing to be open-minded about. And practically speaking, if we were to be able to even detect them from a distance, get a techno signature of a distant planet of a distant star system that has alien life. Honestly, the number one thing I kind of want to know is like, what's your propulsion system? Like, how do we
100%.
travel faster, right? Like, there's a bunch of details probably, but first, let's get together
And teach me how to go fast.
go fast.
I like motorcycles. I like rockets. Tell me what you got. Yeah.
Yeah, like how, like I'll show you mine if you show me yours, kind of thing. at the interstellar intergalactic level. Yeah. Anyway, I just wonder. Maybe it's a cheat code in this video game we call life, but I want to use the cheat code to figure out what kind of propulsion systems are possible. And it feels like other alien civilizations might help us, give us give us a guidance on that. Of course, I think even just discovering, boy, one of the things with the space program, like everything we're doing with Mars, like the secret thing I'm really excited about. The romantic thing is humans on Mars, but the secret thing is building giant stations on Mars that allow us to definitively, hopefully, find the traces of life that either currently doesn't live or has once lived on Mars. Because if that's the case, that means for sure life is everywhere.
Oh, 100%.
And then you're like, once you know that, sorry to keep interrupting, not shutting the hell up. Is this supposed to be an interview? God damn it. All right. Just the knowledge of that, just the knowledge that a 4-minute mile can be run, I think will open our minds completely to really, really hardcore push to interstellar travel or colonizing Mars, becoming a multiplanetary species. It'd be truly inspiring.
You think that? Do you get nervous though? Like, I'm the interviewer now.
Yeah.
Don't you get nervous that we could make spectacular discovery on Mars that not only has there been life, there's actually like pretty advanced micro, or multicellular life totally thriving in certain regions. We just hadn't visited them yet on Mars, and we make this big discovery that a relatively large percentage of people just simply wouldn't believe it. They'd think it's all 100% fake, and that they're just doing this to control us, and that blah, blah, blah. Like, we could make the most important discovery in human life, like in all of human existence, that we're not alone in this universe, by, cellularly at least. And a good percentage of people, I'm thinking 20, 30, in today's world, 40+% of people wouldn't even believe it existed.
Interesting. It's just a very important thing to think about, especially as an educator like yourself. I think the current cynicism towards institutions and science is temporary. I think they're basically, the internet woke up. The internet smells bullshit, and it looked at I'm sorry, I'm not being ageist, but saying older scientists, and they looked at them and they kind of said, you're kind of full of shit. You got a lot of ego. You speak down to everybody. You're not very good at communicating. I think there's a lot of truth to what they're saying. And I think the young scientists that are coming up will be much better at not being full of shit, being authentic, being real, not treating people like they're children that can't possibly understand, like taking it very seriously, that there's a lot of intelligent people out there that are curious, that are full of desire for knowledge, like being transparent about all the uncertainties of the scientific process, all the tensions, the conflicts, all of that. And I think once we fix the science communication system adapted to the internet, I think that won't be an issue. I hope. I mean, that's why people like you are really important. Is like communicate with authenticity. But yeah, that's definitely something to think about. I mean, yes, the early. Listen, scientists too, like the phosphine discovered on Venus, is like they're extremely skeptical always. So definitely there will be a lot of skepticism. And it depends what it looks like. If it kind of looks like, this thing kind of looks like bacteria back on Earth, yes. So it means contamination is very difficult to avoid in general. But if the thing looks like fundamentally different, then you're like, all right, that like.
Totally different DNA, RNA. Like, this is not. We've never observed this ever at all.
Then you're like, all right, cool. Of course. So that another promising thing that difficult to be definitive about, but as get better and better direct imaging systems, there's now like I don't know how many, but thousands of planets being discovered outside of our solar system.
Oh, yeah.
There's moons being discovered now, Earth-like planets being discovered. So like all of that, if we could do direct imaging of those planets more and more and more, there could be some gigantic. Listen, if there is like a Kardashev like type 2 civilization, we're going to see the damn thing. It's going to be producing a lot of, it's going to be radiating a lot of energy. So the possibility of detecting some of that, that's also a real possibility with something like James Webb telescopes, like those kinds of efforts. That starts becoming a reality.
Have you read Andy Weir's Project Hail Mary?
I have not, no.
You're going to love it. Like it is basically almost answering that, like, how could they not see us type of thing, almost, where he creates this incredible, I don't want to spoil anything, but it's just this sense that like we could have totally different perspectives with an alien race and not even like consider that, the two of us are coexisting almost.
Yeah.
I don't want to spoil anything. It's really, really, really worth the read.
Oh, you mean a different perspective? Like the aliens have a different perspective than humans?
Yeah, like we see with this visual light.
Yeah.
Someone could see in X-ray, etc. And just the way we even come to the same perspective and like looking and observing is just so different fundamentally that like we could, I mean, it's not quite like that. It's not like it's like, oh, they were actually on the moon and we're, it's nothing like that. But it's such a unique and incredible story. I think Andy Weir is one of the best science fiction writers. I can't say that with much authority because I don't listen to much science fiction. So zero authority. I really like Andy Weir's books, and that book is no different.
Well, that sounds like I'm really worried about that. It sounds like I would really love it. I've been very I've done a lot of reading in my life, but like the science fiction is one of the things I've been really, really weak on. I haven't really read much, and I just made more and more friends over the years recently that say that I absolutely must read some of these things.
Do you physically read or do you do audiobooks while you run and stuff?
Both. I do both. Yeah. But physically, I sadly don't. It's a Kindle, right?
Yeah. Yeah.
But while I run, I also do. So I do both. I do about on a normal day, especially now because I've been really focused on reading. It's about 60 minutes of reading on a Kindle. And 1 to 2 hours, because I run about 2 hours when I don't have like other stuff. Like today, I won't run, so it's about 3 hours. So on average, I would say it's like 2.5 hours a day that I read. And audiobooks are just the same. They're a little slower, but they can, especially for the classics, they can capture some of the magic with a deep voice, usually with a British accent. I love it. I also read that a book on propulsion like 2 years ago, I remember. But I remember that was extremely difficult.
Ignition
it was Ignition.
By John D. Clark.
Yep.
Yeah.
It was very difficult to listen.
Oh, I see. I don't read. I listen when I'm on road trips or running or
Yeah.
stuff like that too. So I swear there's probably 40 or like not 40, but there's like 8 minutes of, we tried BMZ 15, 13, BM 412, RMNL, mitral hydrogen for like, I swear it's multiple minutes of explaining one trial on something because there's just so many different chemicals they try. I don't know. It's almost a joke. Like I literally audibly laughed out loud listening to it because I'm like, this is so ridiculous. I'm sure it makes sense reading it, but like listening to it is just hilarious. But it's great though.
What do you think of some of the challenges for long-term space travel? Do you think about this kind of stuff, the biological stuff?
Yeah.
Do you worry? Do you think about radiation on Mars? And out in space over periods of actually the effects on the human body, forget even the radiation, over periods of months and years.
Yeah. I think realistically we have a really good handle on what the effects are. And we actually have the solution to like everything. It's just whether or not we can, like, for instance, one of the, low Earth orbit, one of the biggest challenges eventually after your long-term space travel is bone density loss and not having gravity. You actually have issues with a handful of things, and artificial gravity is relatively easy in terms of space flight. you can have two vehicles just tethered together and, just spinning, give it enough distance and a decent enough spin velocity, and you can get 1G like relatively easy. We're talking again relatively easy, especially after talking about theoretical physics. Like that's easy stuff. We haven't done that yet, but like there's no reason why we can't produce artificial gravity if we say that that's a big enough hurdle that we absolutely have to overcome this. Okay, cool. We'll just spin up two vehicles that are going to Mars, and people will have. But that's the thing, is Mars is only about, we'll say, 6 months there. Then you're hanging out on Mars. You have 38% of gravity, and then 6 months ish back. People live on the International Space Station at 6 month stints. We've had people for basically a year up on the International Space Station. It's not like it's not life altering. Yeah, you have a couple days of not being able to walk very well, and you do have some bone density loss and some other concerns. But like, again, it's solvable. And I think, the first missions to Mars, I think we'll probably do the trade. Is it worth it to like land on Mars and have a crippled crew that can't even physically stand yet, for a day or two before they get their, feet from underneath them? Or do we need to spin up two spacecraft or, a tether and have, like, you can't do it like Starship, even though it's 30 feet wide or 9 meters wide. If you spin it on that one axis, that's not enough space to get 1G without your feet and your head being at two different velocities. So you get really sick. You always feel like you're falling. Your brain will tell you that you're falling constantly. But then again, okay, so this is a whole thing is, and I don't know if we don't really have the data yet on like going from 0G. We know the effects of that. We know the effects of 1G really well. That's our majority of our data set. But we don't really have much data on the long-term effects of, 1/6 gravity, like on the moon, or 38% gravity. Is 1/6 gravity actually enough to counteract 95% of the effects of low gravity? Or is it 15, is it 1/6? Is it like a linear thing? Is 38% gravity totally, 38% as bad as 1 or whatever? Is it a slight, like, where is it out on the scale? So there's a chance that we don't need anywhere near 1G of gravity to counteract the bulk majority of these problems. We could have 0.1G or whatever is the right compromise of vehicle complexity and human biology and all of these other effects. Like, this is absolutely a solvable thing. That is,
and we figure some of this out through just experimentation,
100%
along the way.
Yep.
One of this is back to my dating life. I think one of the essential fundamental research questions I'm wondering about is the dynamics and so the details of how you have sex in space. Asking for a friend, of course. I mean, there literally is sort of work on this, right? Because like, if you think about long-term space travel, I mean, sex is sort of like there's the recreational aspect of sex, but the most important aspect of sex for long-term space travel is procreation, and also the full biological cycle of that. So from the embryo, the development of the baby, the giving the birth, and all that kind of stuff. Oh, yeah. So like, there's a lot of really difficult problems of biology there to understand, and perhaps to solve. Some of that, again, just like you said brilliantly, some of that can be just solved with engineering outside of the human body by creating a gravitational field like that. But maybe along the way, you can figure out how to do that without doing it. We're balancing the costs and so on.
And radiation's the other thing. Like, we know we have a really good data set on what radiation and doses do to humans. Like, we know we can measure radiation. We know we can approximate, and kind of give edge cases for the Mars transient and getting to Mars and being on Mars. And the simple answer to that is, like, at the end of the day, if we have to, dig into Mars or find a tunnel to live in so you get some extra mass in between you and cosmic radiation, so be it. Like, that's the answer then. Again, none of these are like insolvable problems. They're just hurdles you would have to overcome based on, the risk exposure and the posture there.
Imagine being the first child, the first baby born outside of Earth. That'd be pretty cool.
Yeah, that'll be.
I would love to be alive to see that.
That'll be a big one.
I don't know if he'll. I don't know, because it's such a dangerous thing. It's so risky.
I think that could be in our lifetime.
You think so?
Yeah. I would like to think in a perfect world, if we're thinking futurism, that in 30 to 50 years, I definitely think we could have full-time, like permanent major civilizations, like what Blue Origin wants to develop, where they have a huge like sphere, and you're doing a lot of especially heavy industry off of Earth, so you're not polluting Earth. Like that's makes so much sense to me. I think we could live in a lifetime where we've thought this since the 50s and 60s that people are going to be living and working in space like crazy, and at any given point, we're lucky to have 12 people in space today. But I really think in our lifetime, we're finally getting to that point of, that's a reality.
Let me, because you mentioned Blue Origin, can we just lay out some of the competitors to SpaceX? So much of what we talked about is SpaceX specifically because they're sort of pushing the boundaries of what's possible in the commercial spaceflight. But there's a lot of, like you said, incredible work being done for large companies and small companies, startups, and so on. So who are the competitors to SpaceX? ULA, United Launch Alliance, Blue Origin, there's a Virgin, is it Galactic Orbit?
Orbit would be the competitor.
Virgin Orbit. There's Rocket Labs, Electron rocket that you mentioned. There's the folks you covered, Firefly.
Yep.
And what are we missing? There's the Epic Space Launch System from NASA, I guess that is. Yeah.
Technically NASA, but prime contractor Boeing, Northrop,
Lockheed.
No. Yeah, Northrop is the boosters. Yep.
Okay. Nice. So, like, what's interesting to say to lay out the land here that you're excited about?
Just in general, I think if you aren't working on some form of reusable vehicle, like physically working on it, pen to paper, or not beyond pen to paper, like bending metal for a reusable vehicle, you're gone. You're toast. I think we're well into that being the only provable, way forward. The only way you're going to compete and survive is a reusable rocket. Fully reusable would be great, but that's obviously massively aspirational still. But it will come. But to me, the list, you pretty much had it right on the head. There's Astra was another orbital rocket company.
Yeah.
There's a lot of companies, and I think right now the ones that I personally really believe in, Rocket Lab is awesome. I really think that they are one of the few that I believe can actually build a Falcon 9 class rocket, like today with their technology, with their knowledge, with their investments, with their funding. They've proven themselves. There's very few. They have actually made it look easy. I think there's a lot of startups and a lot of new rocket. There's too many launch providers popping out of the woodwork right now. They won't all survive, of course. I think realistically, if you look at like airplanes, how many airplane there's a handful of airplane manufacturers. There's not hundreds and thousands of airplane manufacturers. I think it'll be a similar thing for spaceflight. I think we'll see, realistically in the terms of jumbo jets and passengers, there's basically two. There's Airbus and there's Boeing. So I think in the long run there'll be 2 or 3 major players. I think there'll be 10 minor, like as far as launch providers, as far as the ones actually leaving Earth and getting into orbit. I just don't think there's a ton of room for individuality, really.
Yeah, I would love to see it like a really serious competitor to SpaceX in the way that SpaceX does things. I don't know if ULA is quite quite the right kind of competitor.
Let me say this: ULA has all of the potential, but just operationally, they're either Lockheed Martin and Boeing's like love child.
Yeah,
they're kind of set up in a far too traditional manner where they just really aren't given the opportunity to innovate like a lot of these startups are.
So Rocket Lab is a little bit more of that nature. What do you think about sort of just Blue Origin in general?
Blue Origin's, what Blue Origin has done with New Shepard is amazing, and people just laud it because it's suborbital and it looks very phallic. So
I guess the meme matters also. It's modern day,
but it's sad because people don't see what they are also working on, which is New Glenn. I see comments almost every day still of like, it doesn't matter because they're they're working on tiny. It's like, no, New Glenn is more powerful and more capable than Falcon Heavy. New Glenn is almost more of a competitor to, not quite as to Starship, but it's almost in that class. It's a heavy lift launch vehicle. It's huge. It's crazy. It'll be nuts. They're very actively working on it. You know, I still think we're 3 years away from it launching, but that's a very strong competitor in the class of rockets that SpaceX is currently making.
So SpaceX is currently leading the way, but it could become a close race.
And well, it's just we'll just for now we'll ignore SpaceX and we'll just kind of talk about like I think who's kind of coming around the corner here. Who's
sure.
So let me just do a quick overview. I'm going to shoot myself in the foot for getting some cool people here and some exciting companies. But Relativity is one that if you should definitely get Tim Ellis on the show, who's the CEO of Relativity. They're doing 3D printed rockets. They're the ones that have the world's largest 3D printer. They're getting really close to their first orbital launch. The cool thing about them, the reason that I think they're exciting, the reason that I think they have the potential is just how quickly they can iterate. I think 3D printing a rocket is really dumb. I think iterating with 3D printing on a rocket is brilliant because you can literally change software and have like very little, upload a file and have a new rocket. Like that's amazing. So in terms of long-term iterative process, if we're really talking about like hitting the ground running and just seeing where the evolution takes you, I think that's about as good as you can get. I think what SpaceX is doing at Starbase, just physically bending cheap steel, is probably also a very valid solution. So I really think, and they have the engineering chops. I think they've got some amazing people there. Again, Rocket Lab, I adore what they work on. And, like everyone, there's a caveat here that everything takes longer. Anything, any company tells you it's 2 or 3 times longer, just period. Rocket Lab's no different. But they're working on a neutron rocket that's going to be I think 8,000 to 15,000 kilograms to low Earth orbit. Like it's a good medium class rocket. Will compete right along with Falcon 9, hopefully.
By the way, neutron would be its name. Right?
Yep.
It's
so
not some kind of
neutron.
It's not some kind of fascinating new physics breakthrough where they're using neutrons. Yes.
No. But they're also using liquid methane and liquid oxygen. I just think seems like a great rocket, and assuming they can actually get it flying in 2 or 3 years, I think they're going to be here to stay. I'd be remiss right now. I'm editing a video from an interview with Stoke Aerospace out in Kent, Washington. It's just one of these companies that they have a long ways to go. Like they're still in they're behind the curve, frankly, in terms of launch vehicles right now, because like I said, there's so many coming out of the woodwork. But the idea they're working on, their solution to a fully reusable rocket is amazing. One of the coolest concepts I've ever seen.
Are you going to cover it in the video?
Yep. That'll be hopefully coming out depending on what the schedule is down there. I'm actively editing that as we speak, and it is so cool. I mean, it is like it's genius. And if they can actually get it to work, I can see them merging. I can for sure see someone potentially in a perfect world, they merge with Rocket Lab. They Stoke develops the upper stage and maybe even the engines. They are the two guys, the CEO, the co-founders of that company, they are propulsion engineer magnificence. They both of them worked at Blue. They developed engines in a hurry there and then left Blue when it felt like it was getting too slow for them. And now they are, these guys fired a 15-chambered rocket engine instead of 4 from the Soviet Union. We're talking 15 chambers, single turbopump, 70 times in the month of October.
Wow.
That's impressive.
Wow.
And that's that was on average, if you think about days off, time off, parts changing, over twice a day on average of a Hydrolox engine. That's insane. So I love them and I hope the best for them. But they're also topical right now. They're at top of my head. So
what about Firefly?
What I like about Firefly, they've already got kind of a traditional aerospace backing. They're starting to buddy up a lot with Northrop Grumman. So they're going to be building the booster stage for Antares, which is currently flying only out of Wallops, Virginia, and is one of the only other commercial providers for the International Space Station. And Northrop Grumman is a very traditional aerospace company, lots of solid rocket boosters, and they've purchased, ironically, their current Antares is reliant on Russian engines and Ukrainian boosters, two things that I don't think you're going to be able to get your hands on too much anymore. So they're looking to some U.S. propulsion and stages. So they actually are partnering with with Firefly, and their new Antares rocket will be a first stage built entirely by Firefly. So I'm excited that Firefly already has the propulsion technology. And they actually developed, ironically, their tap-off cycle engine was developed in partnership with Ukrainian engineers who developed the whole turbopump system. So it's like, it's this cool meddling of these worlds. Their former CEO, Tom Merkusik, was like, I have an interview with him, and he's anyone that can just spout nuances and facts. I just love. I just soaked that guy's information up as best I could because he is brilliant. Literally a rocket doctor, you know, it's so.
Yeah. I mean, that's what, like you said, the fascinating thing about these folks, they're legit. They're such great engineers, that people that bring these rockets to life. And then there's all this stuff that we know and don't know about in China and other parts and other nations that are putting stuff into orbit. One of the sad things also is, like, you know, with Lockheed and Boeing is, and just military applications in general, there's so much technology that's currently being developed that we probably know nothing about.
Yeah.
And it makes me a little bit sad, of course.
Yeah.
But for several reasons. One is that the use of that technology has really much, like, it's not that inspired. It's like a very military focused.
Yeah, it's to kill someone.
It's to kill someone. Yeah. There's not even like a side application.
Right.
And the big one is that the secret. It's shrouded in secrecy as opposed to being a source of inspiration.
Yeah, 100%.
But that's the way of the world.
Mm-hmm.
Like, what was that one plane that you covered that was like we know nothing about?
Oh, the X-37B.
The X-37B.
Yeah, orbited for over 900 days and returned. Like, yeah, I want to know
that
about
thing
that
up
thing.
to?
I don't know. It's so frustrating. We know when it launches. People, you know, amateurs track and know. They even will be like, oh, it changed orbit. You know, it raised and lowered its orbit, blah, blah, blah. We generally have just almost no idea what it's doing up there. And it just saddens me because I want to know. And it's awesome. It's a great vehicle.
War. What is it good for? You mentioned Kerbal Space Program, the video game. Someone asked you what video game you recommend for learning about space and rockets, and you said, Kerbal Space Program. So tell me about this game. What is this game? And I also heard that a second one is coming out. So what like, you know, I've been playing more games recently because games are fun and they remind you that life is awesome. So why should I play this game?
If you want to learn about rockets, how to fly, how to build, how to get into orbit, how to get to other planets, there's no better way to learn about rockets than playing Kerbal Space Program.
What does it entail? Like, do you actually like...
it's like SimCity and Microsoft Flight Simulator for rockets.
Oh, interesting. So you get to, like, do you design the rockets?
Yeah. Yeah. Okay, so I started playing it in like 2014, I think, around as I'm like falling in love with space. And I became obsessed with this game. Like, literally you take you get boop, a little command module, click, you click on a fuel tank, boop, you choose your engine, boop, you choose a stage connector, boop, you connect more tanks and build these space planes and fantastical things. And it's all like physics based. It's available. This sounds like a commercial. It's available on PC, and Mac, and console. Like, it's available everywhere.
But wait, there's more.
And
you said, like, you streamed yourself playing this. Are any of those videos up still?
Oh yeah. There's some of actually the first videos I ever uploaded to YouTube were recaptured streams from Twitch that I just physically uploaded to YouTube.
This is awesome. And
so it's me playing Kerbal. I used to do this kind of like a podcast style thing. I should get back into this because it's one of my favorite things I ever did. We called it Today-ish in Spaceflight History, but these days I'd probably just play Kerbal. But I had my friend come sit next to me. His name's Jacob. Mm-hmm. And he is a former professional pole vaulter. Just this really knows nothing about rockets.
Yes.
Knows nothing about space. Hilarious. Like, in the sweetest, most fun way. He, as an adult, asked me which is bigger, the Earth or the Moon. And I love that for him. That's fantastic. He's just a delightful human. He would sit next to me. We would recreate a historical spaceflight mission in Kerbal Space Program. And he would just sit there and play guitar and sing about what I'm like doing and asking questions.
Yeah.
And it's still one of my favorite things I've ever done.
Yeah. You should definitely do something like that. So basically just, shoot the shit with a friend.
Get their curiosity going.
Get the
Let them just
curiosity
sit there and ask questions. And it was awesome. Like, I mean, yeah, those are some, I've done it a handful of times. I think we probably did like 20 or 30 episodes or something. And it's definitely something I would like to get back to doing.
Can you in the game like go to the moon?
Yeah, so it's technically a different solar system. It's the Kerbal system, and you're on the planet Kerbin.
Mm-hmm.
So there's the Mun, M-U-N.
Yep.
There's a second moon in the system on this planet. It's called Minmus.
They didn't want to pay licensing fees or what?
Well, it's just a little easier. It's a little bit smaller, sure. So the physics are easier.
So it tries to be consistent with physics.
Yeah. Oh, yeah. The physics are all like real world physics, and I mean, there's aero simulations. There's all of it's like 1-to-1, for Earth physics.
That's awesome.
It's just on an easier scale, solar system, so it's easier to navigate. But there's still there's a planet called Eve that's kind of like Venus. So it has a really thick atmosphere, really thick, really soupy. It's and a lot more gravity. So it's just really, really hard to get off of. It's relatively easy to land on Eve, but like that's kind of like the ultimate boss in the game is like getting off of Eve. So that's one of my favorite things to do is build these crafts to get to Eve and try to return home.
You mentioned that there's almost like a podcast thing. You also did our Ludicrous Future. What is there a podcast in your future? Are you thinking? Do you enjoy the medium? You're so incredibly good at talking. It's less effort to sort of to produce. Is that something in the back of your mind also?
Oh man, I love talking.
Yeah, said, and you're very good at it. I mean, yeah.
I find that it's just the problem for me with podcasts, and I guess the podcasts that I've done have tried to be relatively topical about like the current spaceflight affairs. Okay. And 3 or 4 years ago, that was actually, manageable for me to keep up with. Mm-hmm. These days, man, I just can't keep up with it. I gave up on trying to be super topical, and I realized that maybe my biggest talent and the things that resonate most with people is just trying to explain the basics and the root. So I'm really just trying to I'm trying to do less live streams if I can, but then again, like Starship, I gotta stream that. There's no way I'm not gonna do that. But I'm really just trying to get back to making the deep dive videos where I have no limit on how long and how deep and just really go for it, because that's actually what I love to do the best.
Yeah, I mean, that's views aside, those are just works of genius, and you're getting better and better at them, and that's in terms of the beautiful things you can create in this world, those are that. So if you continue, especially where the way space travel is developing, right, like that, your voice is very much needed. So I think it's wise to do what you do best.
And I think I'm feeling more and more, especially this last year, I did a lot of live streaming and traveling back and forth between Florida and California and here, and just handling major big live streams. Really stressed myself out. And at the end of the day, I was like, all of this is taking away from my ability to make videos. Yeah. And that's ideally, honestly, if I had my choice of things, I would just ignore everything else and just sit and lock myself in my house for a year and just sit there and make videos and go and travel every other month, for fun, not for space stuff. Just go and do some light traveling, some
around the moon or what?
Yeah, just some light traveling.
What advice would you give to young folks, or just folks struggling to find their way in life, whether they're in high school, college, or beyond, how to have a life they can be proud of, how to have a career they can be proud of? You've had a really interesting journey yourself. What from that can you draw? Give advice to others?
To be honest, I feel like it's so painfully obvious to follow your heart and follow what makes you happy, that I'm just shocked that people allow themselves to sit on mediocrity, to just sit there and be well, this is just what I do, and for a lot of people that's perfectly fine. I have, some of my best friends are clocking in and out and they're perfectly happy. They have a wonderful life. Absolutely no judgment there, of course. But for people that are stuck feeling like they're not sure of, what's next and how to bring light into their world, you really just got to listen to what does make you happy. People feel guilty about, I play video games for 8 hours. Then start learning how to make a video game. Learn how to do reviews of video games, or there's so many, you can work in the video game industry. You know, you don't have to isolate your love from your work, you know, and it's just funny that we, you know, maybe you feel guilty that you drink too much. Okay, I don't know if this is a good advice. Go learn how to make alcohol. You know,
start a liquor company.
Yeah, start a liquor company. I mean, maybe that's terrible advice.
No, it's great advice, but it's also in your own story. It seems like you've almost stumbled on, like, some of it is just exploration and keeping your mind and heart open to discovering that thing that grabs you. Right?
What do you fall asleep thinking about? You know, like.
But you stumbled on the space almost accidentally, right?
Yeah.
I mean,
kind of, yeah.
Like, would you, when you were being a professional photographer, would you have known?
Oh no. Well, do you want to know what I wanted to be when I was a kid?
What's that?
Well, first, when I was young, I wanted to be a tractor. I'm not quite sure I understood how that works.
That works.
Then I wanted to be a scorpion trainer.
Yeah.
Thought I could train them to cut people's lawns.
Better and better.
Yep. And then, honestly, the majority of my childhood...
People's lawns, got it. I think your understanding of physics early on was just a little...
the pinchers, man. The pinchers.
I know.
Then from like probably 6 until like early college, I wanted to be a prosthetic engineer. And never once did I think about anything rockets, really. You know, I had like a space shuttle poster. I had some space shuttle Legos. You know, I liked space and, you know, I knew of the space shuttle, but, you know, it was far down the list as far as things that I thought were cool. Ninja Turtles, Lamborghini Countach, B-17G Flying Fortress.
Yeah, I guess that
Music.
means if you just keep your heart open to falling in love with an idea, with a passion, yeah, you could start from that, from Ninja Turtles and Scorpions cutting lawn, to being one of the best, one of the top educators, inspirational figures in space, and actually traveling around the moon. And who knows, maybe one day stepping foot on the moon and Mars, even though you say you're not interested. It seems like you stating that you're not interested in certain things somehow results in you doing those things.
My friends joke that like I'm going to be the first person to go to the moon against their will.
Yeah. Like I guess. All right.
Yeah.
This is all right. What's the food
like? Guys, we're going to start a fundraiser. Please, like, Tim just doesn't want to have to. He doesn't want to go. You know.
Definitely don't want to do it. All right, Tim. You're an incredible person. Thank you so much for everything you do. I've been a fan of yours for a long time. Not just the content, but just who you are as a human being. Just how excited you are for everything. It's just an inspiration. You're a joy to watch. Thank you for being you. Thank you for doing the stuff you're doing. I can't wait to see what you do next, man. Thank you so much for talking with me today. That was awesome.
Thank you so much. It's my pleasure.
Thanks for listening to this conversation with Tim Dodd. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from H.G. Wells. Life, forever dying to be born afresh, forever young and eager, will presently stand upon this earth as upon a footstool, and stretched out its realm amidst the stars. Thank you for listening, and hope to see you next time.